Hello. First row, Lindsay. Okay, I'm going to give it one more minute, and then we're going to get started here. I don't really have a good stage presence, but I went rogue, and I'm not wearing any pink, which is kind of like a big deal for Uniswap. And I'm doing that because I'm the designer, so I have to wear black. But luckily, I have this very cool limited edition Uniswap gray hat that nobody else in the world really has. So I'm still representing. All right. Shall we? Okay. So this talk is going to be about Uniswap, about designing Uniswap. So just a little bit of context if you don't know what Uniswap is and you don't know who I am. So I'm Khalil. I'm Khalil, also Khalil.uni.eth. I'm the VP of Design at Uniswap Labs, which is the company that makes the Uniswap web app, makes the mobile apps, and all the things that we do these days. I've been working on the project since the beginning. I was the first person to work on it after Hayden, did all the prototyping, really early days kind of stuff. You might know us from this interface, right? The swap box. This is, these days, a very common interface that you see everywhere in DeFi. But I want to talk about why it just worked when we did it in the first place and what we're doing today to keep Uniswap just working. So a little bit of context of why this is important. So some numbers that these are rough, by the way, but 75% of new wallets visit Uniswap on their first day in crypto or Web3 or on EVM chains. And we see about 30,000 new wallets every day on the Uniswap interface. These are pretty big numbers. We think we want to get them bigger, but it means that we're often the first stop for people when they're experiencing DeFi and self-custody for the first time. Another really kind of cool set of stats from that little swap box is that the Uniswap protocol, which is not only the interface, but other ways of accessing it, since we designed it, has done some pretty crazy numbers, right? So that little box has afforded a lot of trading, a lot of innovation, and a lot of access to new tokens and new markets. Our goal at Uniswap Labs, our mission, is to unlock universal ownership and exchange. It's kind of a lofty mission, but we really believe in it. We're really trying hard to do it. And one of the big hurdles that you probably hear as you speak to people in this conference and on the internet and things like that is if we want to get to this end goal, right? Why is it so hard to make crypto experiences that just work? It's really hard. I know it firsthand. And I think when I think about this problem from a design point of view, I have a theory. It's kind of loose, but I'm going to try to explain it to you. And then I'm going to show you how we apply that theory and try to make products that are really cool. Okay, so this is the first Uniswap interface, V1. And it looks a lot like it does today. And that's actually, we're really proud of that. We think that's a great thing. This was a little bit of an aha moment for a lot of people when they were using it for the first time because it gave them a mental model for trading that they hadn't really seen before. But the only way that that worked is because the app itself was super, super basic, right? I mean, this is really reductive, but basically this is what the app dealt with, right? The ERC20 standard, the logic of x times y equals k to make swapping work, ETH send transaction, and MetaMask, okay? So the app itself had a kind of picture of the world that was very, very simple, okay? And because it had a picture of the world that was very simple, it meant that people who used it didn't have to hold very much context in their head, right? It made it so that the context that the app had to deal with also was very simple. And as we go forward into today, this is what the app looks like today, a lot of things have changed. And really what has changed is the context that the app lives within, right? If we rewind 6 years, there were no L2s, There were no, ENS wasn't really a big thing. There wasn't Wallet Connect. A whole bunch of things didn't exist yet. So over that period of time, what has happened is that our apps that we're building, all of a sudden, they start to model the world a lot more closely than they did back then, right? And what I mean by that is they have to start to bring into their boundaries things that are in the real world. So we're starting to cross over the edges of the closed loop logic that existed back in those early days. And this is really important, right? Because this is the kind of stuff that's going to make it accessible for people, across the whole entire world. And so when we design at Uniswap Labs, we really think about what it means to sort of cross over those edges. I want to kind of give you guys a reference point if you're interested in this kind of stuff, design theory, design thinking. There's a really cool book called Notes on the Synthesis of Form by this guy named Christopher Alexander. Christopher Alexander is an architect. He's written a lot of books, one called The Pattern Language. And in these books, he proposes that design is basically about synthesizing context and using patterns that people recognize together to make new things. And so basically, my theory about why it's so hard to make things in crypto that just work is because oftentimes we are given as designers systems that have logic that are closed, that are a lot are self-referential and don't really often think about things outside of them. And that's on purpose, right? That's what makes these systems safe. But at the same time, humans are not really like that. When I step in front of a computer and I bring my context, my fear of money, my fast-paced life on the train, I don't really care. I want it to understand my context and to basically deal with the complexity of everyday life. So good design understands the context outside of the scope of the technical system and an understanding of people's mental models. If you do this well, people come away with the impression that it just works. So, okay, this is how I feel sometimes talking about this stuff, right? So I will kind of rewind, and we'll get to the fun stuff now. But I just wanted to kind of leave you with that's how I think about things. That's how the team at Uniswap Labs, the design team, thinks about things. And we try to practice that in our everyday work. Okay, so how do we as a team make it just work? We eat complexity. We follow our principles, which I'll show you in a second, and we repeat and iterate. So what are our principles? It's really important to have principles if you're building products because it's hard to have conversations about what's right to do, what the right thing to do is if you don't. So have product principles. So these are some of them. There are more, but we want to build things that are secure. We want to build things that are fast and affordable. And also, we want to give people options. I missed that one. And then design principles, we want to make people feel connected. We want to make things that feel useful and that are approachable. So these are two sides of the same coin, right? Okay, so now I'm just going to show you cool things we've built using these principles. So recently, we just put out Uniswap usernames. I'm going to play the trailer and then talk about it for a second. Okay, so what are Uniswap usernames? Basically, they're a system built on top of ENS. I'm going to go really fast through this just because there's a lot to get to, but they're a system built on top of ENS that allow people to claim a human-readable name when they onboard via the Uniswap wallet for free. And where this came from was the design team observing people doing onboarding onto our apps and talking to them about their experience. And one of the things that we noticed when people were doing it in real life, especially when you were getting onboarded by a friend, is that people would download the app, go through onboarding, they would get to the screen, and often the first thing that the person who was helping them onboard would say is send me your address because I want to send you ETH, okay? All right, so now, if you don't know that person individually, you may not have their number to text them. How do you get them to send them your thing, right? You can pull out the QR code, blah, blah, blah. But if you're doing it in a remote setting where you're not in person with them, it's kind of hard to then have to explain what an address is, have to explain all these complex things. Instead, it would be a lot nicer if you could just say, hey, what is your Uniswap username, right? And then send them money that way. And so these are small things that we built to make it easier to get involved with crypto, easier to get started with Uniswap, that are derived from these real world contexts and insights that we had when we were designing these things. It's really cool because it also is extensible, so it kind of builds on top of some of the principles that Ethereum is built on and ENS is built on, and we're sort of like kind of just extending that a little further to make things easier to use, and out of it you get this really cool world now of all these different names that people can claim and ways that people can represent themselves without having to spend gas to do so. Okay, the next slide I'm going to go to is, I'll go back, is a kind of a longer video or a longer promo video of the stuff we've just released. And I'm going to play it. It's about a minute long, and then I'll just go back and walk through a few of the things and then try to do a little demo really fast. All right. So in that video, you saw a few things. I want to talk about extensions specifically because I think this is another case that represents this approach to design. So something that we noticed as we were looking at wallets out there, first of all, they weren't really optimized for swapping. Second of all, when we watched people use them, there was a bunch of context that we felt like developers who had made extensions that were pop-ups were missing. Namely, the feeling of having many tabs open, the switching back and forth between browser windows, and losing your place, basically. And so we developed the Uniswap extension as a sidebar to bring the wallet to you, help it go with you wherever you go, but also to kind of like solve this problem of this lost context that people often complained about using traditional browser extensions as we know them. We also, of course, are trying to do better and improve this situation. Like, I love MetaMask, I have a lot of respect for them, but we got to move on from that to this. All right, I think I have time. I'm going to try to do a demo of one last really cool feature that I don't think we've showed ever about the extension. And it has to do with what we're trying to do in the future with this suite of products, and also a representation of what it means to try to bring more context to the experience of using crypto in your everyday life. Okay, let's see if the demo time will work. So, all right, well, here is the onboarding screen of the Uniswap extension. Some of you might have seen this from the booth, but I want to show you a really cool experience that we've built that we think is one of the first times that like Uniswap has really made something magical with this new suite of products. So on my phone, I have the Uniswap wallet here. It's a wallet that I use to swap, very simple, right? And let's say I'm a user who just downloaded the extension, and I already have this app. What I can do is click down here, and I have the ability now to sync my wallets from my phone without having to copy and paste the seed phrase insecurely, kind of like deal with the complexity of all those things. And so on my phone here, all I have to do is scan this. Hold on, let's get it to focus. And I'm being asked basically to authenticate into the system. I get a one-time code to enter. So don't do this publicly, by the way, when you download this app. And then I have to make a password to secure my wallet on the extension. Right, ignore the demo bugs. But basically, in about under 1 minute, I've now got my wallet in my Uniswap extension, fully imported, fully working, with one scan and one OTP, and I can already go through and start to swap. So these types of experiences where once you start to have this suite of products and more context, you start to be able to do things between them and think a little bit more about like, what is the context that your user is in when they might want to set up an extension for the first time. And so one last thing just to show off about this extension and why we think it's really cool is that it does travel with you. So if I'm browsing Farcaster, for instance, and want to buy dgen, I can do that really easily just from within the sidebar. And it's really cool because it kind of becomes your companion a little bit more. And we think that, oh, I don't have enough ETH to swap. Sorry, demo fail. But anyway, it would work if I did, and it really becomes your companion to go with you as you sort of start to poke into these different apps, dApps, other experiences, news sources that might be the context in which you then choose to swap. All right, back to the slides. Okay, so a few more thoughts on context. We've been really working hard to understand better how the Uniswap apps are used in the world. This is something that we're really proud of that I think we don't talk about enough, but all of the apps that we put out in the world are fully translated with fairly high quality translations, but in a lot of languages and a lot of currencies as well. And we learned from looking at our data that Uniswap is a really global product. We do primarily have US users, but you'd be surprised at the distribution as you look across the different types of users that come to to our products. So this is something that we've really been focusing on, and we actually want to push way harder on it because we know that the context that people use their products in may not be, Denver, Colorado. And the last thing is we've been really working hard to bring a lot more change to Uniswap as well, to the apps, and more are coming soon. So this is a little taste of the latest things we've been working on, using those principles to drive our decision making. What we're working towards, just to kind of conclude, is this unified experience across web, Android, iOS, browser extensions, and more that uses the same design system, the same set of principles, a better understanding and a deeper set of insights about context and the way that people use these products in their everyday life. And we really think that this is sort of setting us up for a world where users may be able to kind of come and choose Uniswap and bypass all of the sort of centralized exchanges that people often come through first to get to DeFi. We're not quite there yet. We have a few more hurdles to get over, but we're working really hard to solve these in the next year. One thing that I think is really cool is that everything here, of course, is powered by the Uniswap protocol. It's getting stronger and more powerful every day. Recently, we released a version of something called Uniswap X, which enables swapping with no gas, which is really powerful, and it's something that we're actually going to accelerate on. So there's going to be a version of Uniswap that probably abstracts gas entirely. We're also releasing the ability to pay gas with any token very soon as well. So we're trying to tear down these barriers as we build out this platform. Coming soon, V4 is going to come out in Q3. That's a really big deal. Go read about it on the internet. Go talk with the Uniswap Foundation about it. A lot is happening. There's also some sneaky, hidden new features that are going to come to the extension and the wallets and the web app. But in general, our goal here is really to build out this platform, that understands people, understands the context that they swap, that they trade within. And we believe that that's going to result in a smarter way to swap. Thank you very much.
Okay, great. Awesome. Thank you for those of you who are coming out to listen to this fireside chat on verified USD and how they're leveraging layer 0 and a novel algorithm called color trace. To introduce myself, my name's Irene. I'm head of strategy at Layer 0 Labs. Layer 0 Labs is the developer company behind Layer 0, which is the leading omni-chain interoperability protocol, and also the original developers behind Stargate Finance, which is the most widely used native asset bridge. Matt, who's joining me today, is president of the Verified USD Foundation. Could you introduce yourself?
Sure.
Press it up.
Hi there. Yeah, Matthew Commons, president of the Verified USD Foundation. The Verified USD Foundation is the issuer of USDV, a omni-chain stablecoin, actually the first omni-chain fungible token stablecoin. It's a collaboration between Layer 0 on the technology side and Matrix Port on the operating side. So we've been live about 3 months, and yeah, really happy to be here today and share a little bit about what we're doing and how we can work with the community.
So to set the scene a little bit for people who are unfamiliar with USDV, Layer 0 Labs had been approached by a team that posed this question of how might we create a stablecoin that can share revenue or issue rewards back to its minters and subsequently the community that has helped grow it. And this problem is actually an age-old one. It's commonly referred to as the colored coins problem, meaning when you have one-to-one fungible tokens, how do you actually differentiate or store the traits and history of these tokens in a storage and compute constrained environment? For Bitcoin, there's this lossless metadata layer, but in an EVM environment, that would be an accumulation of addresses and information that is intractable in such a constrained environment. And this question was actually a very interesting one for us, a bit of a side quest compared to our primary focus, which is cross-chain infrastructure. But the outcome of it was this novel algorithm called color trace. And the Verified USD Foundation is the very first token issuer that's leveraging this algorithm. My question for you, Matt, is you previously were CFO at Algorand. You have spent much of your career in this space. When you first heard of the project, what drew you to this stablecoin in a competitive stablecoin landscape?
Yeah, so first of all, I have been a huge fan of Layer 0 Labs for a long time. I was one of the reviewers on the original Layer 0 white paper, got to know Brian Pellegrino and the team, and really was very enthusiastic about working with them, and kind of like followed Layer 0 for a couple of years. And this was so when Brian reached out last summer, I was immediately interested and flew out to Vancouver and wanted to learn more about it just because of Layer 0's background and reputation. But my interest in stablecoins, I've always liked decentralized systems, permissionless systems, and it always kind of irked me a little bit that we had permissionless systems, and then there are these two centralized private companies sitting on top of this as the major issuers of, $100 billion plus worth of stablecoins. That is really like a key component of the decentralized economy. Like if you're going to be decentralized, why do you have, these huge points of centralization there? So, was interested in the concept of how to do it, and coloring the coins makes sense. Like if you can color the coins, then you can attribute value to the underlying, to the parties who brought capital into the system, and share yield that way. But from a technical perspective, it's really never been possible to do that. If you have multiple different colors and you have one wallet, the complexity increases exponentially. So using a conventional, just kind of tagging each coin with with some additional data, that was not going to be scalable in doing it. So Layer 0 solving the colored coins problem was really key to unlocking this, and was immediately intrigued by it.
Yeah, to set the scene also a little bit for those listening, this isn't the first time that a team tried to share value back to their contributors. So if you look at Coinbase, for example, I believe last year Circle formed a very special partnership with them in which it now attributes to maybe $1 billion in value back to Coinbase every year. And so for all of the growth that Coinbase contributes to USDC and the volume across our ecosystem in centralized exchanges and elsewhere, they are sharing in the rewards of this. However, if Circle wanted to then share with, say, Uniswap, PancakeSwap, all of these DEXs for whom they attribute most of the growth of stablecoins in, say, like the BNB ecosystem or other L2s, there isn't actually a way to do this fairly and on-chain. You could perhaps trust off-chain that there might be some sort of marketing fee that's paid back to these protocols, but if it's not verifiable and on-chain, once again, it's almost like trusting your credit card company to give you points for what you have purchased with the card. So the problem is actually a really challenging one, and I think from an ethos perspective, the idea that protocols should actually be fairly rewarded for the growth of stablecoin ecosystems resonated really deeply with us. I think that monopolies are very prevalent within our industry, and for decentralized technology to actually properly thrive, there has to be competition. So my question for you then is, USDV is not only a stablecoin that is revenue sharing from the yield that it earns through short-term treasury bills, which are the current collateral, but it's also an omni-chain token. Can you talk a little bit about the product and in market, how it changes the experience for developers and then also for users?
Sure, absolutely. So, there are really three main differentiating features about USDV. One of them we talked about already, the color trace algorithm, which allows us to share the yield of the underlying collateral equitably in the ecosystem through our partners who mint USDV. But there's two more. Another one is the on-chain transparency, because we actually have our collateral locked on-chain and really best-in-class auditing, chain-link proof of reserves, et cetera. Then the third is what you mentioned there, Irene, which is we are the first stablecoin to use Layer Zero's omni-chain fungible token standard. So what this means is that all USDV is effectively born on ETH mainnet, because on mainnet is where the collateral in the term of the STBT treasury bill token is locked up. $1 of the treasury bill token stands behind every $1 of USDV. But because we're an OFT, there's a very straightforward way to burn USDV on ETH mainnet and then remint it on other chains. So today we are live on 7 chains. So mainnet, Arbitrum, Optimism, Polygon, BNB, Avalanche, and a Southeast Asian focused chain called Viction. But as you know, Irene, Layer Zero connects to over 50 different chains today, with more on the way, EVM as well as non-EVM. So when we look at the roadmap and expansion, we want to be native on more chains than any other stablecoin. I mean, today we're on 7, and the other big players are on 15. But we anticipate that sometime later this year we will pass by them and we'll never look back.
One of the unlocks of the OFT standard, omni-chain fungible token standard, is that once you have deployed this contract, you can, under, say, 15 minutes, or as easy as deploying an ERC20 smart contract, expand to new chains. And these addresses are the same. There's unified liquidity. There isn't a need for, say, pools or external LPs to enable this seamless horizontal composability. So take, for example, a stablecoin on Base, and a user who wants to now move that stablecoin to Arbitrum. Typically, you would have to do the 7-day bridgeback period, and then from there, use the native bridge back to Arbitrum. With Layer Zero's OFT, you can pay in one click with one gas token and go from L2 to L2, or go from point to point within this mesh network. So for USDV, Viction makes a ton of sense. There is actually product market fit in Southeast Asia to launch on, say, Clayton, which is a very popular South Korean chain, or many others would take 15 minutes, say. And I'm curious, how are you guys thinking about the prioritization of different chains?
Yeah, so there's a few different ways, or a few different kind of data elements that fit into how we prioritize chains. So by far the easiest from a technical perspective are EVM-compatible chains where there's an existing Layer Zero endpoint. As you said, deploying an OFT is very easy. And then sort of within that universe, it's then a question of, we want to have some type of basic functionality on the destination chain. So, we'd like to have, some kind of a DEX as a partner that can be minting so you can get into and out of USDV. To the extent that there's not a bridge already, we'd like to have a bridge in place. and then moving towards having borrowing and lending. So it's really just sort of, can we get critical mass? We're limited to 7 chains, not because of any technical reason today. It's just, hey, is there interest? And I think here at ETH Denver, we've had a huge amount of interest from, a number of chains, EVM as well as non-EVM. Again, non-EVM, it's a little more of a case-by-case basis, but I think if you look at Layer 0, they do have a number of non-EVM endpoints, more to come, and that's definitely part of our growth plan.
And for protocols, if you implement USDV or you list it, effectively how this works is your protocol is assigned a color. So let's take, for example, Uniswap. Any minted USDV or other stablecoins swapped into USDV would be colored pink, let's say. And even if these tokens leave the Uniswap protocol, they're sitting in some EOAs or they are inserted into some other protocol, so long as that token is colored pink, the yield is perpetually shared with Uniswap. It's about 2.5% or half of the short-term treasury token yield. And this means that you are effectively rewarded simply for the proliferation of these tokens in the space. Now, when there's some other protocol that has also registered as a colorer, if these tokens end up in their protocol, let's say it's Rainbow Wallet and their color is purple, they can pay a one-time fee to recolor and then get all of the yield from there on forth. So it creates almost an arena-like dynamic, which incentivizes, again, the growth of the stablecoin, but also the fair reward distribution verified, again, on-chain. This week, what have been the questions or the curiosities that have surprised you from developers who are asking you about USDV?
Yeah, so I think, first of all, I think a lot of people have kind of gotten it. When you kind of spend a few minutes and sort of explain this idea of yield sharing, hey, it's not yield to the end user, but it's yield to the protocol, they can reinvest in the ecosystem, people get it, and there's like the light bulb goes off, and they're like, wow, this is the way that these things should be done. So we've had an enormous amount of positive feedback from it that's been really encouraging. Some of the typical questions we get, around how yield sharing works. So we'll kind of walk through, some elements of that. One thing I would highlight is that, 50% is sort of the floor of what we share with the yield. The other 50% goes to the foundation, but the foundation, again, we're a nonprofit entity. Our, mission is to encourage the USDV ecosystem. So a lot of times we'll work with the various DeFi protocols. In addition to the 50% of the underlying yield, we'll do some other type of emissions or matching incentives or things like that. Usually it's on a one-to-one basis, that the protocol or the partner will be putting up $1 of incentives, and the foundation will do that as well. So it can certainly go significantly above 50%, especially in the early days. I mean, a lot of the times we're trying to allocate this in areas where we think it's a good fit, and we want to make it grow, and incentives are a part of that.
And one of the key things, too, about distributing yield to the minters rather than end users is the issue around securities. And I'm curious, or would love to hear you expand on this a bit, having also been CFO at Algorand. Many lending and borrowing protocols are hesitant to list some of these next-gen stablecoins that directly issue yield to holders. It poses an enormous security risk. In this way, it is a particularly creative and novel mechanism to still reward contributors to the ecosystem. Could you just speak a little bit about that and how that's resonated?
Yeah, sure. So our underlying collateral token, we're using, as you mentioned before, Irene, something called STBT, or short-term treasury bill token. It is issued by an orphan trust that has no owners except the token holders. But it's really something that it is a security. It holds treasury bills. The treasury bills pay interest, and the STBT token pays interest. It rebases every day, including on weekends. So what that means, since it is a security, you have to be whitelisted, you have to be KYC'd, and at this point, it's only open to non-U.S. investors who are also meeting the qualified purchaser definition. So, which is sort of an asset financial threshold to show that they're sophisticated enough to do that. That's just where we are right now. So we don't have any minting in the U.S. You have to be non-U.S. entity, and you have to be able to do that. We hope that changes in the future. There is a stablecoin bill. There's a lot developing. Obviously, we're a USD stablecoin, and the U.S. is the largest crypto market. So, we'd like to have more active participation onshore in the U.S. We just need more regulatory clarity in order to do that.
The whole foundation is spending a lot of time in different regions, and I think over the last few months, there was also Stable Summit this week, a lot of conversation around where there's actually product market fit. What is an area of intrigue, and what kind of evidence has supported the foundation's investment in these spaces?
Yeah. So, as you can see, I mean, with our existing partner set, we've started with CeFi and DeFi, and that is definitely the place to start. It's quick. We can meet people here, say, hey, get on our chain, partner with our DEX, and it's a very, very quick process. We do some KYC, we sign a very standard form contract, and boom, you're set up as a minter, and we go. But really, the long-term growth, we see stablecoins in general, and certainly USDV in particular, extending well beyond just CeFi and DeFi, and really being used for payments, for savings, for remittances, other types of things. So there's a lot of interest in emerging markets. Really places where people don't have like Venmo and PayPal and an FDIC insured bank account in their pocket.
Can you name a few of these places that you visited?
Yeah, sure. So Argentina, for one, is particularly interesting, and we've got a very crypto-friendly libertarian president there now who's making a lot of changes. This is an economy that 10% of the physical U.S. dollars in the world are in Argentina because people don't trust the banks. They don't trust the government. They've had very bad experiences with their dollar bank deposits being seized and devalued in the past, and people buy houses with stacks of $100 bills there. There is interest and real usage of stablecoins there today. Tether on Tron is kind of the largest incumbent right there now. But we believe that our partnership model, where we can share the yield back with partners in Argentina and other countries, is useful. So Argentina is probably a good example of like a hyperinflationary economy and why that's interested. Turkey is interesting as well, but lots of other emerging markets. Vietnam, we mentioned with what we're doing with Eviction. 100 million people, very young population, technically savvy, but also kind of underbanked largely in the conventional sense. Huge opportunities there and around the world.
As we're nearing up on time, and I want to try and reserve about a minute in case there are questions, what is a parting note here for how developers who are learning about USDV this week can engage or experiment with implementing USDV?
That's great. Well, we're over at booth 302, so that's kind of by the Polkadot and Near pavilions, just off of the Rainbow, next to Uniswap. So you can find us over there. USDV.money is a good place, and then from there you can find Twitter and other places. So yeah, but thank you so much, Irene. This was great, and
I think
really
a parting note from my side is having been deeply involved in the creation of the color trace algorithm, there are other novel things you can do with it too. I was just speaking with one of the most widely used trading platforms, and they have always wanted to do on-chain ref links. How can you replicate the experience of referral links through, say, a centralized exchange, but now through a DEX or a trading platform? I'd love to see color trace implemented in a novel way in that regard. And then with USDV, the kinds of protocols and products that are best suited for this model are anything that has high throughput of stablecoins going through it. Those are wallets, for example. These are DEXs, lending and borrowing platforms. Some of the protocols that you guys already work with are Frax, Venus, PancakeSwap, wallets like Beam by Eco, some omni-chain wallets as well, and then on centralized exchanges, BitGet and a few others. So I'm keen to follow on in the progress. We're certainly really excited to see color trace used by developers right now, and thank you guys for coming. We have time for a few questions, so if you have any, please come up to the mic here, and you can also find us after.
So you mentioned that the stablecoin industry is dominated by two players, and we would like to see more competition. How many different stablecoins do you think the market could bear in the long term?
Yeah, I mean, we see a lot of different types of stablecoins out there now. I think, there's kind of algorithmic stablecoins, which are, I would say in a different category than, treasury-backed stablecoins. And algorithmic stablecoins, it will really depend on the platform. And we partner, actively with those. Frax is one of our launch partners. We want to be part of collateral of others. So, so algorithmic stablecoins, it's sort of, dependent on the number of successful DeFi protocols. For treasury-backed stablecoins, I think it's probably a smaller thing. Up until today, really table stakes where you had to be really big. So Tether, Circle, you had Binance in there for a while, PayPal now. You know, you've had to, in order to play in the game, you've had to have really heft in order to do that. What USDV allows is it allows partners to participate in the game, to share in the yield. They don't necessarily need to have their own stablecoin. They can get the benefits of economies of scale, fungibility, and so forth through partnerships. So that's kind of where we see the growth going forward.
Yeah, it can be very meaningful for protocols. If you take a look at PancakeSwap, for example, I think they make it's between 10 to $20 million a year, and yet the volume or the amount of stablecoin growth that they've accounted for is several billion. And with USDV, if they effectively convert many of their users to using it, it adds several $1 million to their bottom line. My point of view is that there are a few different angles. One, certain stablecoins serve different purposes. So algorithmic stablecoins are often used by like DeFi power users, and that will always be the case. Maker, for example, is launching a new stablecoin as well. That's something to watch, and I think their like target demographic is very different than, say, the demo of USDV, perhaps. And when you're selling a stablecoin, you're selling trust. I don't actually think that the market will be able to mindshare-wise sustain 15, 20 stablecoins. The real chain abstracted future in my mind is wallets and dexes that abstract away even like the tickers of different stablecoins. It just ends up becoming like an intermediary. It's something that's just pegged to a dollar. And so you could swap, say, USDT for USDV without performing the actual swap. It adds so many clicks into the process in which you're really just trying to send value to someone elsewhere. So the next few years will be interesting because there are very exotic stable coins, and we'll see if they're stable. But I really think the mindshare piece and the fact that you're selling the idea of trust is a scarce resource.
Great. Well, thanks so much, Irene. Really appreciate your time here and doing this. And yeah, looking forward to continuing our collaboration.
Amazing. Thank you guys so much.
just ask if you're doing any Q&A, just have them come up and talk into the mic. Sometimes I like to
Maybe I can raise the question, or get them to come all the way up.
Yeah. So we have a microphone right here that's just set up for the Q&A, and then we have it like on the stream and everything. If people are just screaming out.
Fair enough. Okay.
Yeah.
Thank you so much.
We still have.
Good morning, friends. Oh, this microphone is loud, and I speak really loudly, so I hope you guys are all excited to hear about some of the top themes for 2024 for Filecoin, which is the decentralized storage layer of Web3. We're just going to jump in and get started. If you're not familiar with Filecoin or what we're trying to achieve as the decentralized storage layer for Web3, this is the Filecoin master plan. Step 1, build the world's largest decentralized storage network, which we have done. We actually did that in the first year after Filecoin mainnet, which was very exciting. We have thousands, I think over 3,000 storage providers globally around the world who are building on Filecoin across 40 different countries with 10 exabytes of storage capacity. Step 2 was to onboard and safeguard humanity's data. And we've been working on that, very focused for the past couple of years. That continues to be a key focus, bringing many, many different users and clients to store their data in Filecoin. And then step 3, which kicked off last year with the launch of the Filecoin virtual machine, is to bring compute to the data stored in Filecoin to enable web-scale applications to be using decentralized storage. So just in the past year, we've seen an immense amount of growth in the client data stored on Filecoin. I think we're now at over 2 exabytes of data stored in Filecoin, which is just kind of a shocking, huge number, and serving many, many different clients, from research to education to nonprofits who are storing their dark matter research data on Filecoin. CERN's Atlas project is storing all of their neutrino data on Filecoin. And there's thousands of clients and data sets that are trusting Filecoin with their critical storage data. Also, I mentioned last year, just under a year ago, we launched the Filecoin virtual machine. This unleashes a whole ton of new capabilities for people to write smart contracts and applications that are orchestrating and programming the storage within Filecoin. This is all EVM compatible, so you can port your existing EVM smart contracts to Filecoin, upgrade them with new Filecoin storage capabilities, and start building new interesting applications that were never possible before because you couldn't offload storage into Filecoin. We've seen a whole ton of really, really cool applications being built. Lighthouse and NFT.storage have been working on perpetual and automatic storage contracts where you can program the renewal of your data storage over time. We have compute networks and Gen AI networks that are kind of monetizing data sets or computing over data sets stored in Filecoin. We have CDNs that are doing fast, efficient content retrieval from Filecoin. And we have really interesting DeFi loan markets, which have been helping bridge the gap between Filecoin token holders and Filecoin storage providers who need collateral to secure their data in the Filecoin network. And so we've seen just truly massive, unexpected growth. We're now top 20 TVL of all chains, still growing at about 50% month over month, which we're almost a year in, and we're still growing at that rate. It's really, really amazing. And you can see there's a huge community of folks who are depositing Filecoin so that storage providers can use that as collateral, and many, many, over 872 storage providers who are borrowing Filecoin so that they don't have to build up a massive Filecoin war chest before they can come and bring their capacity to the Filecoin network to store client data. So I'm pretty impressed by that. I think it's been some really amazing growth for the Filecoin ecosystem. But really, even more importantly than vanity metrics like TVL are the builders and partners who are bringing their applications and their capabilities into the Filecoin ecosystem. There's over 200 teams that are building on Filecoin across bridges, oracles, staking exchanges, and lots of really interesting data DAO or data-oriented use cases as well. Just some of the recent launches include SushiSwap and Uniswap, who have been bringing their DEXs to the Filecoin ecosystem, which kind of enables a lot of new kind of like cross-chain or asset swapping applications in FVM. And again, I think that this is going to continue growing massively. One of the things that FVM and that sort of capability unlocks is powering compute over data networks, powering DPIN networks, and helping build new layer 2 networks that are building upon that FVM layer in Filecoin. So this unlocks a new phase. Previously, we had Filecoin as a storage network. With FVM, we kind of upgraded with new applications and new programmability, and now this is unlocking a new wave of layer 2 scalable applications that are building on Filecoin storage and upgrading it with new capabilities, compute capabilities, database and hot storage-oriented capabilities, retrieval capabilities, and a lot of these are building upon Interplanetary consensus, which is a framework for building these planetary scale applications in Filecoin. One of those actually has already launched. I think a huge round of applause is deserved for Fluence, who actually announced their mainnet on Tuesday as the first Filecoin L2 building on IPC that's already live and out there, which is awesome. So if you haven't heard of Interplanetary Consensus, it's a scalability solution specifically designed for large-scale, infra-intensive applications. It is designed to be highly scalable and hierarchically scalable. So instead of, everything's going to be an L2, and that's as far as we get as an ecosystem. This is designed for recursive scalability and for subnets that are highly tunable. They can be application-specific. They can have their own specialized built-in actors. They can have their own consensus algorithms, and they can shard progressively depending on their application-specific needs. So that might be having a gaming subnet that then has subnets within it for different games. That could be having geographical region subnets where only nodes within a certain region are able to join that subnet, thereby enabling you to have really fast block times because nodes are much closer together and able to interoperate more quickly. And you can also have things like deeper infrastructure services. One of the reasons we're coming to Interplanetary Consensus as a critical tool is that we've been working in this infrastructure-rich DPIN network space for years and years and years now. Filecoin's been live for 3.5 years as kind of the first large-scale DPIN network out there. And so IPC is really designed and optimized for helping those networks come and scale very quickly and reach the sort of massive scale that infrastructure networks need as they're growing. I mentioned that subnets are very, very customizable. This is thanks to the kind of structure of the FVM as a hypervisor. I mentioned FVM is EVM compatible. That's because we literally have the EVM running inside FVM's hypervisor as the first runtime. But you can add additional runtimes over time. Aqua VM is the one that's used by Fluence, and so you can bring in additional runtimes as desired within different subnets. You can deploy your own custom WASM actors. FVM is all WASM based under the hood, and so you can have specialized WASM functions that you deploy within a specific subnet. You can bring your own runtime, you can bring your own native coin or token, and it all has kind of your own configurable consensus layer within that as well. So it's designed to be very configurable, but it's also designed to make your life easy so you can get up and running quickly. This is really tuned for kind of large-scale service networks. These are things like compute networks, like Fluence, that are already getting onboarded and then can interoperate smoothly with Filecoin's network of thousands of storage provider nodes, also running compute nodes right next to that existing storage so that they can run compute jobs over the storage in Filecoin, output the result of their compute jobs into Filecoin storage and interop smoothly there, but also things like hot storage layers, CDNs, indexing engines, retrievability networks, and more. So I really do want to celebrate the fact that we already have the Fluence mainnet that's building on top of IPC and building as a Filecoin L2. And I want to seed something for anyone else out here in the audience who might be working on, prototyping their IPC network or coming to Filecoin as an L2. The Fluence team, I think, took a great step forward from kind of a public goods perspective, committing 5% of their token supply to funding public goods as a retro PGF for developers who have been participating and contributing to things like Filecoin and IPC and other building blocks. You can go and check this out. You have to have public SSH keys on your GitHub profile in order to claim as a nudge. So not everyone, if you don't have that configured yet, then you're not yet eligible for this airdrop. But I think it's a really great standard that we should be applying across all crypto ecosystems, and especially for Filecoin, across all Filecoin L2s, to set the standard that these networks are also contributing and giving back to the immense community of developers, ecosystem builders, tooling providers, infra providers that operate in this ecosystem. This really should be the standard for all networks. So as we bring more and more DePIN networks to Filecoin, more and more compute networks to Filecoin, I think we should be, in general, creating this strong community and giving back mindset that kind of helps tie these many, many ecosystems together, because many of them do get to share the capabilities and new unlocks that they're bringing into this ecosystem. All right, so that was theme number 1. Filecoin L2s powering compute over data and DePIN networks. Theme number 2 is Filecoin as the storage layer for Web3 in particular. So this is, looking at the data layer of blockchain architecture. We already have libp2p, which is pretty standardized as your networking layer that's used by Polygon and Ethereum and Polkadot and Filecoin and every other blockchain network. But really helping rebase all of Web3 so that we're not having centralized AWS archives of all of our blockchain data, and we're instead utilizing decentralized storage networks for that. As you might have seen earlier in the presentation, we've already seen massive adoption from kind of Web 2 archival and research use cases, storing their massive, very large-scale data sets on Filecoin. CERN is, I think, the largest data generator on the planet. It's generating something like exabytes of data per year. It's pretty cool. We're now talking about making sure that the tooling and the ease of use in Filecoin isn't just tuned for very, very large data archives, but is really tuned for Web3 developers and Web3 chain archival solutions, so that the Web3 ecosystem can be efficiently relying on Filecoin as its decentralized storage layer. I think there's a great example of this just from the past year. The Triton team, Triton 1, worked very closely with the Filecoin chain store team to onboard and store all of the Solana chain state on Filecoin. There was this big frustration where whenever they had new nodes bootstrapping into the Solana ecosystem, or they're experiencing some chain instability and they needed to reload their chain from Genesis, it cost every node provider thousands of dollars to refetch all of the chain history from Infura, RPC APIs, so that they could reload their nodes and validate their state from Genesis. And so there's an awesome collaboration here to load all of the Solana chain archival state onto Filecoin. They structured it as an IPLD graph so you can retrieve subsets of that block data over time. And as you can see, was really well received as a great step forward and exemplar for the entire Web3 ecosystem, because this can now power and be a public good for entire blockchain communities for things like, powering RPC APIs or enabling indexing solutions or enabling dApps that just want to, onboard, index, and operate over top of historical chain state. So awesome to see the reception of that. So we have a couple of chains that have already been onboarded in terms of their blockchain state and history. We have a couple of collabs work in progress with folks. Been chatting with folks here, Avail, Near, Say. And then we have some folks that I have on my wish list as next up for who we plan to work with to bring their chain state to Filecoin. If you're excited to get yourself added to this next up list, we'd be happy to collaborate with you. We kind of have a 3-step process right now of pulling all chain state and storing it in Filecoin, then doing a deeper dive IPLDification, a structuring of your chain data state to make it highly accessible and indexable, and then kind of the ongoing hook from like Web3 ecosystem to ongoing every block by block, bring that into Filecoin. So we've talked about Web3 chain state, but what about the large-scale data that isn't stored in the chain state itself, but is highly interconnected and interoperating? And I think a great example of that is the larger-scale DePIN data that is being created and referenced on-chain, but isn't actually stored in chain state directly. And so the collaboration between Textile Basin and WeatherXM is a great exemplar there, where they have all of this large-scale weather data that's been being created, and Textile Basin work to index that, onboard it on Filecoin, and is working on scaling that solution as a more decentralized layer 2 style operation where you can just have kind of ongoing DPIN data storage on Filecoin, which helps make WeatherXM and these other DPIN networks more robust and resilient, and also lowers their costs for keeping all of this large-scale weather data around and accessible for their community to build on and power their explorers and applications. So if you haven't heard of Textile Basin yet, there was a really great event yesterday called Proof of Data Summit where I think Marla gave a pretty good talk about decentralized object storage. This is a really exciting kind of new innovation. If you know about Tableland, which is also from the Textile team, it's a kind of like S3 database indexing solution for things like mutable NFTs. This is taking those same lessons of the kind of like bucket model and S3 API model and bringing that to Filecoin archival solutions for DPIN networks. And so this team has a ton of experience in the space, and I would really recommend if you are a DPIN network out there, get in touch with the Textile team. They are actively looking for early users that they can co-design the right APIs and the most efficient solution with. We also have some really exciting work happening on the kind of storage aggregator L2 space. So these are groups who are actually utilizing the same building blocks of IPC that are powering Filecoin L2 compute networks and other networks to offer hot, fast storage aggregation and caching for networks. So there's a great team that's currently called W3S, or the Decentralized Web3 Storage team, that's combining the ease of use developer APIs that many people have used in Web3.storage with the L2 content caching network of Filecoin Saturn to create a hot, fast data storage, object storage layer for smart contract developers or builders who want just like really simple, smooth, easy to use hot storage APIs to Filecoin. And it's utilizing all this same IPC technology to get up and started. A number of groups, if you are a smart contract builder and you want something that works and works well today, Lighthouse has a lot of great storage contracts that are already up and running. They have proof of data inclusion in Filecoin deals. They have a lot of great like programmable access controls and a lot of repair workers that allow you to do that configurable. I want this stored in with this many different storage providers in these different regions, and I want it repaired over time. And they're also leaning into that, okay, how do we utilize technologies like IPC to help bring that as a hot storage layer for Filecoin. And if you don't want to worry about any of that and you want more of the custom partnership, I just want to partner with an amazing group to help me get onboarded. Banyan just opened their open beta a couple of weeks ago, and they'll do kind of a more custom deep dive onboarding partnership with different groups and have a pretty slick UI for storing data in Filecoin. So high level point, there's a lot of really amazing hot storage solutions focused on Web3 as an ecosystem that are growing and improving themselves in the Filecoin ecosystem right now. And if you're excited about using them, come talk to me and I will route you to the best one for you. Excited to make those connections. All right, so I'm almost out of time, but can't leave you before also highlighting some of the amazing economic growth of the Filecoin ecosystem as well. We'd mentioned how DeFi was scaling, but also we have some really exciting work around new paid inbound activity in the Filecoin ecosystem, where we have more applications, more users, like all of these Web3 chains, paying for their Filecoin storage at scale. So that's more export of value into the Filecoin economy. We also have a chunk of work right now on reducing OpEx for groups like Filecoin storage providers. And then DeFi is helping scale the number of internal businesses in the Filecoin economy. And that's pretty awesome to see because this is helping grow and scale all of the kind of internal ecosystem applications and use cases within Filecoin. To highlight the three that I was mentioning here, there's a lot of work right now landing in the next network upgrade that have improvements specifically for storage providers in Filecoin, but there's a couple others that generally kind of reduce OpEx costs for those participating in Filecoin, helping us devote more of our time and energy to growing our applications directly. We have a number of paid users coming to Filecoin. I think the D-Store onboarding flywheel just closed their first petabyte enterprise enterprise paid storage deal. I think it was something, at least $5 to $8 per terabyte per month for a hot storage copy and an archival copy, which is pretty awesome. And we have better and better retrieval metrics being used as well, so that users who want to expect hot, fast retrievals from Filecoin can have a good reputation system for figuring out who to work with in the ecosystem. And then I'd mentioned we have a number of DEXs that are now live, and the DeFi ecosystem in Filecoin is just kind of booming in response to that. Another enabling factor we have coming up in Q2 is what we're calling fast finality for Filecoin, or F3, which enables fast block times. I think it's single block time finality within the Filecoin ecosystem, which enables much faster cross-chain bridging, much faster user interaction and interoperability with DeFi protocols. So you can get much faster confirmation times. You can do much smoother interop between Filecoin and other ecosystems. So that's going to be pretty exciting, both for, say, hot FVM use cases that are pulling storage from other networks, or for kind of more financial and DeFi-oriented applications. Awesome. Well, that's my highlight of the things that are happening in Filecoin land. Excited to work with everyone here to make Filecoin better together. And if any of you want to stick around a little bit longer, you can come to the Filecoin booth, which is literally just right there, for a great AMA with Juan Benet, the creator of Filecoin, I think starting at 11:45, so in like less than 10 minutes. So I'm happy to take a couple of questions if folks have them, and then happy to chat with folks as we walk the 10 meters to the booth together. So thank you guys so much. Anyone have any questions? If so, if you could come to the microphone, that would be slightly easier so that the recording can hear you.
Hello. So a lot has happened in the last 10 years with Protocol Labs and Filecoin. I'm wondering, it could be personal or professional, what are you most proud of?
I think I'm most proud of the amazing builders in the Filecoin ecosystem. There's just a really phenomenal community of all of the groups that are building tooling, hot storage layers, protocol improvements. It's just a pretty special community. Everyone is very collaborative and friendly, and innovating, like building really, we have like a number of L2 networks that are all kind of going to market in the next 6 months. And those are folks who started from hackathons during the ETH Global HackFS back in summer of 2020, when everyone was in COVID lockdown. This group of builders was getting together, started to hack on Filecoin even before Filecoin mainnet launch had happened. So think really rough APIs. Half of the things didn't work very well yet. And this group got started. We now have applications like Huddle01 that got started in that hackathon. We have Lighthouse, which I think got started either that year or the HackFest the year after that. And so there's just an amazing builder community, and that's, I think, what I'm most proud of, and what keeps me alive and thriving and happy in this ecosystem is getting to collaborate with all of those amazing folks. So if you are not yet in the Filecoin ecosystem and want to join the ranks of some really phenomenal humans, come talk to me, because that's also a thing that I work on kind of at the core protocol dev layer, is helping more folks get onboarded, involved, and making improvements to Filecoin to power their use case or their application. So that's what makes me happiest. Any other questions? If not, I will descend into the ranks, and we can wander over to the booth together. But thank you all so much. Appreciate it.
Testing. Oh, cool. Hello, everyone. I'm going to keep this short because I'm deathly afraid of public speaking, but I think that this is a good idea that needs to be out there, so I'm going to do my best to present it. Hopefully next time someone else can present this idea on the idea's behalf. My name's Billy. I've been in crypto for a really long time. I started something called Intuition, and what we're doing is we're building towards the trustful interaction layer. And during this presentation, I'm going to explain what the trustful interaction layer means to me and why it's important. So in order to understand the trustful interaction layer, we need to kind of understand the core primitives of Web3 and what we're doing in Web3. So Web3 is kind of rooted in this idea that we should migrate from subjective trust systems to objective trust systems. So instead of needing to do things like rely on humans every step of the way, what if instead we could kind of codify logic and codify rules and have kind of some sort of certainty that the rules would be upheld in the system. So I think that that's like an objectively good thing, and it's kind of a correct design decision for society, or at least it's a powerful tool for us to have in our arsenal. But right now, the Web3 experience is kind of broken. And it's broken for a lot of reasons. But one of the reasons I think it's broken is because in the absence of trustful interaction, trustless code is oftentimes a bug and not a feature. So an example of what this means is like, I kind of like to have the ability to reverse charges on my credit card. Or when my identity gets stolen, I like to have someone there who can like help me figure it out. And when we're dealing with objective trust systems, even though they're really great for a lot of things, if we interact with the wrong things, we kind of get screwed. And what we see right now, like the Web3 experience right now is new user comes in, they interact with the wrong things, they immediately get scammed, they lose all their money, and then they're disillusioned and they don't come back for 5 years. Even me, I've been in crypto for over 10 years. Like, I still don't have a lot of trust when I interact with things. And so I interact with like a very limited number of things in Web3 because it's just like, it's not very trustful. Like every step of the way, there's 800 different pitfalls. And so it's really scary. And so if it's scary for me, I can't even imagine what it would be like for someone brand new to the ecosystem. Like they probably don't even know Ethereum exists. They don't know that MetaMask exists, that there's Uniswap, that there's OpenSea. They come in, immediately get phished or something, and just have a horrible experience and then probably never come back. And so like this can't be the experience if we want mass adoption. Like this needs to change. And so what I think we need to do is we have to build this trustful interaction layer. So before you even get to the point of interacting with trustless code, you have to still interact with these subjective trust systems. And this layer of the stack, we can't really make it trustless yet. And so what we have to do is we have to make it trustful. We have to like add more trust instead of removing trust from the equation. Because we like maybe at some point we'll be able to do it, but we can't do it yet. And so what is trustful interaction? So, sorry, coughing. So basically, before you get down to the level of interacting with trustless code, you have to trust a lot of things. And you got to trust people at every step along the way. So you have to trust that you're installing and using the correct software. And then you have to trust the devs of that software. And then you have to trust that that software is free of vulnerabilities. And you have to trust that you're navigating to the correct URLs and interacting with correct and secure smart contracts and buying the right things, whether it's like tokens or products or whatever. And you have to make sure you're getting involved in the right ecosystems and finding the right communities and connections. And so this is like there's so much that needs to happen before you even get to the point of like hitting a smart contract and interacting with trustless code. And we need like way more attention on this layer of the stack. And so how do we make it trustful? Well, we kind of have two options. And it's not really two options, it's kind of a spectrum, but I'll frame the spectrum using the extremes. So on one side, we got like the centralized approach. And the centralized approach is opinionated gatekeepers telling you who and what you can or should interact with. So just like a entirely curated user experience. So let's say you're on like Coinbase mobile wallet and they're like, oh, here's the 5 dApps that you can or should use. Like that probably prevents you from interacting with the wrong things, but it also puts Coinbase in a very strong position of power to kind of curate your Web3 experience, which isn't really what we want in Web3. And so the other extreme is the decentralized approach, and kind of what I think is happening right now, but it's not really structured. So what happens right now is like the social fabric of society kind of tells you what to interact with, and it's like this conversational dissemination of information, and like the data is very unstructured if it even exists in the first place. So it's happening at the conference and it's happening on Twitter, and you kind of like learn what's going on. You're like, oh, this thing seems trustworthy, so I'm going to interact with that. And I think that where we need to land is somewhere that's kind of in the middle of the two. And it's kind of this happy path that like one kind of allows us to leverage the wisdom of the crowds, but two also doesn't like give any one person or group too much power. And so there's a lot of things that need to be built at this layer of the stack. But we're focused on 3 things that I wanted to talk about today. So one is more useful and holistic expression. 2 is actual usable data. And then 3 is a decoupling of data and algorithms from platforms. And I'm going to go into what each of those mean now. So more useful expression. So in order to like interact with the right things, we need data. And the problem is a lot of people aren't expressing a lot of the data that they have stored in their heads. So for example, I've never written an Amazon review. I've never written a Yelp review. I've never done a LinkedIn endorsement. I do 5 stars on Uber every single time because I don't care. And I don't want to box this into being a review thing, but it's like we're not necessarily expressing ourselves all the time. And so if you look at the data, I'm not alone. Like maybe I'm a bad person, but like 97% of people aren't actively contributing data to these platforms. And then conversely, we all use this data to make decisions almost every day. It's like even me as someone trying to solve this problem, I still go to Amazon and I'm still like, oh, 5 stars, 10,000 reviews. Obviously, I'm going to buy this one. Or 5-star restaurant versus 3-star. Of course, I'm going to go to the better rated restaurant, even though I know the data's flawed because no one that I know does these things. And so, like, what we need to do is get people to express themselves more because the data exists. It just exists in our heads. Because if you come to me and you ask me about a product I've bought and used, or a restaurant I've been to, or a person I've worked with, I can tell you about them, but we have to have a conversation. Like the data doesn't exist on the web, and that's not very efficient. And so that's kind of like one piece of the expression problem. And then the other piece is our expression is limited by the games that we're playing on the web. And I use the term game very loosely, but it's like in Twitter, you know, the algorithm is the algorithm, and the actions I can take is I can heart things, and I can repost them, and I can comment. So I'm limited to those actions. And that's like one of the only platforms I use on the web right now. So my like expression on the web is just like very limited. And it's not necessarily like representative of my holistic inner state or my holistic inner knowledge. And so I think what we need to do is kind of incentivize people in different ways to express themselves a little bit more, to take this information that maybe only lives in their heads right now and get it out there into the digital realm for other people to discover, and do it in ways that's like positive sum. So I think the games that are created right now that people are interacting with oftentimes have perverse incentives that result in like the non-true reputation of the person being expressed online. And so simple example is, okay, I'm using Midjourney, and I've just prompted Midjourney for 10,000 intuition logos. Like, that doesn't mean that the only thing I think about is intuition logos. But to Midjourney, it thinks the only thing I care about is intuition logos. But that isn't the case, obviously. Or let's say I, put $10 million into some DeFi farm. Like, I'm maybe not signaling that I trust the team or the protocol or believe in it long term. I might just be farming yield for a couple of days, and then I'm out of there. So like, we don't have this granular expression of what's actually going on in our minds. And I think we need a little bit more of that. So that's step one. Step two is, okay, now we got people expressing themselves. what format do we capture the data in? Like, how do we make the data actually usable? Like, sure, AI is making dealing with unstructured data a lot easier, but it's still kind of messy. And so there's two, I think, big things that we need to solve here. So the first is the identity problem. So everything has so many disparate digital identifiers. Like, we as people, we have hundreds. Every new app we sign up for, we create a new identity for that context, and then we generate data and reputation that only lives within that context. So I can't take my 5-star Uber reputation and rent an Airbnb. I can't take my 20-year reputation with Bank of America and open a Wells Fargo account or get an under-collateralized loan in DeFi. It just seems crazy. But it's not just people. So let's say I want to create some verifiable data or create an attestation about Ethereum itself. Like, what is the unique identifier I use to reference Ethereum in my attestation? Is it the website? Is it the Twitter profile? Is it the LinkedIn? Like, I actually don't know right now. And in Web3, it's kind of nice because we all have these self-sovereign private keys that resolve to addresses. Some of us have like public-facing ENS addresses. So it's like, okay, you want to make an attestation about Billy, or you want to attach some data to me. You attach the data to billy.eth, and it's amazing. And the thing doing the attesting also has an address, and so it's very clean. And so what we need to do, I think, is arrive at what the globally persistent canonical identifiers for all things are going to be. And the way that we do that is through social consensus. So for example, how do we arrive at what the globally persistent canonical identifier is for Pepe coin? Like, there's 10,000 Pepe coins. Which one's the canonical Pepe? And the answer is the market decides. Like, all the Pepe coins might look exactly the same, but it's what the crowd has said is the canonical Pepe. That's the Pepe. And so I think we have to extrapolate that concept out to the identities of all things so that we can arrive at what the identifiers we are going to use to reference those things are going to be. Once we have those identifiers, then we can start attaching data to them. When we go to attach data to the identifiers, then we need the data to be clean. And so how do we get clean data that everyone can work with? And so the answer kind of to date has been like standards committees and standards hell, which everyone hates. It doesn't really work. You get in a room, you argue for 5-10 years, and maybe arrive at a conclusion. But I think what we're really good at in Web3 is social consensus. And so what if instead of like top-down hierarchically imposed taxonomies, we built this like bottom-up incentivized folksonomy, and we let the market decide on how to structure the data. And we kind of like incentivized people to converge on specific ways to structure their data. So you don't really have to like argue at the table. You just kind of do what's best personally for you, and what's best personally for you is also what's best for the system. So I think if we could build a system that does that, that would be pretty cool. So we're doing that. So that's number one. So first, we got people expressing the data. The data is being attached to canonical identifiers for things. The data is now structured. Now the question becomes, where do we store the data? Do we store it in Twitter servers? Do we store it on Amazon servers? Probably not. So what we next need to do is we need to decouple data and algorithms from platforms. So what if instead of all the data living in the silos of the applications, we had this like single unified verifiable data lake that all applications were pushing data to and all applications were reading data from. Then like every app could very easily leverage the data of every other app. So example of this is right now, when I go to interact with Twitter, I'm interacting with Twitter data and the Twitter algorithm. I can't like opt into using other data, and I can't opt out of the Twitter algorithm and toggle to something else. I have to like use their stuff. But I would love to be able to toggle to a different algorithm, or I'd love to be able to toggle to, if I'm arguing with a flat earther, I'd love to like toggle to see their feed, and maybe the reason they think the earth is flat is because their whole feed is an echo chamber of people saying the earth is flat. So that's kind of like one of the reasons why I think this is important. And the other is if we decouple the data and algorithms from the platforms, then the platforms become less entrenched and there's less vendor lock-in, because I don't really want to leave Twitter or something like that because I've spent a lot of time and energy and attention kind of building up my data and my reputation, reputation and my following over there. And so even if there's better user experiences elsewhere, I don't even get to try them out because I'm just never going to leave Twitter. And so it doesn't leave room for experimentation. And so it's kind of happening in decentralized social right now. But I think like the more experimentation we have at the application layer, the better our interactions are going to be. So that's kind of the third thing. So, okay, now the data exists online. It's structured properly. It's stored in some neutral place. It's available to everyone. Like, now what? Now, how do we get to the original concept of trustful interaction? First, what I think we got to do, you got to establish your trust graphs. You can have one trust graph, or you can have many granular contextual trust graphs. So you could say, okay, in the context of Web3, here's the agents in the system that I trust. Or you could say, on the topic of supplements, here's the people I trust. Or restaurants, or books, or podcasts, or movies, whatever. You can get as granular as you want. But just like defining these contextual trust graphs, then once you have them, you can pick your algorithms. And you can take both of these things wherever you go. So it's like, okay, maybe the algorithm I want to choose is the eigentrust algorithm. And I say, okay, my trust graph is here, and I'm going to weight people who are 1 degree of separation away from me 100%. And people who are 2 degrees of separation away from me 60%. And 3 degrees of separation away from me 20%, whatever. So just like picking and choosing the way that you want to filter the data now that you got your trust graphs. And then third is bringing your trust graphs and your algorithms and all of the data with you wherever you go, so that when you go to interact with something, you're served with all of the data you need when you need it. So instead of the user experience of interacting with MetaMask right now being presented with a bunch of non-human readable jargon, what if you could like see what your intuition was saying about the contract you're interacting with? And it's like, okay, the people that I trust in the context of smart contracts are the auditing firms. And it's like, okay, QuantStamp and Trail of Bits and Consensus Diligence have all said that this thing is audited or secure. So now I've got a little bit more trust when I'm interacting with this contract. I have a little bit more confidence. And you can kind of just extrapolate that out to anything. So let's say you're on Amazon and you're buying a product. Right now, you don't have an Amazon friends list. And so what you see when you go to the reviews is 10,000 reviews from people you don't know. Like, I've never clicked on a profile. But what would be really cool is if we could overlay that data with trust graph of your choosing, or the algorithm of your choosing, or both. And it's like, okay, you know, I'm shopping for supplements, and I trust Dr. Huberman in that context, and he is saying that he recommends this supplement. Great, I don't have to like go and listen to 8 podcasts to kind of decipher what supplements he likes. The data is now being presented to me at the point of interaction, which is just way more efficient. And so the end result of all of this is just trying to give people better decision-making power when they go to interact with things, instead of like kind of being in the dark and kind of being scared, especially in Web3 when it can have kind of dire and catastrophic consequences because you can just like lose all of your money at any moment. We just kind of need to have more information when we're interacting with things. And so what this resolves in is kind of this more holistic trust stack. So I don't think you can read those little words. Sorry, but we got like execution and consensus and storage. And I think there's this whole other layer on top of those. That's the interaction layer. It's like, okay, before you even get to the point of touching trustless execution or consensus or storage, you have to interact with things. And we just need to bring more trust to that interaction layer so that we're not interacting with the wrong things. That's pretty much it. I'm Billy. We're Intuition. We're doing this. If you want to talk, we're around. We also got a booth. 506 is near the entrance. And yeah, that's my time. Thank you all.
All right. Can you hear me in the back? Let's go ahead and get started. Welcome to my 20-minute quick round. I'm Dana Mahina. I'm here from the island of Kauai. I spent 30 years in Silicon Valley. I'm a corporate defector, and I'm also a recovering CEO. How in the world did I get here? Well, thanks to Opolis, shout out to them. I've been involved as an advisor for 4 years, woohoo! And here we go. Let's talk about your burnout. So most high-achieving, overachieving people who are solopreneurs and really crushing it have some form of burnout. 89% of women around the world report having burnout, according to the World Health Organization, and men also have burnout. Men who are working their asses off to deliver what they think their vision quest is. Good for you, that's awesome. Let's deal with your burnout today. Let's take you from burnout to joy as soon as humanly possible, shall we? Great. All right, here we go. So, burnout is actually not even necessary. We're all brought up to crush it, kill it, be high achievers, overachievers, run like hamsters inside of wheels. How many of you think hamsters are cute? You are not a hamster. You are a human being. It's not cute. It's not cute to get sick. It's not cute to burn out. And it's not cute to crush the people around you in your family, your friends, your community, yourself, your own well-being, your sense of who you are, just because you want to have the giant payday. The payday will come if you're really smart about your own productivity. So, if you're in a burnout cycle, I'm going to help you with micro steps to get out of it. And more importantly, prevention is the cure. I'm going to teach you how to recognize when burnout is on its way. All right, so what is productivity? Does anybody know? It's busy. It's high achievement. No, it's actually not. Productivity is hyper efficiency, maximal output for minimum effort. So if you are a very, very, very focused person doing 17,000 things in one day, the chances are you're about to B is for burnout. I wrote a book recently called B is for Burnout. Forgive the expletive, you can cut it, not bitch. This book is geared toward women who, again, 89% of us around the world are burned out. This is for men also, because you're allies, because your neighbors, your wives, your partners, your friends, your daughters, your sisters, your aunties, they're burning out all the time. And you're burning out trying to keep them from burning out, aren't you? Don't you want help? So here's how to do it. Change the way you work. Change the way you live your life. If you're a leadership, you're running a business, a company, you're a solopreneur, you're a Web3 guru, people follow what you do, they don't follow what you say. So we gotta get you off this burnout cycle and into being way more productive, finding time for yourself. Now there's also a value equation that I've discovered. I've hired, trained, and developed thousands of people over my 30 years in Silicon Valley. And what do I know about people? I know that they lie to themselves. I did it too. I was so burned out. I was always one cold away from full-blown pneumonia. And then what would I do? Work harder from the bed. It was not cute. I know I look like a gamer with a headset and a laptop and Kleenex, but it wasn't cute. And it sent a real message to my children who were young at the time. I was a single mom that, hey, girls, you got to work yourself to death. That's just the way it is if you want to get ahead, if you want to win the game, if you want to play the race, the amazing race that is this world. It's actually not even true. I am more productive today living on an island in the middle of nowhere. I set my schedule. I'm very focused during that schedule. And I always optimize for the lowest effort coming from my value for the highest return. I provide so much value, and so do you if you think about the way you run your life and your businesses, to others, your customers, your clients, your friends, your communities, your groups. You give and give and give, but what are you receiving in exchange? Is it an even exchange? Not like the old Latin term quid pro quo. This for that. That's terrible. What I'm talking about is giving and receiving and really valuing the output and how you give, and in exchange, how you are thanked. Some of us are thanked with money. Some of us are thanked with crypto. I don't know. Some of us are thanked with time off. Some of us are thanked with a walk in nature. Some of us are thanked by we get to go to the gym every morning because we set our own schedule. Some of us are thanked by our loved ones because we make quality time for them. However your value is exchanged is really important, and you want to take inventory. What is the value you're giving? What is the value you're receiving? Okay, what brings you joy? So there are micro steps to joy, micro habits. Many of you have read about micro adjusting. There's 7,000 books. Let me tell you what brings me joy, and it's clean. This is Dr. Bronner's, you know the brand? They're not sponsoring this, they should be. Dr. Bronner's organic hand sanitizer. I always travel with it. Why? Because it cleans my hands and this mic. Ask my AV buddy here. This cleans the mic, but it smells amazing. And you can breathe in lavender for about 3 seconds and you feel already a sense of calm. How many of you have a hard time getting up and away from the computer? You're like in a vortex, stuck. Go outside. Yes, go outside. Look outside. Breathe the air. You can't get yourself to open a window? Look at a tree. Laser in on the tree. Look at the color green. What does it feel like? What does green mean to you? You're probably going to design something cool with like UX all of a sudden that's green. You don't know why. Because you were fixated on something outside. Pet your dog. Take your dog for a walk. Most of us love our pets. They're our family. In Hawaii, we call them ohana. They're part of our family. Do something every day that helps you bring more joy, even for 5 minutes, into your life, and watch how your relationships improve. And watch how the dollars start rolling in. It's all related. We're so much more successful financially, emotionally, spiritually, when we prioritize our own wellness. And your life has 5 facets. I've already said it once. I'm not going to do a quiz today. Those of you streaming this and watching, and you're my clients already, you better know what these are. Career, family, friendships, your own well-being, and your community. So many of you say, I want to volunteer. We send out these quizzes on Instagram, dana.mahina on Instagram. Please find me there. I also love LinkedIn. Sometimes I'm on X, Dana Mahina. Go to danamahina.com. We do these quizzes, and people always say, oh, I really wish I had more time for community. So they write a check, $10, $15, $25. They sell Girl Scout cookies for their kid. They do a fundraiser on my island selling Kahlua pork plate for the boys' football team. But they still feel guilty about it. How many of you understand the emotion that is guilt? You feel guilty. It's passed down from generations. It's very manipulative, totally masterful. It's also actually not an emotion. How do I know? If you're really, really sad, the opposite is joy or happiness. If you're really, really pissed off, the opposite might be total calm. Guilt, the opposite is more guilt. It's just shovel it, pass it down generationally. Guilt is not a strategy. We want to really dump the guilt and infuse the joy. So if you really want to give back in community, repurpose your life. Take an hour from work and give it to community. Instead of doing the bake sale, maybe actually do something that you really want to do. You want to go read to the kids for story hour. You want to teach them how to deal with money. Kids have no idea about money. Maybe you want to go out into community and volunteer with the Boys and Girls Club. You can make an hour a week. How many of you can do basic math? I should come down into the audience. Oh, good. What is 24 times 7? 168? That's right. Yeah, very good. 168. That's how many hours all of us, men, women, children, she, they, all of us. 168. That's as many hours as we all get in 1 week. It might be the only thing that has equity your entire life, no matter who you are, where you're from, what you believe, and how you identify. We have 168 hours in the week. You have to spend them very wisely. I know there's a lot of poker tournaments going on around here. I don't play poker, but I'm really good at reading people. So if your poker tells obvious, you don't want to play with me. And what I would tell you is about yourself, your 168 hours in the week is probably not being spent the way you really want to spend it. What do you want to have more joy in your life? A little less work, a little more wellness, a little more community time. Maybe you want to spend less time with your family. It might be just okay to tell them no, because boundaries are critical. People have such a hard time saying no, and no makes room for yes. to do the things you really want to do, including micro joy habits. I've given you several examples of how to do that today. I'm watching my time. Okay, myth busting. You do not have to burn out in order to be successful. Most of us don't believe that. You're going to walk out of here today, you're going to turn off your screen at home, and you're going to go, yeah, she's full of it. How easy for her to say. She's in the island of Kauai, her life's kind of cush. Actually, I'm working extremely hard. I'm just working very mindfully. And what I'm not going to trade off or give up are things I love, getting in open water and swimming. I teach a kupuna, which is 55-plus-year-old. I'm 56. I could be everyone's mother here. It's kind of trippy. I teach a kupuna water aerobic class once a week. Why? Because it's community and it's friendship. See how I'm blending and integrating my work-life harmony? Because balance is baloney. Then what happens is I work. I do coaching. I have a podcast called Work and Life Harmonized. I've written this new book. I can do that around 8 to 2 every single day and pretty much have the afternoons to myself. If I'm disciplined and if I'm honest with myself and I stop lying, that 2:30 today is okay. Oh, I'm on a roll, 3 o'clock. Oh, I love this person. Let me help them. Oh, my heart is melting, 5 o'clock. And before I know it, I'm back in the trap that I used to live in. 10-hour days, 12-hour days, 16-hour days. Really, we have to be mindful. And so if you really want to be successful, I really urge each and every one of you to redefine what success means to you. Most of us are not going to say at the end of life, I'm just going to count the dollars. It's all about the quan and what I made. Most of us aren't going to say that. Most of us are going to say, I did what I loved my family, I had this great life, I had a bucket list trip, I gave back. Maybe you're an innovator or an inventor and you did something that is IP worthy and you really did something to change humanity. That's what you're going to say at the end of life. And so I like to begin with the end of mine. So I promised you that I would talk about what in the world to do to give yourself space and grace. So time, good. I know I speak really, really quickly. I've had a lot of caffeine, and I'm on the totally opposite time zone and jet lagged. So thanks for bearing with my fast track speaking. Micro joy steps are the way to solve for this. So if you see burnout coming for yourself, a loved one, a coworker, an employee, a family member, somebody at church, wherever you spend your time, I want you to be a kind person and an accountability partner, and I want you to pull them aside gently and say, yo, you're burning out. I know, because I spot it, because I got it. I can see it, it's happening. You're getting sick, you're losing your hair, you're stressed all the time. You walk around with your shoulders up. You mumble, you complain, you're very negative, you're almost toxic. Let's stop your burnout cycle before it starts, because stopping it before it starts is so much easier than when you're already in it. When you're in it, then we gotta have a different strategy. And hope is not a strategy. You cannot hope your way through burnout. So let's be smart, let's be strategic, and let's be great role models for others in terms of how we reduce the burnout cycle for ourselves and others. So what's one thing that you can do today, right now in this very moment, that you're willing to commit to that will stop some of your burnout and start bringing up some of your joy? If you're brave enough, there's a mic. I can't even see it. Come on up to the mic. Tell me one thing you're willing to do. I like to call on people in the audience, so you might want to volunteer yourself. Come on, somebody come up. There's a prize. Watch how this works. There's a prize. There's a prize. Come on up to the mic. Tell me how you're willing to reduce your burnout. Will. I know you. You got to come up. Come on. Thank you. Give them a hand. I know. I volunteer people. I'm a mom. The girls are 20 and 24. I do this to everyone. Sorry. What are you willing to do to reduce burnout? One little thing.
Take a walk with my dog every day during lunchtime.
Awesome. Take a walk with his dog every day at lunchtime. Here's a book. You can have a second book to give to whomever you want. Thank you. Okay. Anybody else willing to come up? Be brave. Make a commitment. I'm your accountability partner. It's okay. Come on. Great. Thank you. See, someone has to go first. And in the front, when you're a keynote speaker, let me just tell you, it's so weird. Those are supposed to be VIP seats. Everyone sits way in the back. My whole life on stage is, I don't get it. Hi.
Hi.
What are you willing to do to reduce burnout?
Work out.
Work out.
Very simple.
Great.
Yeah.
What do you
Just
like
sweat
to
it out?
What do you like to do to work out?
If I'm angry, I go for a run or lift weights. And if I'm calm, I do yoga, depending on the mood.
That's fantastic. So specific. We call that SMARTER. Specific, measurable, achievable, realistic.
Yes.
Evaluate it, repeat it, and rinse it, or dump it and start again. Wonderful. Thank you so much. Here's your gift. Thank you. Thanks for being brave. Okay, so I'm going to be wrapping in 5 minutes. The last thing I want to talk to you about is how in the world you can use a book like this for yourself and your loved ones, men and women, even though it's a female-related book, hot pink, prior to the Barbie movie, believe it or not. This was my idea. I know I'm dressed like this too. Men can wear pink. Be in touch with your emotional feminine side. Thank you. What you really need to do is look through the chapters and the table of contents of this book. I wrote this like a quick hit coaching tool. My clients of years and years, hundreds and hundreds of people, both men and women, have said, it's like you're sitting next to me. It's like you're talking to me. When are you recording the Audible for this book? Some of us are really shy about our own voice. I don't like the sound of my own voice. Here I am, a podcaster. I'm up on this stage. I am going to record Audible for this book, not for my first book, but for this one because I feel really confident about it. Confidence is key. So take your confident self, your willingness to reduce burnout and increase joy, open the book. I'm also in the Career Hub after this for a couple of hours. Come find me. It's next to the Zen Garden or whatever they call it. I might be in the Zen Garden, but come fish me out. And I will sign your book for you. The table of contents has a very easy way to figure out how to change yourself from overdrive to thrive, A through Z, just like what we all learned in school, the basics. Or if you're a second English learner, A through Z will work for you as well. A is for authenticity, B is for burnout, Y is for you, P is for productivity, J is for joy. D is for delegate without remorse. There's a chapter for everybody, and inside of these chapters, they're always a close with the big so what? So what? What am I supposed to do about all this? Yeah, I feel burned out. Yeah, I feel crappy. I know 700 people that don't feel good. We're stuck. We don't even know where to start. We're already in that burnout cycle. Well, all the micro step tips and tricks, traps to avoid, most of the mistakes I've made, again, working with literally thousands of people, I'm kind of an expert. I can tell you that if you just start, if you see something, you say something. If you feel it, you sense it, you think it, you say something. You put stuff on the table. And then you'd be really surprised how communal things can get. Other people say, I feel that way too. I've felt that way too. And you start to really hold each other accountable in a really communal way to reduce the burnout and increase the joy and to find creative outlets for micro-stepping and micro-adjusting your way from wherever it is you and your loved ones are to wherever it is that you want to get. So that's the end for me. I'm going to have an open mic for questions if you have any. Here's how to find me. If you're viewing this right now, please tag me, in particular on Instagram at dana.mahina or anywhere you hang out for social media. This book is a really big part of my life because it's designed to help people get accessible and affordable coaching where they wouldn't normally have access, and for people to really find each other and build their own communities wherever you work, spend your time, occupy life. I'd really love to see people reduce burnout and increase joy. So thank you, thank you, thank you. If you have questions, come on up. Any questions? Come on. Cool. Aloha, as we say from the island. I know you.
Aloha, yeah. Hi, King.
How's it?
The question, well, it's going good. How's it going?
The question was?
What's that? Oh, the question is, so if I wanted to give this to somebody who I think has burnout, I'm going to read it myself. But if I were to gift this to somebody, how would I do that delicately, I guess, without offending them? Because it's like, hey, look, you're burned out. You should read this.
Yeah, yeah. Thanks, Eddie.
Yeah.
So you want to say to somebody, hey, I noticed for myself over the years that I got in this cycle where I'd get really, really sick, but then I'd push through. I'm noticing that in you as well. Is it something we can talk about? And then you say, there's this great book written by Dana Mahina, who spent a lifetime in burnout. And her tips and tools are really helping me, and I really believe they could help you too, because I care about you. There's this little trick called radical candor. Shout out Dr. Kim Scott. This is her book, not mine. Came out about 6 years ago. And it says, care about people and challenge them directly. That's radical candor. And I'm always a fan of that, even when you're confronting something sensitive. So thanks, that was an excellent question. I'm getting the sound that time is up. Thank you, thank you. I'll see you at the Career Hub. Have a great show.
Hello, everyone. Well, I'm Eduardo, he's Hector. We are not Jordi, Jordi is over there. We switched our talk, but mainly the topic is the same. We are going to talk about how the AP 4844 is going to affect rollups. And as most of you know, this is going to be the end game for transaction cost. So we are going to give kind of overview of what that means for ZK-rollups. I'm going to make a kind of a summary and put some numbers in the table. And later on, Hector is going to explain how these affect to our rollup. So let's start by talking about some key points about the 4844. The first thing to know is that right now, currently, ZK-rollup are using cold data to publish transaction data or state diffs. And now we are going to switch to a new paradigm in which we are going to start to using blobs for publishing this data. So each blob, it has available 128 kilobytes of data. We are going to have 6 blobs per block. And one important thing, especially for node operators, is that the blob is going to be only available during 18 days. Mainly this is to not blow up the hard drive space of validators. And that means that probably we are going to see how archival blobs providers are start to happening, because if you want to have this data after this time, you need to ask to this provider for the data. An important thing to mention also is that we are going to move from 70 gas per byte to 3 gas, and mainly this is the main benefit of this. And another important thing to mention is the fee market. The fee that you are going to pay using blobs is different to the fee that is computed on the execution layer. Here we have a schema, basic schema how this looks like. We still have regular Ethereum transactions, as you can see here, but now we are going to have a new type of transactions, the data transaction that contains a blob. And these blobs can be verified on-chain due to the commitment. Hector is going to provide more information about that. So yeah, the first thing to know when we talk about data cost of transaction is the prover. Usually people believe that the prover is a bottleneck in terms of cost, but I've been talking about this since last year. Prover is not the bottleneck anymore. You can repeat it with me. Prover is not the bottleneck. As you can see, the cost of a transaction is quite negligible. And this is some numbers of our current prover. It takes 2 minutes to make a proof of a batch. A batch is more or less 500 transactions. And we are going to add a lot of improvements on our proven system, like backups and other things that probably is a topic for another talk, not for today. But that is the key point, that the prover doesn't represent the most part of the cost of a transaction. So what are the costs of a transaction then? So we have 4 costs here. We have data availability, we have sequencing, we have prover, and we have aggregation. Data availability is paid for every byte posted on chain. Sequencing is when you publish the transaction on L1 and you need to pay this constant L1 transaction, but it's shared among all the batches that you are submitting to the network. Then the prover cost is constant hardware cost and is for each proof computed. And finally, we have the aggregation that is also constant, like the sequencing, and sharing among all the sequences aggregated. Don't get confused by this scale. This is, we will see later on, but it's just kind of a glimpse that the data availability is the most important part on this cost. So this is our current numbers. Before going to the 4844, we are paying 16 byte cold data. And well, as we previously mentioned, we are going to use 128 kilobytes for sequencing these batches. Internally in the ZK-VM, we have the ZK counters. Mainly this is what limits us to group transactions. And the thing is, with backups in the coming months, we are going to remove these counters. But at the end, it's just a way to make groups of transactions that are being able to be proven. Taking a look at this number, as you can see, for instance, 350 ETH transfers is around 39K bytes per batch. Well, you have that. You can see here that depending on the type of transaction, we need to submit more or less data on chain. And finally, you can see more or less how many transactions we can include in just one blob. So for instance, we can submit the data for 1,127 transactions in the case of 8 transfers, or around 350 in the case of Uniswaps. It's important to mention that obviously, well, the price of ETH for these estimations is, well, some time ago, but obviously the price of Ether has an impact on the price of the transaction on L2. So let's put real numbers here, right? This is what we are paying currently. Currently, we are paying the 95% of the cost of submitting transaction to L1 because of the data availability. If you take a look, sequencing is just a 4%, the prover is negligible, and also the aggregation. So this pie represents more or less where are the costs. And why this is so important? The thing is with the 44.4 and this Ethereum rollup centric roadmap that we started in 2020, we are decreasing this around 3-7 times less. And that is why this is the end game for transaction costs for rollups. So, for instance, well, it's hard to see, but I will try to explain it. This is a screenshot of the blob scan. A website in which you can take a look to the blobs that are happening. This is, for instance, something in Sepolia. And here, even it's hard to see, but mainly we have, if I'm not wrong, 5 blobs. One is not in the screen. And the first thing that you can see here is the free market price. The thing is, if you include 3 blobs in a block, that means that the price is going to be constant. If we include more than that, the price of the gas price is going to increase, and if it's less than 3, the gas price is going to decrease. Now it's hard to know what is going to be the price. That depends on how many rollups are using blobs. But we expected at the beginning the price is going to be really, really low. Another important thing to see here is that if you take a look to the blob as called data gas, that is this thing, you can see that is 7 times less than if you use cold data. And that is why it's so important this for rollups. And now Hector is going to give you more details about how this affects our system.
Hello. Okay. Let's start with the funny part. So to be slightly more specific, a data blob, I like to see the data blob as a vector of field elements, each of which are over the BLS scalar field order. And the vision I like more is seeing these elements are being evaluations of a given polynomial under some sets of predefined values. In this particular case, is a set of roots of unity. But also, it's important to notice that from L1, we are not going to be able to access any elements in this vector. But the only thing we are going to be able to retrieve from any smart contract is through a new opcode, which is called blob hash. Okay, and it will basically give you the SHA-256 of the commitment of the polynomial that represents this vector. Okay, and only with this information we need to be able to prove that what we are proving off-chain in L2 is the same that what you can retrieve in L1. Okay. So the main issue here is that in L1 you are forced to play with what you have. In particular, you are forced to play with the KCC commitment over the BLS. But in L2, we do whatever we want. We do whatever it fits better for us. Okay? And in particular, we are not using the KCC commitment, but we are using our own proving system. So in some sense, we have to fix the inconsistency between what you have in L1 versus what we do in L2. Okay? And we will see that thanks to a new precompile that will be introduced in this AAP, we will be able to fix this inconsistency. Okay, and well, in particular, the trick is well known to fix this inconsistency, which is called proof of equivalence protocol. Okay, and basically the idea is to prove that what you have committed on-chain is the same as what you commit off-chain in L2. Okay, so basically a prover sends to a verifier the two commitments. Okay, then for sure this protocol will be non-interactive at the end, but just to, I think it's more intuitive seeing this interactive. Then the verifier will send unpredictable and random point. And then the prover, what it has to do is to prove that the evaluation of the polynomial of both committed polynomials under this point are the same in both cases. Okay, that's why he's sending back the evaluation and both proofs. Okay, I'm trying to be slightly more precise in how we are going to work with the ZIP. So basically, the idea is that first, we are going to compute off-chain everything that we need for proving the correctness of the KCC commitment. Okay, so basically, we are going to be computing the random point as the linear Poseidon or the information inside the blob. Okay, this is all off-chain. And then we are going to compute the proof and the evaluation. Okay, and this is the information that we send on-chain, okay, at least in the first part of this data flow. And basically, the smart contract, what we'll do in the first instance, when we sequence all the batches, is checking that this information is correct. Okay, so it's like a first guarantee that what is on-chain is what we like to prove in the next step. Okay, and in the next step is where we do all the work logged in the L2. Okay, so it's more or less the same, but basically we are going to use our proving system to prove that Z, so the random point is well computed, meaning that is the linear Poseidon of the information inside the blob. And not only this, but also that the evaluation of the polynomial that represents the blob is precisely what we have verified in step 1. Okay? So basically, if in the next step when we prove that the batches are correct, we are able to verify this proof, that will mean that, well, not only that the evaluation is correct, but also that it coincides with what we got in the previous step. Okay, let's see now the proving architecture. Okay, so this is more or less the summary of the architecture that we have from the proving perspective. Okay, notice that, well, basically what we do is we prove the correctness of one batch of transactions, but not only one, but using aggregation, we're able to verify just by sending one transaction, just by sending one proof on-chain, that all the transactions inside all the batches are correct. Okay, and we basically aggregate all the proofs in what we call the aggregation stage. Okay, and this is what we have right now. But now, with the AP 4844, we will need to include the proof of the blob, okay, which is the proof of the correctness of the evaluation. And in particular, what we are gonna change from the previous architecture is we are gonna cut off after computing all the aggregations of all the proofs of all the batches. And in this point, we are gonna introduce the proof of the blob. Okay? We are gonna introduce the proof of the blob, which is the proof of the correctness of the polynomial evaluation, and we are gonna aggregate this proof with the output of the previous aggregation. Okay, this is what we call our inner blob prover. And then not only, we are not going to stay that, but we are going to also aggregate the proof from one blob of a set of batches to proofs of other blobs of other set of batches. Okay, so at the end, we are just going to send up one transaction to L1 proving the correctness of many blobs that points to many batches. Okay, and well, just going a little bit inside the details, these are going to be the public inputs that we are going to add to the inner blob prover. Okay, there are more of them, but just to mention a few relevance, we have the blob state root and the new state root, blob state root, sorry. And we also have the accumulated input hash, which is important because here, well, the accumulated input hash basically is, it's like what relates one blob to another one, like in a blockchain, okay, we are going to relate the previous blob with the next one. And in particular, here, we are going to be able to decide if we would like to go for the AIP 4844 or not. Because, for example, let's say where we have a period where the blob cost is much expensive than the cold data price. So here we will be able to decide if we are gonna keep putting things inside the blob, or we prefer to, for a short period, come back to the cold data solution. Okay, and in the inner blob we have all the public input related to the blob itself. But then here in the outer blob part, we have public input not only related to the blob, but also to the set of patches that you are approving. Okay, so here, for example, you can see that we again have the block accumulated input hash, but we also have the state root, the new one and the old one. Okay, it's basically the state changes that you encounter when you process all the transactions inside the blob. Okay, and well, in order to prove all this stuff, our solution was to create a processor that is able to interpret all the, let's say, state changes that are done due to the transactions inside the patch. Okay, so basically we have like a gigabrain, okay, which is what we call our ZK-VM processor, which is able, well, we design it like in a distributed manner, meaning that we are not encoding all the logic inside the same processor, but we are distributing them among different coprocessors. Okay, for example, we have a part that deals with arithmetic operations. We have another part which deals with binary operations, for example, and well, let's say that what is able to do and what is not able to do this main processor is thanks to the ROM part of this processor. Okay, this was the old processor. But remember that I told before that the blob proof is in some sense independent to the batch proof. So we needed to create a new processor, which in principle it can be thought as a subset or as a subset of the original processor. So for example, in the left side, we had some specific machines or specific coprocessors to deal with padding operations and clean operations. And here, in the new processor, which will be much shorter than the original one, we will have just a subset of the coprocessors that we had in the original one. Okay, in particular, the arithmetic state machines will only need to deal with much less equations than the original one. Well, and finally, just to give you a glimpse of how we are doing these things, this is like the bunch of the computations that are encoded in the ROM of the new processor, okay? And in particular, as I have explained before, the main objective, at least for now, of this new processor is proving the evaluation of a polynomial. Okay, and here in the upper right side, we have the formula for computing this evaluation. And here we have the assembly code that is performing basically this evaluation. Okay, as you can see, it's the evaluation of a polynomial of degree 4096, which is the size of the blob.
Yeah, finally, I would like to explain a little our roadmap. This is not a commitment, it's just our intentions, just to make that clear. Well, as you can see, right now we are onboarding CDKs on the new aggregation layer. We can talk about that in the booth. We have promoting that a lot. We are working on the API 4844 currently. And also, in parallel, we are working on the Erigon RPC that is going to happen very soon. And also, we are going to check our infrastructure to add Erigon as a new sequencer of our network, with the idea to increase the TPS of the ZKVM, but also of the CDKs. We are also working in PIL2 and backups, variable degree composite polynomial, that are the things that I mentioned before in regard of improving prover performance. And we are developing the aggregation layer V2, aggregation layer V3, and especially also important and interesting for this talk is the data completion. We have saw that how easily we can decrease the cost of transactions by a factor of 3 or 7 or something like that. But we are also going to add data compression to the data that we are submitting to the blobs. And with that, we can achieve bigger factor compression and cheapest transactions. So yeah, mainly this. Thank you for coming. And if you have any question, you can find out around. Thank you.
Hi, everyone. I'm Chosapun. Oh, a few minutes? Okay. Okay. Okay, perfect.
Just so that nobody missed part of your presentation, if someone's looking forward to it coming in.
You guys got to time it? Oh, nothing, never mind. Hi, everyone. I'm Joseph Poon. We've been working on a new EIP 7640, in conjunction with Christopher Jeffrey and Boima Fambule. So this talk, we're going to be talking about how, sort of like high level, how the mempool works, sort of how we got here in terms of how the mempool works in reality today. Why does proposer-builder separation exist? What is the role? And then the proposed EIP and the effects, principally making intents more decentralized, encouraging greater proposer autonomy with reduction in trust in builders, greater mempool efficiencies, and creating more decentralization and account abstraction. So this is sort of what Ethereum's pending transactions getting into a block looks like. You can either go in directly or go through this like searcher relay whole MEV structure. So this isn't obviously how it's always worked, right? It sort of just used to look like this. How did we go from this to this? There's a lot of discussion about MEV. But ultimately, historically, it was always this client over here that sort of decided whether something got into a block. All this other infrastructure exists now. And what's the role of all these, centralized providers? What do they really do? Because before, it was a peer-to-peer network. You broadcast your block, people gossip it, nodes gossip it along a peer-to-peer network, and then, the validators verify the block, and then we're good to go. So we got here because we ultimately separated out creating the block, which transactions get into a block, and the blocks themselves, the validation, creation, and signing of these blocks. And a lot of people think it's because, well, we need to hide this MEV activity. There's if someone produces some type of MEV activity, then someone else can copy that trade and they want to hide it. That's not actually, if you think about it from a proposer perspective, it doesn't actually make sense. This is largely the rhetoric that we've heard from people. This is not, it doesn't make sense because if it's an activity that you need to hide from other people, then the proposers aren't going to be getting realistically like a high fee for that. Like the gas tip for that is going to be very, very small. It's actually only well-known activities, back running, sandwich attacks, that type of garbage that actually gets bid up. So if you're a proposer, if you're a validator, those are the transactions that you actually care about. If someone's doing some type of activity where they get some MEV, from a proposer perspective, like if they're the only one, I don't care. I don't really care about mining this block. So why do we have all this infrastructure, right? Why do we have this whole notion of separation, And a lot of it is, if you're doing these types of attacks, that you need to bundle it, And account abstraction makes it easier to do this type of bundling without these types of entities. But this proposal is not actually an MEV proposal. This is not actually an MEV presentation per se. You can use this proposal in conjunction with account abstraction to resolve these use cases, but this is not a presentation necessarily on bundling. However, there is a need for intents, as we've heard in this space, and intents is largely a buzzword. We know what are really intents from a mechanistic perspective. A lot of people talk about intents from a use case perspective. Mechanistically, if you actually break it down, what intents are is the fact that you can propagate along some type of mempool or some type of pending transaction, which cannot be a valid transaction today. So in other words, this is a revertible transaction. This is an incomplete transaction, but it's still being propagated. So it's that, okay, this is not a real transaction or it's not fulfilled. We're going to propagate it. And then eventually it will change state due to someone else into a valid transaction. And that is what gets mined. So mechanistically, that's all this intent stuff is. Right? It's that, okay, it's not a valid transaction right now. We'll still share it, but we'll defer producing it into a block until it's valid. That's all it really is. Like a lot of people talk about it, but mechanistically, it's that simple. And in Ethereum, whenever people talk about intents, these are centralized providers. Straight up. That's what happens. You're talking to a server, and that server decides what happens with it, and you're sort of trusting them to do, correct behavior, so to speak. And maybe that should be decentralized, right? But really, if you look at why this structure exists instead of this, it's fundamentally about contentious transactions. And what do I mean by contentious transactions? It's that if many people are trying to get the same transaction in, think about your standard MEV, then you only want one transaction to get in, And to backtrack a little bit, like this is not a presentation about getting rid of MEV in its entirely. It's about making a more decentralized system instead of having centralized trusted providers. So when I talk about contentious transactions, let's give a simple example. Let's say there's an NFT being released on chain tomorrow at midnight. Whoever bids first gets it. Whoever like gets this into a block first, and the first one inside that block just gets it. It's that simple. Let's say 20 people want it. Now only one is going to win, right? So in the traditional Ethereum mempool, if you propagate this transaction and there's 20 people bidding on it, intuitively you'd be like, okay, let's put in a higher gas fee, right? Let's get this thing in before other people. However, if you do this, that means 19 other people will lose money from spending gas, right? And fundamentally, if you think about it, this is the core. When people talk about MEV, when they talk about this like proposer-builder separation, this is the real problem. If you break it down, this fundamentally is the problem that they're trying to solve. So you have all this, like all these builders, all these relays, and all this stuff because they need a market to form off of these people trying to get their transactions in, right? So if these 19 people don't get their transaction in, a lot of these providers will say, hey, we'll withhold the transaction and not include it in a block, and we pinky promise to do that, right? That's all they're saying. It's just a pinky promise. And what happens as a result? What happens is that consequently, because these centralized providers have a promise to you not to mine this block, this means they cannot relay your transaction to other people. And that is where the network effects of centralization comes in. That is why, on a fundamental level, there's only 4 or 6 or so builders out there. Because these builders cannot share your information. That is the core of this design. That's really all it is. So why do we have it this way, right? Like, why do those 19 people have to pay if you broadcast it along the Ethereum mempool? It's simply denial of service protection. The P2P is an open gossip network, the Ethereum like P2P, for pending transactions. And, the state of the transaction is not really known until it's included in a block. Because, for example, if there's 19 other people trying to get it in, well, when you broadcast the transaction, you don't know if you're the winner. So as a result, you have to pay for the revert in order to make it so that there's no denial of service in the mempool. Because I could flood the mempool with transactions that are ultimately invalid. And this solution of reverting transactions and always paying gas, it's a very simplistic solution, but it's worked. But because of this problem, people have devised other, centralized solutions. A transaction lifecycle can be broken down into, you sign a transaction, your local wallet produces it, and then there's a relay policy, and this is oftentimes overlooked. And this is a very, very important point where in order for a transaction to go from one node to another before it's mined, before it's produced in a block, there's a policy established inside the peer-to-peer nodes on whether to send this to other peer-to-peer nodes, the pending transactions. An example is there's a maximum depth of pending transactions per account. So if you've got an account with let's say, 100 pending transactions, you blast it out there, well, it'll only go up to about 75 or so. And then, the proposer decides what to include, and then at that point, after it's included in a block, it can either be reverted or a valid transaction. Now, the fact that there's a separation between reverted and valid transactions is fairly interesting because there's three sort of major filters. whether it gets propagated on the P2P level, and then whether it gets reverted and whether it's valid. What's fairly interesting is oftentimes the constraint around the P2P layer is higher than what is accepted in a block. For example, the block can include 100 transactions from an account, but it's not allowed in the P2P layer. So here's the proposal. It's incredibly simple. It's incredibly simple. It's not a lot of lines of code. It's simply a new transaction type proposed in Ethereum, a hard fork core consensus change, and it's simply having a field called revert protect. And if a transaction has revert protect set, then it cannot be included in a block. If it's included in a block, then that is an invalid block. It's sort of like including in a block like a bad signature or whatever it may be, right? And that means that you are now free to propagate these transactions among random untrusted parties because you know your transaction will only get in if it does not revert. However, we need to address this denial of service attack problem. That was the original problem that we're looking at. And it's a very simple rule. If I'm a standard Ethereum node today, without an alternate mempool, the default behavior will be to not relay the transaction and not accept the transaction. And therefore, there's no real impact in terms of existing nodes with no alternate mempool. And then there's an additional opcode to detect whether the flag is set in the EVM. So in order to construct these alternate mempools, what an example would be, you have some type of, public mempool in addition to the existing mempool. It looks a lot like it, except there's flow controls. So if you're an account, let's say you're staking 32 ETH, you can broadcast it along a certain amount, maybe let's say 1 per minute, or whatever the flow rate is. And then you also have a priority queue algorithm attached to it. So if someone's flooding the network with an account, you sort of downrank it and make it so that only higher priority transactions go through. And this is a true peer-to-peer network. We're not talking about a new token model, no new validators, pure P2P, right? And you can run this in addition to the existing Ethereum P2P network, and it basically looks pretty much exactly like that. The minor difference is you can add intents to this, but that's a whole nother discussion. Additionally, by having this change in, if you wanted to use the existing MEV infrastructure today, you're reducing the trust in these MEV providers. And what do I mean by that? Because you're trusting ultimately the MEV providers not to relay these transactions to other people, right? Today, that's what's going on. With this change, and something like account abstractions or another EIP, you can have an environment where these MEV providers, these builders, are willing to just share your transactions willy-nilly to other people. And why is this important, right? We only have 4 to 6 of these people. With this change, you could potentially have thousands of these builders. There's no real reputation attached to them right now. Right now, there's trust imbued in the block builders. And that fundamentally breaks the system in the long term, because what happens is that these people are withholding block data because they can't trust the proposers, and as a result, there's some risk in the system in the long term. And hopefully this can create a new wave of decentralized mempools, a new wave of innovation on intents, and building things on the P2P layer, because the P2P layer is sort of like, it's a cobweb of code. And I think we need a great deal of innovation to bring Ethereum back to the forefront when it comes to intents. And I think we can get back to this. This is really what we can get back to, I think. And so what are some use cases? Decentralized market formation and P2P mempools. That means that, that NFT example you saw earlier, people just bid up their gas fees. They're just the gas tip. You just start increasing that. It propagates. Everyone can see that. And the P2P network, you can just get a view on whoever the current, potential winner is. You don't need to rely on these, centralized parties. And it creates the opportunity for true decentralized intents. Like I said earlier, intents are invalid transactions today that may become valid later, which need to be held in the mempool. And right now, you're just hitting some HTTP server for these intents. They could reorder, withhold your transactions, ignore you, front run you, You might not even know. And at least on a P2P mempool, it's very, very public. And you bid it up via gas fees, and it's very straightforward. And it creates greater proposer autonomy and greater innovation. Proposer autonomy meaning that if you're signing a block, maybe you should know what's in the block. Maybe you should be building that. And this NFT example is why we don't have that. And we need more secure, decentralized account abstractions. Account abstraction is getting in soon. It's going to be popular. It's going to be interesting. And right now, the account abstraction has a fundamental trade-off between having only one bundler for your account abstraction contract or you relying on these builders. And the reason why this constraint exists is because their transactions can get reverted. If you're bundling 50 transactions to save gas in account abstraction, if one gets reverted, you're kind of messed up because you paid the fee for that transaction, you paid gas for it, and none of those 50 got in. What do, right? That's kind of messed up. So you have to use these centralized builders. And that's fundamentally baked into the account abstraction design today without a change like this. So in terms of community process and how you can help, the EIP was just uploaded a couple days ago. Please review, comments appreciated. And if you're building dApps, I do think intents are coming. I think it's a big deal. I think you should be biased towards decentralized approaches. And decentralized approaches means you're operating on a public mempool, or maybe even the builders are publicly gossiping your transactions. And hopefully this can push forward Ethereum towards a more decentralized future. Thank you. Questions? All right, thank you.
friends after this, Brandon.
Be friends, yes.
There's a STEM life party. Somebody is. I love the shirt.
Where'd you come from?
Where'd I come from?
Yeah.
Oh, just the house I was staying at. Just a fun night last night, and I'm giving a talk today that I was having.
Oh man, I did not have to give any talks except for the beginning of the week, which I'm very happy about.
Oh, wait, this is his. I'm sorry. That's yours.
I got it. That's yours.
Yes,
yeah.
you just need to turn it right here. Just a little switch.
I got it now.
Thanks for agreeing to do this. Yeah.
All right. Let's get started. Okay, so this is gonna be a really, really good panel, everybody. We got some OGs on the panel. Let's give everybody a big shout out. Okay, so let's start with some context. We're here today because we all believe in this amazing technology called ZK. And ZK has been, at its core, very complicated, finding market fit, product market fit in the past few years, and I believe we found it, right? We found 1, scalability, and 2, privacy as the main benefits of ZK in the blockchain context. So here we have 2 camps here, literally represented on both sides of me. So we got ZK Sync and Polygon on the right-hand side, and we have Alio and Aztec on the left side of me. So according to this privacy and scalability use case, the architectural design of the blockchain are also different, vastly different, right? So we got the ZK VM camp, which is here to solve the privacy issues, and the ZK EVM, right, solving scalability of the Ethereum problem. So we're really going to just dive right into those issues and really figure out the differences, the different perspectives. I'm going to just give a preface by saying I am a big ZK fan. You know, that's why I'm working in this space. But I'm going to take off that maxi hat and just be a skeptic for the day and really push everyone on the panel, you know, why we're doing the things we're doing. So there's no right or wrong answers, but different perspectives. So with that, let's get started, shall we? Okay. So first of all, just a quick introduction in 30 seconds. The name, your title, and your project, please.
Okay. Alex, CEO of Matter Labs, co-inventor of ZK Sync. ZK Sync is a scaling protocol for Ethereum. It's the largest ZK network today on Ethereum, with a mission to bring zero-knowledge proofs and like basically bring the entire world on-chain with zero-knowledge proofs, because I believe that this is the only technology which can actually scale Web3 to the entire world while preserving the key values that we hold dear in the world of blockchains.
Hey everyone, I'm Brendan. I'm a co-founder at Polygon. I work on ZK stuff. Jaime from our team pointed out that this is the only panel that he's seen that has the word versus in the title. And so I guess I'm really excited.
Let's make it a debate. I'll real quick introduce myself as well. I'm the head of BD at Alio. But just so you guys know, I'm going to ask the most hardcore questions to Alex over here. My boss is here just to be impartial. Don't worry about that. Go ahead, Alex.
Hey, everybody. I'm Alex. I'm the executive director of the Alio Foundation. Just briefly, Alio is building a new Layer 1 blockchain with a ZK VM based on ZEXi, with really the goal of, the focus being privacy, and the idea being taking, how the internet went from unencrypted to encrypted via the transition from HTTP to HTTPS. That's what Alio aims to do with Web3. In addition to that, I run ZPrize, which is a nonprofit initiative to help accelerate ZK proving. And before all that, I was an investor at A16Z.
Hey everyone, I'm Zach. I am the CEO and co-founder of Aztec and co-inventor of Plonk. So Aztec is a privacy-preserving layer 2 for Ethereum. So our thesis is that privacy is really the missing link required for blockchain to hit the mainstream and reach into everyone's lives and not just cypherpunks. And that having rich composable privacy in a smart contract framework is what's required for us to really add jet fuel into this world computer that we're building.
All right. Okay, so first, simple question. Let's start with that. In your own words, what is the difference between using ZK as a tech stack for privacy versus as a rollup? Let's start with Alex. Over here.
I actually don't think there is that much a difference. Like Alex just brought up a beautiful analogy of HTTP and HTTPS and how it upgraded the Web 2 and brought our lives online. If you think of HTTPS, it does not only provide privacy, confidentiality of your communication, it guaranteed the integrity of communication. You could finally talk, you can use any device, access your online bank, access your medical records, work accounts, and so on, and be sure that this communication is going to be protected and you're going to be talking to the right party. It doesn't matter who is in between, like all the routers, internet providers. You don't have to trust them. It's a trustless communication between any point on the internet to any other point. The ZK is doing the exact same thing for the world of blockchains, for the Web 3. It provides, from a different angle, unlike HTTPS, which enabled integrity of communication, the ZK enables the integrity of computation. Because the blockchain network, or like a network of many blockchains, is essentially a global distributed computer which performs distributed computations on a huge shared state. This state can be sharded, it can be different chains, but it's you can consider it just like the internet is probably one global computer with different systems, same with the world of blockchains. And to communicate trustlessly and seamlessly and without capital costs, you need this layer of integrity, and this is provided by ZK. So I think we're just leaning into one or another property of this technology, but it really has these two facets.
Yeah, I think that's a nice way to put it. I think that you can think of rollups as ZK rollups as being sort of a way to constrain the operator of a chain to only behave in a way that's valid. So you can take a chain that processes millions of transactions off of Ethereum, and you can prove and you can guarantee on Ethereum that all of those transactions are valid, and so you can scale by moving compute off of the main chain. I do think that it's important to emphasize that these systems are not mutually exclusive. We can have rollups that also provide privacy, and we can build private applications and smart contracts on ZK VMs as well. And so, I think that ZK just opens up a huge design space for both privacy and scalability.
Anything to add on that?
Yeah, I think this is a perfect point too. I mean, since this panel is all about versus, I think this is I would share a different perspective. So I think I agree that roll-ups and HTTPS, I guess in cybersecurity, there's three concepts that are often cited: confidentiality, integrity, and availability or authenticity, depending on who you ask. And I think what we just heard about from roll-ups is the integrity of computation. And I actually am not a big fan of the term ZK-rollups because I think the ZK snarks, the ZK stands for zero knowledge, and the academic term means the verifier learns nothing about the statement being proven. But in most rollup designs, including those deployed today, by virtue of how the structure is set up, where a user submits a transaction to a prover, the prover kind of learns the content of that transaction to generate a proof that then technically the verifier on Ethereum it doesn't reveal anything, but the blob that's posted alongside the roll-up transaction for security reasons can effectively be reverse engineered, and so it doesn't really get you privacy today. And I do think it's possible, theoretically, to imagine a world where you can do a ZK roll-up, and Zach should weigh in on this, but I think it's theoretically, or I think it's practically quite complicated. And so my personal view is that scalability is one reason that people have cited that Ethereum has not been more widely adopted, but I would argue that the lack of privacy, the ability for people to not hide what they're doing potentially in financial transactions, is more what holds the space back. So to me, that has to be the starting point and the prerequisite for further adoption.
Actually, ZK stands for these days for zipped by cryptography.
Well, we'll have to debate that on another panel.
Yeah, Vitalik said so, so like no need to debate.
So yeah, I think I'm obviously more with Alex here, but to articulate my thoughts, Alex and Brendan were saying about scaling privacy being roughly equivalent. At a very high level, yes, but I think that's like saying, I mean, yes, both cars and trains use internal combustion engines, but they serve very different purposes. Because blockchain is not just a computation environment, it's an execution environment, which defines an interplay between computation and state, and how the results of computation update persistent state. And if you want that to be privacy preserving, that requires radically different choices to be made when designing your network architecture and your systems architecture, which then leads to radically different choices in terms of the actual zero-knowledge cryptography technology stack that you select, because you have different resource priorities. So, yes, they are sort of the same, but we're rapidly seeing a large bifurcation in technology and architectures between scaling networks and privacy networks, or scalable privacy networks. And I think the further this space develops and the more that various networks specialize and refine, we're actually going to see more of a divergence between these protocols, and the more difficult it'll be to reconcile those technological divergences.
Yeah, I would maybe just clarify at this point that like in a ZK rollup, you're using ZK for both scalability and privacy. I would definitely not disagree that if you want a privacy preserving smart contract execution environment, that does not look like the EVM. Like, I don't think that anyone would disagree with that. Just
cool. All right, so I think I'm gonna go into the EVM camp here, the ZK EVM side, and really understand the unique designs that make you different, right, from each other. So, Polygon is using Vitalik's definition, a type 1, right, type 1 or 2, I would say. And then you guys, Alex, ZK Sync side, it's more of a type 4. So can you explain, what are the trade-offs there? How did you come to that decisions? Start with Brendan, please.
Oh, with me? Yeah, so I think Vitalik's framework for classifying ZK VMs, it just ranks types of ZK VMs on how close they are to the EVM that's used on Ethereum. And so a type 1 would be a prover with the ability to prove blocks for existing chains. So you have to change nothing about the chain, and you can just generate proofs. A type 2 is offering an environment that's functionally identical for developers and for users, but on the back end, it uses different primitives for like the state tribe. And then as you progress further down the classification framework, I think it terminates at a ZK VM where it's a different environment than Ethereum, but you can use a compiler to take some Solidity code, maybe with modifications, and run it in a Type 4 ZK VM.
So, like, I want to ask the audience a question. Have any of you run the virtual machine on your computer? Like, if you have a Mac, you run, like, I don't know, VirtualBox, and then you put some Windows programs there, right? Like, you can do that, and you can run any program in the exact same way. You just take the binary code, like for Microsoft Word, and you run it on the MacBook. Right? It will be in this window. It will have like the keyboard maybe will be like slightly whatever, but it will be slower. Or the other option is you can take this Microsoft Word code and you can compile it natively for your Mac, and then you can run it super smooth and fast, and maybe you can use some native features to Mac because your menu is going to be like more natively integrated and so on. So we thought if you're gonna be like, if the future is ZK and you're gonna be running like native ZK applications, they're gonna be much more performant, like massively outperform any emulated approaches, that it makes sense to start with this compiler approach. You can always add an emulator on top of that. Like for some specific cases, like maybe you want to run, like just port some special contracts and have the same address between different chains. You should be able to do that, but that's more an edge case. the default is you take the code and then you compile it. And this is why we chose the type 4 approach, to begin with the most efficient, most performant way. And if you check the fees, like right now, ZK Sync is by far lower cost than any other rollup, ZK or non-ZK, like by like at least 50% margin.
Yeah. So, hold for applause. One thing to point out though is that fees are massively determined by call data, which has nothing to do with the prover. I would just emphasize that if you look at proving cost, the proving cost is largely determined by the efficiency of the underlying proving system. And if you have more efficient proving systems, then regardless of whether or not you're doing a type 2 or a type 4 or a type 1, you will most likely have a lower proving cost. And so I think like our sort of thought process and design decision was based on the fact that if you give people an equivalent environment to Ethereum where all the developer tools just work, all the smart contract code just works, then the differences between, and I actually see Jordy in the audience, he is the man responsible for the first type 2 ZKVM, but it's a much better experience for users and developers because it's an identical experience to the L1.
Hey, that's not fair that you planted Jordy back there. I want you to know. But now, actually, I have a question on this. It's just a neutral question that I'm genuinely curious about. Is the goal, I guess, for both of your projects, is this characterization or this categorization, kind of implies some kind of progression? Do you all view is it the goal to get to the type 1, and if so, why, and if not, why not?
No, so for us, like we see different ZKVMs and different ZKVMs as satisfying different use cases. So like if you have an existing type 1 chain, an existing EVM chain like Celo or BSC or Polygon POS is like a really good example. Then you might not want to migrate that to a completely different ZKVM execution environment. And so it's a nice thing to be able to take a type 1 prover and instantly and seamlessly start generating proofs for that chain. If you're starting a new chain, you might prefer to make a different trade-off and use a type 2 for lower proving cost. If you have a non-EVM application or non-EVM execution environment, you might choose to use a ZKVM, and that's something that we're working on at Polygon as well. And so it's not like this progression where every chain terminates at type 1. I think that there are trade-offs, and developers should be free to make those trade-offs.
I agree with Brandon. I agree with what Brandon said, and I want to highlight a specific use case for when type 1 will be necessary, and this is why we're also going to bring it, and you guys are working on this. It's proving Ethereum layer 1 blocks themselves. Because once you can prove layer 1 blocks, then you can have your phone, like a wallet on your phone, verifying these proofs, and be sure that the Ethereum block that you're currently watching at is valid from Genesis, and all the chains that settled on this block are also valid, and you basically turn every single smartphone in the world into Ethereum full node. Well, like bringing 1 billion full nodes to Ethereum is a massive decentralization boost, and this is what's going to happen.
Okay, let's move on to the VM side and see how that debate goes, right? So within the virtual, like you're building your own virtual machines on both Aztec and Aleo, but you have very different approaches to that too. Aztec is an L2, and Aleo is its own L1. Explain your perspectives there.
Should I start?
Go ahead.
Well, for us, it was a bit of a no-brainer because of our, maybe just because of our backgrounds in the Ethereum ecosystem. But the way we see it, like, why is privacy useful? Privacy is only useful if you have value you want to hide, because nobody cares about how many magic beans you have, and so for us, we wanted to, from the kind of commercial perspective, we wanted to build as close to the layer that had value on it. That was a source of liquidity, so that it's much easier for people to bridge into Aztec, use Aztec-based applications that we're tied into the Ethereum ecosystem, that can be happening through trustless bridges because our consensus is derived from Ethereum. So that was the commercial reason. But the other reason, which was really something which is a general philosophy that I try to apply with Aztec, is play to your strengths. Our strengths are cryptography engineering, and building products and systems using that cryptography. We are not consensus specialists. We don't want to build a consensus network. We felt like that would just be an anvil around our neck, and the maintenance overheads of maintaining that consensus network over time and making sure that it was upgraded to use the latest innovations so it didn't become uncompetitive would be an unsurmountable source of friction for us.
Yeah, so I actually think it was a no-brainer to not build on Ethereum for the following reason. So as an investor, I remember a time when everybody said no one wanted to learn Solidity. They're like, we need to have Viper or whatever. We need to we need to create languages that are close to things people already know because no one's going to want to learn a new language. And I remember a time when people said things about, I know we're at an ETH conference, but Solana, where people were like, it's another layer one. Who needs another layer one? No one's ever going to adopt that. And I think the reality is that it's still very early days, and I think what will ultimately drive people to adopt things is where they find real utility. And in my view, cryptocurrency, Web3 in general, has not really found a killer use case outside of speculative applications. There are some, I think, promising early areas, but I think for the most part, I think if you just look at on-chain activity, you can kind of convince yourself of this. Most of the use cases are speculative. And I think to get around that, we need to build an environment from the ground up that's purpose-built to enable privacy, but also enable programmability, but maintain that permissionlessness that makes Bitcoin and Ethereum special. And I think if you do all that, then I think you enable the potential for new use cases. Identity is one that I'm very passionate about. And I think those use cases themselves, I think, could grow to be, billion or even trillion-dollar industries someday. And I think when you have from the perspective of a builder or an architect, I think when you add there's two ways to build. There's starting simple and then adding layers on top, like building a layer cake, which is, I think, how most people kind of think of Ethereum. You have layer one, layer two. I mean, Bitcoin's another example. You have Lightning Network, and you've got other stuff, right? But I think the trade-off there is every layer that you add, there's now an interface between layers. And many times, that interface, you have to, that's added complexity that you have to deal with. Like the whole concept of a type 1 through type 4 ZK EVM kind of gets at this. You're like, okay, well, I don't have, the bytecode is not quite compatible, so I just got to assume some different things about what hash function I'm putting in for this opcode. So there's just different assumptions that get made, and I think after a while, you get away from these core things that make a single monolithic blockchain unique compared to other types of software. So that's why we decided to build a fully integrated new layer one from the ground up to enable what I view are novel new applications that aren't possible anywhere else.
Could I just do a slight rebuttal, or maybe just focus on one point, which is that you mentioned that like the current applications on Ethereum on blockchains are speculative, and that and maybe I'm reading too much into this, but I might have detected a slight bit of disdain and contempt in your voice, and honestly, I used to feel that way, and I've changed my mind a lot because you play the cards you have, not the cards you want to have. As in, there is $1 trillion in blockchain today, a lot of vibrant applications, and the current activity that has been created by blockchain has created the environment in which we can build and design these advanced protocols and systems. That, what you call speculation, is literally paying your salary, and it's paying your bills. And will likely, possibly, you're going to have to draw your first users from, because those are the current people that use Web3. So I guess I would say, don't piss on your users.
Also, I can't rebut that.
Yeah. Sorry for being a bit harsh.
I also don't think it's like a unique thing about crypto that there would be a technological innovation that's accompanied by a financial innovation that drives speculation. If we look at the development of railroads, those were enabled by the development of the Joint Stock Corporation. And if you read what robber barons and their offspring and their failed children were telling each other, it sounds like shitcoin trading. Like they say, I only pick the railroad stock that goes up, and I just think it's maybe a little bit short-sighted to view what's happening at the very, very, very early stages of the development of this technological infrastructure as being sort of dispositive or reflective of what's going to happen even in the near future.
That's fair, but I do just want to characterize. So I think that's all fair feedback. But I do think, well, so speculation can be a positive force, but it's not. I think we would all agree it's not the end goal, right? I think the end goal is we have real useful applications. We have railroads that actually carry freight and do things that everyone, including outside of this conference, sees utility in. So that's the only clarification I would make.
Okay. I promise I'm going to ask this hardball question to you first, Alex. So, Alio has started 4 years ago. I guess this question goes to Zach to Aztec, right? 6 years ago. Why haven't you launched yet?
Sorry, I told her to ask this one. Look, these are very complex systems, and we only have one chance to get them right. And that's the nature of building blockchains. And I think, in particular, the choice, or the trade-off of the choice to build an end-to-end layer one that includes, a programmability layer, its own VM, a language, and a unique consensus algorithm that kind of accounts for all that and maintains the properties of privacy, permissionlessness, and programmability is hard. And there's a lot of ways it can fail. And because we only have one chance, and because everything is so self-contained, you kind of can't really launch until it's all together. So this is this is one explanation for why I think it's easier. I think it's frankly easier to launch a rollup, at least launch one. But I would argue that many rollups themselves are kind of incomplete. I think there's many people who kind of view, I think in the long term, this goal of having a decentralized sequencer. But from my view, I think most of those conversations happen theoretically, and I think when you look at what a decentralized sequencer actually is, it is kind of the completed product, which looks a lot like a layer one blockchain.
So, your question, why haven't we shipped? We have shipped. That's very unfair. So in 2019, Aztec shipped Aztec 1, which was a confidential transaction system for Ethereum. In 2021, we shipped Aztec 2, which was the world's first ZK rollup. And in 2022, we shipped Aztec Connect, which enabled Aztec 2 to interact interoperably with DeFi protocols in L1 and provide a privacy shield. So we have shipped. We've not shipped the grand design. And the reason for that is the technological hurdles we've had to overcome are fierce. And we've had this process over the last 6 years where basically we have taken the best technology available, which we've had to invent in-house because existing stuff just wasn't good enough. And we take that technology and we push it to its absolute leading edge and create a product that uses it and launches it. And it's only been in the start of 2023 when we had confidence that we had all the ingredients in place to build the full programmable private smart contract vision. And so that's when we made our move to actually, put our foot down and grind on building that. But I guess to really answer your question, shipping takes longer when you have extreme technological barriers in your way that you have to kind of pickaxe through Minecraft style through invention.
So I think I wanted to ask the rollups here, right? Since that was mentioned by Alex, the single sequencer, making it very decentralized, and do you think it make the chain less permissionless?
Less what?
Permissionless.
Oh, of course. Like the centralized sequencer does make the chain less permissionless because the operator can censor it. So this is why we have been working for a long time on making a decentralized layer 2 consensus, and we want to switch to it as soon as we possibly can. Because the permissionlessness is the nature of blockchains. This is one of the most important, three top most important properties. But along with verifiability, or trustlessness in other words, and so the reason we even launched this centralized sequencer in the first place is because it does not compromise on trustlessness, right? So even though it's, the transactions in L2 are kind of permission from the sequencer, but the user is not permission to exit. They can always exit because they can prioritize transactions on layer 1 through priority queue. So if they don't if they are not welcome in the system, they can always leave. So this is already a very important piece of permissionlessness there. But of course, we have to transition, and we will, to decentralization very soon, this year.
Yeah, completely agree with Alex G. I'd also say that there's, I know, Alex, you've expressed maybe some frustration about the roll-up roadmaps in the past. Yeah. And I think it's really, really important to emphasize what Alex just said, which is if you're launching an L1, decentralization is essential for security. Like, in order for your funds to be safe, it needs to be decentralized, and that is not the case on a rollup. Obviously, like, if we think about the like Maslow's hierarchy of chain needs, like security is kind of at the bottom, and then if we move up, like obviously we care about censorship resistance and permissionlessness, but those are like, you know, like we need to think about decentralization as being an instrumental goal to achieve those things, and like to really be specific about what the requirements are for L1 and L2 to be secure.
Okay. Let's move on to the next question. On the performance of the chain, right? So, you know, Alio, to do proving, it takes 5 times the time as opposed to on ZK-Sync, right? So is that because we use client-side proving, and why do we care about that?
Yeah, so I think, look, so the proof system that we have is a little less performant than some other choices, particularly those built on Plonky 2 or Stark-based systems that have more performant provers. But a principle that we really try and build for is this permissionless system where a client can be a prover, right? And this is very similar to how Zcash works. You know, Zcash, you can send a transaction to a Z address that's shielded effectively, right? And I think there is an interesting distinction happening right now in the space as to whether or not that's an acceptable trade-off. Whether or not it's okay for there to be only one prover or maybe a handful of proving marketplaces that have specialized hardware that can generate the proofs, or if you want to have the ability to generate a proof be more democratically available, you could say. So we very much feel, at least I personally see, that there's definitely going to be a world where proof generation is outsourced because people are not going to want to pay the costs associated with it either in time or money. But I do think it's critical, back to this core principle that I think Satoshi really first, you know, kind of enumerated around permissionlessness. And it really, if you look at if you read the Bitcoin white paper, a principle that's very clear is, and part of that is egalitarianism. Like there were big banks and there were not big banks, and Satoshi wanted to build a system to not recreate that. And I think very much for me, a principle that motivates me is making sure everyone can be a prover, right? And there doesn't have to be a bottleneck. That comes at a cost of performance. Sometimes, right? If you're generating a proof on a client-side MacBook, it's not going to be as fast as you're running several, you know, servers in the cloud that can recurse and potentially aggregate a bunch of proofs together.
Can I quickly add a comment so I know we're running over?
Sure.
I broadly agree, but I also think that it's very dangerous to in this space we have a lot of ideological overheads, I guess you would say, that companies have to operate on. We need to be, our decision making needs to be nominally democratic, maximally transparent, and things like egalitarianism, everyone can run a prover. Not everyone shares those views, and it's very easy for other people to kind of abuse those ideals by shipping faster, by ignoring them. So I think it's just something to be mindful of. Like on our end, for example, to be honest, it's a very nice to have if anybody can run a full like roll-up prover for Aztec. But you know, for V1, you know, that's not something we actually care about that much, because that can happen like 2-3 months later. You know, you get the core tech nap down, maybe you need to run a really beefy compute to make a roll-up proof. But then, you know, in 6 months, the tech advances, you're good. What we care about the most is client-side proving, because our clients have secrets because it's privacy, which is the same as you. Which has necessitated an enormous number of architecture and technological changes to our protocol to enable that rapid client-side proving. Which also just means there's a happy accident. Proving a roll-up of Aztec is a lot less computationally intensive than a ZK VM. Yeah.
Yeah, and I would just say, I think one thing that I think about here is I completely agree. Ideology is not the basis to make a decision around a product. I think what users will use it for is the basis to make a decision around a product. But I think for the certain use cases, and I mentioned identity a couple times as one that I think is incredibly important. As you pointed out, like a user's identity information is secret. Like if you have to send that to a server to generate a proof for you, you've kind of created a more expensive version of OAuth, in my opinion. And what I think is really novel, if you want to implement a protocol like ZK Creds, you know, you do effectively have to rely on the client who has the secrets to be able to you know, maintain that secrecy for that use case to work.
But, so it's really important to emphasize though that like a lot of those use cases are completely compatible with Ethereum. Like the only time that you truly cannot build a privacy-preserving use case on the EVM is, I believe, when you have you require anonymity for payments. And so like a lot of the identity use cases we're already seeing being deployed on Ethereum, on L2s, and you could say, yeah, it's like expensive to verify proofs, but with proof aggregation, we can amortize the cost of verification on the EVM.
That's really not the point, but we don't have enough time to I'd love to argue that. I'd love so much to spend a few minutes arguing that.
Oh man, we got to have a sequel to this panel. All right.
Yeah, we have to. Yeah, let's end on a maybe merrier note here. What are you most excited about in the ZK space in the next 12 months? Start with Alex.
The rise of ZK networks with hyperchains, what we call hyperchains connected with hyperbridges, like many blockchains feeling like a one seamless big ZK network.
Yeah, I think further developments in pushing proving systems further, pushing the technology further, and yeah, the Polygon Ag layer. So.
I'm most excited about applications and built by many of the developers that are in this audience on any of these protocols that solve a real-world problem that my grandmother finds utility in.
Yeah, I'm with Alex there. But things that particularly interest me are basically identity. If you can link identities to cryptocurrency accounts uniquely, then that enables blockchain to tap into the real world and affect real-world identities.
Cool. Great. Let's give it up to everybody on the stage. Thank you, Alex G, Brandon Farmer, Alex Pruden, and Zach Williamson. Thank you.
You're good to start whenever. Anytime? Yeah, might as well. 20 minutes. All good. Thank you, sir. Hello. My name is Erman, and I'm here with Flat Money. And today I'd like to talk to you about ETH. So we think that ETH, the value of ETH, how ETH is used, the utility of it, is actually really important, especially now since we've made the switch to the proof of stake, because at the end of the day, that's what's securing the Ethereum network. And I'll talk a little bit about the history of ETH, how it used to be used, especially with users, the RCO days, the first initial dApps, and how that's kind of evolved over time, and the role that USDC or stablecoins have started to play within DeFi, especially in how that's impacted the Ethereum network, and kind of what we can do better, some of the risks, and what we can do better going forward. But one of the questions I really like to ask, because this is always interesting for me, and people sometimes feel very passionately about this, is ETH money? So I'd like to get a show of hands from anyone here who thinks that ETH is money. Got a lot of hands. A few people with their hands down. Okay, that's most of the people. Let's go the other way around. Who thinks that ETH is not money? Ooh, we've got a couple of contrarians there. Okay. Well, this is like the consensus, basically, within Ethereum that, most of us do believe that ETH is money. And maybe the question to ask is, what makes good money? What are the sort of good attributes of money? And some of the things, classic things like, is it durable? Is it portable? Is it divisible? And crypto assets in general, have this attribute by default, which is great. As we sort of go down the list there, it's like store of value. And actually, you could apply this to many different tokens and assets. And actually, there are many legitimate crypto assets now that do have, a store of value and are valued on chain. But as you go down this list, you start to look at the unit of account, the medium of exchange. What are crypto natives transacting in? What do they want to get paid in? When you do the denomination of your, the assets and the services and the applications, in what units are you thinking? So, just going back in time a little bit, going back to the RCO boom days, a lot of projects raise a lot of money and they're mostly raised in ETH. So this is really great. Through 2017, ETH was going up in price. The treasuries were looking really good. The runways were looking long. And the early stage applications, and this is Augur, the first predictions market that went live on Ethereum network. And you can see like everything is denominated in ETH, the estimated cost, the fees, the limit prices, everything is priced in ETH. And this was the norm back in those days. And of course, this was great, during the early 2017 ICO boom. ETH price was going up, everything was looking rosy. And then of course, the ICO bust came. And at that time, things were not looking so good. A lot of people lost a lot of money, but a lot of projects that were funded with ETH and stayed in ETH, their runways dwindled, and many of them couldn't even launch their projects. This is also a problem for the applications that had ETH integrated. It wasn't a great user experience to see the value of your assets decline so rapidly. And then, of course, the rest is history. DeFi summer, the winter, and I don't know what we call this next cycle, but if we called it this, that would make me pretty happy. But the point is, there's a lot of volatility in ETH, and people want to have control over the volatility of their assets, and they want to decide when they want this sort of volatility and when they don't. And that's really what was the catalyst for the rise of stablecoins. And stablecoins really started to jump up, especially the centralized ones like USDC and USDT, and they saw a lot of use cases coming through. And we started to see the decentralized applications start to integrate a lot more of these centralized stablecoins to improve the user experience. And and even regular people that were using crypto to transact with, there are some people that talk about countries with high inflation, like Argentina, that the crypto natives there. What do they use? What sort of crypto would they like to receive as payment? And usually they're going to come back and they're going to say, well, stablecoins. And even people in this room, all the service providers out here, when they accept crypto payments, what do they want to accept? And usually it's stablecoins. And as a result, we're really seeing the market cap of the stablecoins rise. And you can compare that against the ETH market cap, and it's up to 35%, I believe, over 140 billion now. And some people are saying that the stablecoins are set to boom even from here, that the stablecoin market cap is going to jump up another 10x. And the thing is, the stablecoin market cap is kind of uncorrelated. It's not directly correlated to the ETH market cap. So you could have this scenario where the value on chain that's being settled and transacted every day is a lot higher than the ETH market cap. There's nothing, theoretically tying them together. And where that could create an issue is really a small portion of that is what's securing the network. So ideally what we should be striving for is to have our assets as they scale, that they also directly scale the security of Ethereum along with it. And of course, with centralized stablecoins, a year ago, I woke up, look at the news, and this was all over the news globally. We had, bank failures, bank run, and, a real crisis. And I thought, oh, okay, there's a bank run in the US. That's fine, of course, until I looked at the USDC price and I was in shock. And of course, part of the collateral was in these banks. And, it made me really question everything. This shouldn't happen to USDC. It should have happened to USDT because that's what everyone's talking about, right? And then I came to the sad realization that I'm probably just following the wrong crypto Twitter account, so maybe I need to start again. And even with the decentralized stablecoins, where they first started off, you could just mint stablecoins with ETH. It wasn't particularly capital efficient. You put in $200 of ETH to mint $100 of DAI. But this was good in the bull market because ETH is going up in price, your collateral is safe, but not so good in the bear market where you're basically about to be liquidated. So you either have to close your positions or get liquidated, and this wasn't particularly good for MakerDAO and the DAI market cap. So what they decided to do is say, hey, this doesn't really, there's a lot of volatility here. Again, it's a volatility problem. Why don't we collateralize DAI with real world assets? Now, what does that mean? Well, essentially, an institution can come along and say, hey, we want to borrow whatever, 100 million DAI, and look, we're going to sell it, we're going to put that USD in the bank, we're going to re-lend it to another company for more interest so we can make good money, it makes sense, or we can buy short-term securities and earn more interest. And that's a good thing. It's good for MakerDAO. They can make the revenue. These other institutions can make the revenue. But once you dig deeper, it's like, what are we doing here? And, at the top layer, the crypto layer, the DeFi layer, DAI goes out, and eventually DAI comes back in. But once you dig into the off-chain, the TradFi layer, and I'm not going to go through this, but I just want to give you the picture. There's a whole lot of custodians, trustees, a lot of flows, underneath all this. And then, the question is, what does this look like? And you've got the DeFi layer on top, and you've got the TradFi layer down the bottom with all of the issues and lack of transparency that comes with that. And I'm not an American. I don't know what to make of all this, but there's some risks, coming along with all this, right? And at the end of the day, Circle, who issues USDC, they have the ability on chain to block any accounts. And then the question is, if the regulatory environment does change, what does that mean for the holders? But even more, what does that mean for the DeFi protocols where these stablecoins are integrated so deeply? And then zooming out, what are we doing? Does it make sense that, if a single bank sneezes that the whole of DeFi catches a cold? Does it make sense that we're so tied and connected when originally we were supposed to be building a system that actually improves on the legacy systems? So if we zoom out, what should on-chain money really look like? What are the properties of money that we should be striving for? It was even in the original .com era, companies were sort of dreaming of creating internet money, and we finally have the opportunity to do it and to do it right. So, for us, it's really about low volatility, but also maintaining or increasing purchasing power over time, doing that in a decentralized way that cuts off the legacy system and doing it purely on-chain with smart contracts. Can we make it accessible for everyone? L2s are scaling, the fees are coming down. Can we build it on something like Base? And I think that point is really important in the next one, which is, can we have these assets directly secure the Ethereum network? Can we have these assets stake ETH or increase the stake of ETH so they scale together linearly? And of course, what many projects are striving for is really building the new primitives and making sure, well, for us anyway, it's about minimizing external dependencies to be able to do that properly. So I won't go into details about what Flam Money is and Unit, but Unit is essentially a flat coin, which is flat purchasing power over time. But we're backing it 100% with Rocket Pool staked ETH, and we believe this to be the most decentralized liquid staking derivative of ETH that there is available today. And essentially what we've done is we've created a two-sided marketplace. On one side, we have the low volatility of ETH, where we completely strip out the ETH volatility to create the flat coin. And on the other side, we have a perpetual futures market for staked ETH. And what we built out of this is essentially a new primitive that's built on ETH. You take your ETH, which is already fantastic collateral, you stake it, that's the new primitive that's been created, and we convert it into unit where we just strip the volatility. But importantly, we inherit all the decentralization, the staking yield, and the staked ETH that secures Ethereum on top of that. So which direction, there's a lot of presentations here about real world assets bringing the real world, but there's like a counterpoint to this as well, what we could be building. And of course we have ETH, it's great collateral, on-chain collateral of the internet, and what we've been able to do in the past is reduce the volatility by minting stablecoins. And as mentioned, it's less capital efficient, you still ride the volatility of ETH. It's less than ideal, but hey, we can do that. But then, of course, once we switched to proof of stake, we created new liquid staking tokens that not only secure Ethereum, but are yield-bearing, which is really good. And then we realized, oh, wait, this is great collateral. We can use this collateral to then restake and secure other networks, which is fantastic, still riding the volatility. And at Flat Money, we've realized, hey, we can actually take the asset, this fantastic collateral, and just remove the volatility out of it. And what you get is like low volatility collateral, and there's no reason why you shouldn't be able to more capital efficiently mint your stablecoin or use that as collateral for restaking. So once again, there's kind of the two camps here. There's a lot of people saying, hey, if you want legitimacy in crypto, you got to go out to the legacy world. You have to go out to traditional finance. We need real world assets to scale Ethereum. But we believe that actually these on-chain derivatives, we've only started scratching the surface. This space is so young. We can build assets that are orders of magnitude better and actually impossible to build on the legacy systems. And this is what we've always strived for. So thank you for listening to the talk. We're Flat Money. We have a booth next to Base, next to the coffee shop. If you're interested in what we're doing, come say hi. Cheers.
Hello. Oh my God, full house. It's a big audience. Woo! You. All right, thank you for having us, guys. Thanks for turning up. We're going to have a great conversation about balancing. Oh, thanks, Benny. Balancing fun and profit in Web3 games, probably my favorite topic to riff on. And we have an amazing panel here. I will introduce you guys very quickly, just so that we don't spend too much time on intros, because we've only got 20 minutes. World-renowned economist who has worked on designing the game economies of some of the best-known, best-loved Web3 games out there. We have a founder of a Web3 gaming company and one of my favorite Web3 games in the world, Crypto Unicorns. But also with a long history working in Web2 gaming. So a lot of legacy learnings to be able to bring over to the industry there. And that's Aaron Bierschmidt, Lisa J.Y. Tan. And we've got Benny Jiang. He is the co-author of ERC 6551, which is one of the most exciting new trends in NFTs coming up. And he was there for the dawn of things like CryptoKitties, Dapper Labs. So again, we've got a lot of clout here. So just to get us started, I think there's a lot of learnings that we need to unpack in terms of what's happened over the past couple of years. Aaron, maybe you want to kick us off. You've been there right on the front line, building what I think is a brilliant game, but it hasn't been, a smooth path to success. So what are some of the biggest things that you've learned in terms of building a game that can balance fun and profit over the last, 2 years, 3 years? Yeah.
We need a much longer panel. TLDR, I focused a little too much early on in trying to embed as much economic depth within our system as possible. That was both a good thing in that, for the first 9 months of shipping the game, there were more tokens going in than coming out, which very few to almost none of our competitors can really make that claim. The challenge on top of that is I didn't think about completing the economic loop. And we launched without a fully complete economic loop. And what I mean by that is, for example, the economic depth of the system incentivized players to breed a lot of unicorns because they needed a lot of unicorns. It did not incentivize players to optimally breed high stat, good gene unicorns, right? And ultimately that inflated the supply. We now have hundreds of thousands of unicorns. With relatively low demand, you can imagine what happened to price on most of those unicorns. Obviously, a super high tier legendary unicorn just went for tens of thousands of dollars, right? So there's a big range there. But again, we launched without a complete economic loop. We've just completed it with the Glue Factory, which lets you take your donkeys, your low stat unicorns, burn them for unicorn souls, and use those unicorn souls to equip gems for your high stat, high tier, high rarity unicorns. And that embedded a deflationary mechanism into the system that is tied to the actual vertical progression of your remaining unicorns. And in 2 weeks, we've already seen 1% of the supply burned. And I look at that and go, we should have launched with that. And so in the rush to kind of hit the tail end of the last bull and get a game live and out, we didn't take the time to, again, complete economic loops. And that would be my advice to any developer launching a game today, is making sure you really have the full system, because once you let an economy out of the bag, it's impossible to put it back.
So I'm just going to tap on...
I hoped you would.
Yeah, so I'm going to tap on Aaron's point. When we talk about the game system, and people usually think about the supply side, right? How do I introduce new supply into the system, and how do I build that? How do I use tokens to look at user acquisition? Nobody thinks about user retention, but that is how games work. You need to have high level of user retention. And we talk about the minimum, almost like the minimum viable system or minimum viable economics in place. It's about not getting the full model in place that you guys have done now, but you need to get at least a minimum viable system in place on sinks and faucets for things to run. Minimum viable doesn't just mean what is the user or what's the token introduction into the system, but how do you take tokens out? How do you balance between value created, intrinsic value created in the game, and the assets that will represent the intrinsic value so that we can find market value, which are tokens. That balance is something that projects don't see. Projects are just thinking very short term. I'm looking at user acquisition, and because that's what my investors are looking for, and I just want to pump it. But how do you sustain it? The pump just doesn't stay like that. You need to find ways to close the loop, and that is what minimum viable economics will look like.
Yeah, I couldn't agree more. I mean, that is the whole, that's my point, right? Like, you've got to find a way to do that. Otherwise, you're going to let an economic system out of the bag, and it will go in one direction, which is towards collapse.
I mean, we saw that with CryptoKitties as well, right?
I mean, yeah, there's like 2 million CryptoKitties, and like, I think when we first began, we never really thought about how deeply the economic systems can get, right? Of course, with CryptoKitties, we never introduced an ERC20, like kitty coins or anything like that, but that would have created another dimension of like a double-edged sword of good and bad as well, so I 100% agree.
So I'm just going to add one more point because I have just a lot of points to add, and 20 minutes is definitely not enough. But when we think about token utility, the tokens need to exist for a reason as well. And the main goal of an economy is sustainability, but sustainability from a fun perspective. If the game is not fun, if everything you're designing is financialization in mind, the game will not scale. As you mentioned, people will have a lot of supply. There isn't a demand because there is no intrinsic value to hold these assets. So you're just building for the sake of building, and it just does not work. That is not sustainable, that doesn't work, and I have no idea how people keep funding such activities. It's almost like a hobby, not a business, and you don't fund hobbies, you fund businesses that actually is sustainable. It's a sustainable, growing economy that generates revenue and fun for the players and for the studios.
I mean, yeah, I'll echo that. It's the only way to keep value in the system over time, right? If it is purely a financial game, people will optimize towards that, and they will leave as the rewards falter, right? We're going on 2 years of 24/7 live operations of our game, and we have users who've played every single day that we've been live, right? So the only way you really retain people over time is obviously to build an experience that captures them. Now, one thing that I like to debate is obviously there's a lot of different flavors of fun. Some people don't like our land gameplay, but really like Rainbow Rumble or really like Unicorn Party, some of our ecosystem games, right? And so there's a wide spectrum of what people consider to be fun, and ultimately you have to fall somewhere on that spectrum to ultimately have a sustainable ecosystem and product.
Yes, I couldn't agree more. Like, we said we weren't going to do this. We were going to debate. I wasn't meant to say, like, I agree. No, but it is true. Like, I think a big problem we've seen over the past couple of years with Web3 games is that they were overly financialized. A lot of the people coming into those games were only looking for finance or profit. My personal opinion is, and I actually wrote a CoinDesk opinion column about this recently, but I do think we could have a cohort of players that are incentivized by that, but problems come in when everybody expects to earn from the game. But I just wanted to like zoom out a little bit, right? Because we were kind of talking about specific games. Lisa, are you seeing that a lot, like in terms of learnings from the last cycle? Like, what do you think will be the trends going forward in terms of game design and sustainable token economics? What do you think we're going to see that's going to be quite markedly different to the last cycle?
Yeah. Very good question. There are a lot of trends that were working and were not working, and there are a few that I want to pick up. The first one will be understanding what utility or what is the origin of value that is embedded within these assets. So we talk about different kinds of fun, and these fun is usually a reflection of who is in your game, who's in your system. If you're marketing it as a hyper casual, but you get to earn money kind of thing, then you're attracting the kind of people that are looking to extract value, and whatever. That is fun to them. It's extracting value, and you can embed all forms of cool long-term value creation in your token, but nobody will care about that. So something that it's quite talked about in like more serious game studios. I don't know if it's for every game, but things like the LVT, it's a kind of taxation model for NFTs or for assets. So in the physical world, we call it land value tax. Have you guys heard of that? So it's taxing land and increasing the utility of these assets in the space. So we have all these, metaverse kind of decentral land, and these are the great metaverse ecosystems that's selling land, but the people are just buying land for the sake of holding land, hoping that it will exceed in prices. What we need to do is we need to create incentives to nudge people to be creating value. That's the main important thing. How do you create value, and how do you embed these value creation within tokens? The second thing is, and then it's like NFTs or non-fungible tokens, doesn't matter. You just need to embed that. The second thing is probably more on the lesson simulations, more on data analytics side of things. You talk about live ops as well. And there was a huge chunk of people just focusing on running simulations. How do you build games? How do you turn them into simulations? How do you get that data to figure out what to edit and change? The thing is, games are basically like economies, like countries. There's so many diverse economic agents, things that they could do, and that's where AI could come in to expose what the variety of economic agents are. So how do we even simulate these things? There's so many points that we just don't understand, and simulations just probably it's not going to scale. It's not going to be that. I'm not that bullish on simulations on game validation. However, data analytics is going to be very, very important. How do you measure your user retention? I would like investors to start talking a lot more about what's your 7 days, 14 days, 90 days retention. How do they how is that related to ARPU? How is that related to the DAU? How does that relate to value creation in the space? There is not enough analytics on that. And one of the problems is that 90% of data is off-chain. And so there are not a lot of, there's probably like 1 or 2 game studio or analytics firms that's trying to aggregate all the data together, and there are quite a few people trying to figure that out, but we're not there yet, and I hope this will change. And the third one will be investors, which is a very key big player in this entire ecosystem we're talking about. Because we can talk about building the best model, we can talk about going in-depth into the economic stack, we can build everything out, but investors have an incentive to say, I need my returns. I'm going to give you money, I'm going to give you funding, but if you don't give me some returns, why am I funding you? I'm not funding your hobby, I'm not funding I'm not funding it as a subsidy to get users. I need to get returns. And that's where we go back to the whole point of we need to talk about financialization in this game. And that's, to me, that's a big struggle. And I would like to know how you guys deal with that, because you've got one part of the economic agent, which are investors. I'm putting money in because I'm expecting money out. You need to give me that model. And the other parts will be players that's interested in playing the game, and fun is what they want to maximize, not exactly the financialization part. These are opposing factors, and we need to embed both in the token and in the model. I find it quite a bit of a challenge.
I have a question. Do all players have to be humans? Is fun only because we as humans want to have fun while playing games? But if we're imagining games in the future where there are agents or NPCs or whatever, and they're playing the games and we're kind of managing them, like, is that a job or is that fun? And do we need to optimize for fun? And how do we kind of assess metrics at that point where D7, D14 is based on a human coming back and clicking a button, but a bot or NPC will click the button no matter what because it's programmed too. I wonder what we think about this topic.
So just before you dive into that, I feel like that was a very loaded question, Benny. Do you want to just give us a quick elevator pitch on ERC 6551 and particularly what it could potentially do in terms of when it's coupled with AIs bringing NPCs to life?
Yeah, so I was part of the team that worked on the ERC 721 standard, the NFT standard. And then 7 years into the future, which is last year, at ETH Denver, we released a new standard called ERC 6551, token-bound accounts. The TLDR is we linked every single NFT with their own wallet or smart account. And so now an NFT has 3 new properties. One is asset ownership, second is social identity, and the third is programmability, which brings us back to games of like what happens if you program an NFT to play a game that's on chain on your behalf, earning these tokens and driving up the metrics. Is it still a game? Is it optimized for fun, or is it not?
I mean, that just comes back to my point. There's many flavors of fun, right? Inside of our game, particularly core land gameplay, a lot of the fun is in the Forex strategy side of that. It's how you're optimizing your setup for players running teams of scholars. It's actually managing those players. And you can say, well, that's kind of a weird game. It's almost a job. And anyone who's played EVE Online better understands, like, people can obsess over these kind of games and these systems because they're deep. And there's opportunities for specialization. There's opportunities to corner the market on certain items. Like, again, there's a spectrum of players who are going to find that very enjoyable. And, again, our retention speaks to it. Our day 365 is 24%, right? I mean, that's an insane number that most Web 2 games cannot compete with. You can't say in the bear market that all of our players were making so much money that they just sat there for 365 days pulling cash out of the machine. Especially with what I said earlier, where we were net tokens into the game over the first year. So again, there's a whole spectrum of fun, whether it's AI bots, whether it's scholars, et cetera. There's an aspect of fun to being the authority, being the manager, and not necessarily being a grunt or a grinder.
So I'm going to go the other direction. And let's debate for a little bit. So, fight. So I think there's a lot of opportunities in that. At the same time, I'm just going down the dystopian way, right? There's a theory called the date internet theory, where 99% of everything online are bots. So we're just using bots' behavior to train more bots, and it's just all bots. Humans just become the manager. But what's the fun in that? A lot of the people that I know and work with, nobody likes managing. People like doing the work. And people like doing the grunt work because there's a level of satisfaction to see your input result in an output. Management of people, management of bots is very passive. How do I know I'm doing well? I don't know. I think the happiest...
It's a factor of how well your bots are doing, right? If it's fully on chain, you cannot avoid this problem unless you have a solution to it, right? Because anyone can interface with our contracts and build a bot around it, right? And so at the end of the day, you foundationally have to accept the idea that AI agents are going to be in your system, I guess is my counterpoint.
Yes.
Okay.
I think there will be some level of AI agents in the space, but when most of the players, those creating value are AI agents, then this changes the social economic structure of this game that we're talking about. People become capital owners, and only the rich can become capital owners that outsources the work to these bots, and we're just adversely selecting for a greater inequality divide between the agents in the space. And that is a very strange society that we're living in. That who is having fun? It's fun sitting on the owning capital, having AI bots working for you, and you just have a big fat paycheck at the end of the day. That's like heroin on steroids for games.
Oh, this is great. So I'm on the flip side of you because there's one element that we cannot change, which is time. We all live X amount of years. We all have 8 hours of work a day, and you go home, you cook some dinner, and then you go watch Netflix, and you go to bed, right? So that element we cannot change. So what this does is it kind of questions, what is important to the human, right? Is it 8 hours a day working your normal job, or how many hours do you spend in a day playing a game or mobile game, maybe a few hours? Does that time kind of abstract into this AI agent, this NPC that does it for you, and now your element of fun is actually going outside and enjoying the sunshine while the agents...
Outside? What's that?
Yeah, the fictitious sunlight. But so that's what I would say about time is the element.
I agree. So I call that time arbitrage, and we see that in a lot of games, right? You see that a lot of game farmers are in a lower socioeconomic kind of society or countries because it's cheaper, or you make more money spending 1 hour playing the game than 1 hour in minimum wage. So we see that time arbitrage already with real humans in the system, and they're just working because they're grinding, they're making money. But are they creating value? That's the key thing. And now we're just changing these humans in developing nations to AI bots, and are they just creating for the sake of creating to return it to the capital owners, which are people who own these bots? And what does that mean for us? What does it mean for games? Are we just building managers, like a game for managers, and then we're going to train them to become managers of a company? What's the end goal? What is fun? Is that fun?
See, you're just talking to someone who played Sid Meier's Alpha Centauri and Sim City and all this shit, right? So I've played games that, where there's minions that do your bidding, right? And again, whether they're AI agents, whether you're running teams of scholars overseas, et cetera, there is fun in that. There can be a lot of fun in that. And then from the perspective of sustaining the economy over time, you have to ensure that how does it capture value inside of it? Yes. And to your point, it is that whole spectrum of I am a more whale-oriented player. I want to deploy these bots. I want to deploy these scholars. I'm putting money into the system. I'm obviously looking over time to get some out. I'm taking a bet that this economy scales, beyond when I entered it. And then the hope is on the other side, you have players coming in that go, you know what, there's some fun here. I mean, shout out to Pixels. I think Pixels is showing this has a very interesting model. We'll see if it sustains. I have questions
Pixels
around
on the
it,
Ronin network, really killing it right now.
They are, and it is a very interesting thing because you have the 5,000 land NFT holders, and then you have the grinders who come in and work on that land, right? Many of them, I would like to think, are probably bots.
Well, actually, yeah, the CEO of Pixels, Luke, has actually come out and admitted that he thinks probably only about 40% of their 180,000 DAU are actually real people. And the majority of them are coming from the Philippines. So, Yeah.
For sure.
Guys, we've only got 11 seconds left. I just want to say quickly, my favorite takeaway from this panel was many flavors of fun. I think we all have different perspectives in terms of how to build these sustainable game economies that balance fun and profit. But the most exciting thing about Web3 is this is the first time in history that we've been able to actually successfully and legitimately integrate secondary markets and interoperability into these economies. So I think that's when we'll really be able to explore what all those flavors of fun may be. So I just want to say thanks, guys. That was a spicy panel. I just wish we had more time.
Thank you, Leah. Thank you, everybody.
Hey guys. So up next we have Martin Durker from Zirkit, who is going to be discussing sequencer level security.
Awesome. Thank you very much. So welcome everybody. As said, my name is Martin. I am the technical lead and co-founder at Zirkit, and I will be talking about how we treat security at Zirkit and its sequencing protocol. So when you now look at blockchains, what is the state of art for security that they offer to end users? When you take a transaction, you broadcast it to the blockchain, to your favorite node, right? And then the node does a whole bunch of stuff. It checks that the payload it received is well formed, that it actually is a transaction. It will check that the transaction is properly signed, And it will also check that the transaction is valid for block inclusion, right? So it will check that we have the proper nonce that is expected for the account that is trying to transact, that it has the proper chain ID. So, the transaction was actually meant to be transacted on this particular blockchain. And then it also checks some other stuff that is, introduced by various fork rules and similar things. So the bottom line is that the nodes, they actually secure everything that is important from the chain, right? They follow the block formation rules, and they secure the chain by forming the consensus on the content. What they do not do at all is security for the users. They do not care what is contained in the transaction and what the transaction will actually result in, right? So what is this talk about? This talk is about Zirkit and its sequencing protocol because it works a little bit differently. It brings security to the level of sequencer. And this talk specifically is about how we do this with very minimal impact on principles such as censorship resistance or data permanence and redirection of the chain. Okay? So before I go deeper, let's take a look how transactions normally flow through a rollup. Okay? So you are the user, you have a transaction. This is what I'm depicting by this little note, right? So you take this transaction, and the transaction goes to some blockchain node. Then, in the context of rollups, we actually have one system component, one service, that is called the sequencer. And the sequencer is responsible for collecting transactions, and whenever it has enough of them, it poops up a block, and it appends this block into the blockchain, okay? So this is my L2. And this keeps happening for a little bit longer. I also have my L1, and at some point when we have collected enough blocks on the L2, we take the state root that represents the current state, the current tip of my L2 blockchain, and roll it up into some smart contract on an L1. So this is the process, how it normally works. Here I'm going to make a pause, because in Zirkit, we clearly do this slightly differently. So this is the high-level concept of what I'm going after. And then in the rest of the talk, I will be explaining the details, how it actually works in the nitty-gritty, okay? So on Zirkit, the beginning is exactly the same. You have a transaction, and you broadcast it to the blockchain. Somehow this transaction makes it through the peer-to-peer mechanism to the sequencer. But before the sequencer includes it into the next block, it is actually going to scrutinize it. It is going to ask some kind of an oracle whether this transaction is safe for block inclusion with respect to the user. So is this transaction here to hack something, or is this transaction here to not hack something? And if the answer is that the transaction is safe, then everything happens the same way how it would happen normally. So the transaction will be included in the first available block, and everything is fine. If the oracle responds, no, this transaction is here to cause some damage to the users, it is here to hack your favorite protocol or do something that we do not really consider cool as users, then the sequencer is going to handle it differently, and we want for the sequencer to put it into the quarantine for some time. I'm going to elaborate on what exactly this means in a few seconds. Okay? So the malicious transactions go into the quarantine, the honest ones and benign ones go directly into the blockchain, and the rest of the process is exactly the same. We will be waiting for sufficient number of blocks to be formed, and then eventually take the tip of the chain, and in the form of the state root, we are going to roll it up. So now, if you're a developer or somehow technical, you must have a whole bunch of questions. How exactly are we doing that, right? So what exactly does it mean that we place a transaction into the quarantine? What happens with that transaction once it has been placed into the quarantine? How do we actually tell if this transaction is malicious and it should be placed in the quarantine? And then we also have some specific or special types of transactions. I'm going to call them here deposit transactions from L1 that, if you know something about rollups, also require some kind of a special handling. So I'm going to address these topics in the rest of the call. So the first question, what the hell is the quarantine in the first place, right? So now I'm going to sort of switch from the generosity into the specific implementation that we are following in Zirkit. So Zirkit is actually implemented based on Geth. Now, when Geth handles transactions. It follows this simplified lifecycle. It maintains two pools. One is called queue, and the other one is creatively called pending queue. So, we have a little bit of term overloading in here. But the bottom line is, I have a transaction, and it goes into what I call queue. All the transactions that are valid transaction, proper payload that belong to the proper chain, will be placed in this queue. But the fact that I have received transaction, it doesn't mean that this transaction is ready for block inclusion just yet. For example, the transactions from individual accounts, they have to be included in blockchain in the right sequence, following the non-sequence without any gaps, right? So if the transaction has a nonce that is way, way, way in the future, Geth will keep this transaction inside of the queue up until it receives the transaction to fill up the gap, and then eventually it is going to be ready for inclusion in the block. So there is this validation happening, and the transactions that are validated and marked as ready to be included in the next block then make it into the other pool, which we call the pending queue. Okay? And then from the pending queue, Geth just selects the best transactions and forms the next block. So this is what happens in Geth. So when we ask, what is a quarantine, we need to understand how when we actually query the oracle and where the quarantine sits in the system. And it's between the queue and the pending queue. So on top of the regular validations, whether this transaction is ready for inclusion in the block, our system also asks at this point the oracle, hey, is this transaction okay, on top of being ready to be included in the block? And if the answer is no, it's not okay, then it's going to place some flag somewhere in the data structures that Geth maintains, which means, hey, whenever you're considering moving transactions from queue into the pending queue, skip this one. Don't move it into the pool that is ready for immediate block inclusion. So that is what it means to place the transaction into quarantine. We set some kind of a flag that says, hey, skip this, don't include it, and don't move it into the pending queue. So what happens with those transactions when they are placed in the quarantine, right? If I left the transactions in the quarantine forever, that would be some kind of censorship, right? And we don't want that. So we define a whole bunch of criteria that allow for transactions to exit the quarantine. Some criteria are, fairly straightforward. So we said, hey, no transaction should be in the quarantine forever. We, generally don't need that, right? Even when there is a hack transaction that somehow showed up in the mempool, it is enough that the transaction doesn't get included in the blockchain for long enough time so that everybody else can exit the given protocol that is about to be hacked in 24 hours, right? It is enough that the users and general community are able to query the node for transactions that are currently in the quarantine, and that the word can be spread around that there will be an incident and that there is some kind of vulnerability that exists in the given protocol, right? So once we have left the transactions in the quarantine for long enough, 24 hours, 48 hours, configuration dependent constant parameter, those transactions can exit the quarantine, and if they still can be included in blockchain, meaning they didn't start yet violating some other inclusion rules, they will be included. If they started violating some inclusion rules, then Geth has the default behavior of just purging this transaction and dropping it from its memory so that it doesn't get clogged, right? So that's the time criterion. Now, you as the user might not be comfortable waiting for the quarantine to sort of elapse. Say that, you change your mind and you do not want to wait, you don't want to hack that protocol anymore, you just want to use your wallet again and start transacting, right? So you yourself can choose to actively replace the transaction, because this is how we cancel transactions from mining from blockchains. And this is what we call the replacement criterion. So if there was a transaction already included in the chain, which with exactly the same nonce from exactly the same sender, this meets the replacement criterion, transaction makes it out of quarantine, and it will be dropped by Geth. Then we have failure criterion. So imagine that a transaction is about to hack a protocol, but the protocol gets paused. The transaction will revert, right? That's the principle of pausing. So whenever our system detects that we have a transaction in the quarantine and the transaction is simulated and starts failing, that's fine. We will include it in the next block. It's going to fail, and it cannot hurt anybody. So those are the trivial criteria that are sort of, not very interesting. The criterion that I really, really like is economic criterion. So say that you are an honest actor, you are performing some sort of arbitrage on chain, right? So you are pursuing some arbitrage opportunity. And we unfortunately falsely accuse your transaction from being malicious. Well, in such a case, you are 100% confident that your transaction is not malicious, right? You are not here to hack your favorite lending protocol. Well, in that case, you should have the option of telling us, hey, Zirkit, I think that you are wrong. So what do we actually do? Our oracles are a little bit smarter. They do not just say your transaction is good or bad. If the transaction is bad, they also tell us how bad the transaction it is. So, this is going to cost $50,000 in damages. But if I know that the transaction is suspected to cost $50,000 in damages, then it's absolutely fine for me to give you the opportunity to give me a temporary stake, $50,000. Then I will include a transaction in the block right away, right? Because, if it does cause some damage, I have your $50,000 and I can reimburse everybody who got damaged by this action. And there will be no discussion. We will see the effect of this transaction on-chain. If the transaction was honest, your stake comes back immediately in the next block. Our block time is 2 seconds. So, this is really not some kind of long-term lockup or anything like that. So this is our economic criterion. And really, you can imagine a whole bunch of other criteria. We have security companies, we have communities, we have researchers, right? So you can also think of some form of an administrative criterion where we just give somebody the privilege to say, you can release transactions from quarantine by just, signing something, right? So that's the release criteria. Now, what exactly does it mean to release transaction from quarantine? Going back to the implementation of the quarantine itself, we just remove that flag and transaction can be moved from queue to the pending queue from which it can be included in the block. So this is exiting the quarantine, right? Cool. So how do we actually know that transactions are malicious, right? That's a very good question. So I will say this, I don't. We are a blockchain, we are a platform, so we are here to provide a blockchain. But there are many, many companies in the space that provide active monitoring solutions and similar technologies, right? So all of these technologies can be turned into oracles, and we are doing that. So if you don't know how an oracle could work, imagine this. Most of them is currently based on some simulation of transaction and then predictive modeling, machine learning on something like that. So I will take my transaction, I obtain a trace for it, we will see how many contracts it has hit, whether it performs the same thing over and over and over and over, which is actually a pattern that very frequently occurs in various hacks. And so we feed that into some kind of a machine learning model, and it will tell us, yes, this is malicious, or no, this is absolutely fine, right? So that's kind of Zirkit basic. Now I have Zirkit advanced. So I said machine learning, artificial intelligence in generally can hallucinate, right? And we do not like hallucinations. In our case, that could result in somebody being falsely accused from executing a hack. So we want to step up the game, and what Zirkit is going to do, we are going to provide some declarative language where you, as the developer and the deployer of a smart contract, can identify for us the intentions that you had for the smart contract and the invariants that should never, ever, ever be violated in the execution of any kind of transaction. So here, we are actually doing something very interesting because we are opening a very new way of doing clever things with smart contracts. So if you have ever developed a smart contract, you might have used something that is called only owner modifier. You can make your smart contracts ownable, right? There is a library for that in OpenZeppelin. Many people do it. So what only owner does is that whenever a particular method gets invoked, it checks whether the message sender, which is a context variable, environment variable that we have access to in Solidity, matches the address stored in some slot. But when this happens, there is some bytecode executed, right? So users have to pay gas for it, and you actually have to code the logic into the smart contract, which, depending on what exact logic you are coding in, it can actually be a lot of code, and so on and so on. What we are doing here in this declarative language and invariance, we are essentially giving the developers the opportunity to take this thing away from smart contracts. Because in this new setting, we would allow you, through this language, to say, hey, my invariant is that this particular method can only be called if message sender equals this. And you will make that known to the sequencer without the necessity to have that bytecode present in your smart contract itself. And then the sequencer will simulate every single transaction. If it notices that it actually violates the invariant, you have the certainty that it will not ever be included in the block, which can lead to simplification of many projects, right? So it essentially opens a whole new paradigm. And the bottom line here is that, as a Zirkit, we don't have to have a single oracle. We can work with multiple oracles, right? And one thing that you can be certain about is that we will have a very good data set. We will have the entire history of our blockchain. We will have the entire history of our other blockchains where hacks were executed in the past. So we can take this data, we can somehow publish it to all the security researchers, be it independents, academics, industry partners, and we can say, hey, do you have an oracle? Do you think that this is actually better than whatever we have? Well, let's see, backtest it, right? We don't have a problem of including more. So that's a way how we are going to engage the entire community. Final topic for me, L1 deposit transactions. So if you know anything, for example, about Optimism Bedrock, or in general about any kind of rollups, you might know that the transactions that operate with the canonical bridge, so they bring Ether from L1 onto L2, they have some kind of a special handling, right? So those transactions, they're actually submitted to L1, and so that we are certain that Ether will be bridged over, very often the sequencing protocols, they actually contain some kind of a mandate that these transactions have to be included at the beginning of very first block when they were detected, and so on and so on. So why is this important? If you come back in the future, 5 years down the road, right? What you as an independent actor in the system should be able to do, you should be able to read the data availability layer, read all the transaction, and completely deterministically rederive the state of the chain. And that's cool if you don't have any oracle that could potentially say, no, this transaction should not be included, right? Because if that oracle has disappeared, you cannot ask it. And you also kind of do not have the guarantee that the oracle would always respond exactly in the same way. So what I am saying here is L1 deposit transactions are a little bit of a problem, but not really. They can be handled. It is just important that we check them as well, because they can trigger hacks, and that we record somewhere on blockchain, somewhere on the data availability layer, the decisions of the oracle, which then needs to impact that decision whether this transaction will go onto blockchain or not. And I have 50 seconds left. This is the end of my talk. So with this, I would like to thank you for your attention. My name is Martin. You have my email right there. You have my Telegram right there. We have Twitter accounts or X accounts. The official account for the network is ZirkitL2. Me and some other engineers occasionally tweet from account Dr. Zirkit. We have pretty active community on Discord, so feel free to join. There is roughly 100,000 people who can be your friends. And last week, we also launched a liquid restaking program, which, as I checked right before this talk, has something like $350 million in locked Ether value. So if you would like to stake, maybe get some points, here is the link for you. With that, if you have any questions.
Test.
Testing. Cool. So up next we have John Adler, the co-founder and chief research officer of Celestia, to talk about the path to gigabyte blocks. Take it away, John.
Hi, everyone. Good afternoon. I'm here to talk about the first, not the end step of gigabyte blocks, but rather the first few steps of the journey of scaling Ethereum, specifically with data availability. Okay, so a bit about me. My name's John. I'm one of the co-founders of Celestia. I do protocol research and design at Celestia Labs, and do my best to lead the engineering efforts of the protocol team. Occasionally, I also shitpost on Twitter. Okay. So when it comes to scaling Ethereum with data availability, the talk of the past many years has been rollups, right? How does a rollup work? To make sure we're all on the same page, it's a mechanism by which you can separate execution from data availability and ordering. So you could have one of several or several simultaneously different execution layers. For instance, here we have Arbitrum, Optimism, Base, Starknet, and of course there are many others. ZK-Sync, Manta, I can't even name them all. But you can go on L2Beat. There's like almost 50 at this point, layer 2s, rollups. And then there's another, in the upcoming tab, they have like another 30, 35 or something like that. And this is only the beginning. So why are rollups useful? Well, if we start with the premise that execution is the bottleneck, which is a generally agreed upon premise, then of course if you make the base trust layer, which in this case, in this example is the Ethereum protocol, if you make the base trust layer not do that execution, then it can do other stuff with those resources. So in the model that's kind of evolved for classical rollups, which have basically been what people have seen for the past couple years, modulo the past few months, has been one where Ethereum, the layer 1 Ethereum chain, serves as a consensus layer that is responsible both for data availability and also settlement. But also, more importantly, it also has its own execution. So this is the unfortunate side effect that if a rollup wants to leverage Ethereum for data availability, it has to compete with other applications that are not rollups, but rather they're applications proper for some single shared resource, the gas. And this is not great because DeFi primitives and stuff like that can be they can be not very expensive, but rather they can have a lot of financial value. And like the ability to take a global lock on the entire shared state of Ethereum to process your financial transaction in any world where there's a large amount of finance going on the space layer, that is going to be expensive. So how do we get around this issue and make data availability a separate thing? Now we're going towards a modular blockchain stack. And this is what people have been kind of building towards for the last few years. Rollups have been deployed to separate out execution. And now we have data layers and other DA mechanisms being deployed to further modularize the stack and allow Ethereum to be used more for settlement and not for data availability. So you have protocols like Celestia, and you also have mechanisms rather than entire protocols like EIP 4804 that essentially only do data availability and do not also do execution. And what this means is if your execution layer wants to leverage one of these data availability layers, it doesn't have to compete with, say, some DeFi applications. It only has to compete with other rollups, and it only has to compete for data availability, not execution. Moreover, these data availability mechanisms have the nice benefit that they can be substantially more scalable than a layer 1 blockchain, like a base trust layer that also has other responsibilities, which means that the data availability throughput of these data layers can be substantially larger, as we'll see in a few slides. Spoilers. Okay, so what else have we seen come out from these modular blockchains? This is an example of a screenshot from a rollup as a service or RAS provider called Conduit, literally just from, I think, less than 2 weeks ago, on February 21st. They released their product here. It essentially allows you to spin up a rollup as easily as you deploy an application, a smart contract, or you can basically choose, and you can see the 3 layers here. You can choose your execution layer, your execution stack, which in this case, they're both EVM stacks, the OP stack and Arbitrum Orbit. You can choose your settlement layer, exactly like in the previous picture, where you can settle on Ethereum L1, or you can also settle on some L2s. And you can choose your data availability layer. So this actually allows you to deploy not just L2 rollups, but also L3 rollups. So for example, an execution layer built on the OP stack on top of the base L2. And these are the kinds of things that we're seeing emerging now that we have scalable data layers and that DA is no longer the bottleneck for a rollup's cost. Which of course, I'm not going to talk about the issue of if DA is not the cost, then execution might become the bottleneck yet again for these rollups. That's for other people to solve. Here we're going to talk just about the data availability part of this. Okay, so if you were to build something like this that settles on, let's say, Ethereum and that uses Celestia for data availability, how would you go about actually doing that in practice? So this is where this application called Blobstream comes in. It was formerly known as Quantum Gravity Bridge, which is a terrible name, which is why it's now called Blobstream. And it's not a bridge in the traditional sense of a token bridge that is bidirectional, that allows you to move assets and or messages between 2 chains, or 2 domains, as James Presswich would say. Rather, it's a unidirectional relay of information from Celestia to an EVM chain. It could be Ethereum, it could be Base, it could be Arbitrum, for example. Any EVM equivalent or EVM mostly compatible chain would be able to basically use Blobstream out of the box. That being said, there is also the nice property that any execution layer, for example, Solana, which has a completely different execution model than the EVM, could also use Blobstream without any changes to the Celestia protocol. And we'll get into why in a bit as I explain how it works in detail. But the initial implementation is just for EVM chains. Okay, so how does it work? I'm going to try and go into a bit of detail to satisfy some people because in some previous talks I've given about Quantum Gravity Bridge and Blobstream. I kind of gave a high-level overview. Now I'm going to go into a bit more detail since this is a hacker conference, after all, so you can see kind of some details of how it works and some of the nuances around the security assumptions. So, how does this work? The Celestia chain is a Comet BFT chain, like a Tendermint chain, that has a validator set. The validator set signs over every block to give it finality. In some regards, this is similar to the Ethereum consensus protocol, where blocks are final after they've received votes from a cumulative at least 2/3 of the stakers or voting power of the chain at a particular height. Okay, so if you want to know that some data is available on Celestia on your EVM chain, which will use Ethereum in this example, how would you do it? Well, like many bridges, you need to run a light client of the Celestia chain in the EVM. And how do you run a light client? You have a smart contract that verifies signatures and keeps track of voting power so that whenever it is relayed a new header, it checks to see, does the header actually have enough consensus on it? Okay. I mean, this is like fairly standard light client stuff. At this point, nothing special is happening. But what guarantees does this provide? The nice thing about this mechanism versus, for instance, a data availability committee is that if a majority of Celestia validators are dishonest, then sure, they can trick the bridge or the relay, but they are dishonest in a way that is accountable because they have to make signatures. They have to make digital signatures, which can't be forged. Since it's accountable, it means that they can be slashed. data availability committees don't have this property, right? And the data availability committee is purely up to the reputation. Okay. Now, some security nuances. One thing that was very important to us when we were kind of implementing and designing Blobstream as a whole stack is to make sure that it's secure and that it has the slashing property, which a lot of other data availability solutions for Ethereum do not have, right? And if you want to know, if something is secure, the first thing you should ask is, how do you do slashing? Because basically every DA solution that claims to scale Ethereum, unless it's part of the Ethereum protocol itself, is going to have some sort of economic stake, some sort of slashing, etc. If it's not part of the Ethereum protocol itself, such as EIP 4804. Okay, so how do we do slashing? Or rather, what nuance do we have here with slashing? There's kind of, there's this issue that what happens if someone, or in this case, the Celestia validators, rather, don't sign? If they don't sign, then you can't slash them because slashing only works if you have digital signatures from at least a large number of validators to show that they voted for, let's say, an invalid block or a block that is different than the one on the canonical Celestia chain. So what happens if they just stop voting and they just freeze the bridge? Then you can't slash them because you don't know that they've stopped voting. And the reason you don't know they stopped voting is because like many Tendermint chains, Celestia uses EDDSA instead of ECDSA. And on Ethereum, you can't really validate 30, 40, 100 EDDSA signatures in a single transaction. That would cost, like, I don't know, a billion gas. So that's not going to happen. So what's the solution to this? The solution is that this is how it used to work. I'll go into improvements in the next slide. So how would it work? The Celestia validators would post their signatures into Celestia blocks to make them available. After all, Celestia is a data availability layer, right? So kind of self-referentially, they would post their signatures, their ECDSA signatures, because they have two keys, one EDDSA and one ECDSA key pair. They would post their ECDSA signatures to Celestia itself, and this allowed them to be slashed if they stopped signing. So then you get slashing both for equivocation or invalidity, and also slashing for liveness failures. And both of those conditions are very important to have. Again, if any protocol claims to scale Ethereum, the first thing, unless it's part of the Ethereum protocol, the first thing you should ask is, how do you do slashing for both liveness and safety failures? Okay, so now the issue about what I just described, where you have to post signatures into Celestia, and where you have two different types of keys, one EDDSA and one ECDSA, is kind of cumbersome. And it's kind of a bitch. So how do we solve it? Oh, I'll go back to the previous slide in a sec. How do we solve it? This is where Blobstream X comes in. So this is an improvement to Blobstream that uses none other than zero knowledge proofs, the thing that everyone has been hyped about for years. And you actually verify EDDSA signatures inside the ZKP so that they don't have to be verified in the EVM directly. Essentially, you're running a ZK Lite client of Celestia in this case. What benefits does it have? Now, Celestia validators don't need two key pairs, one EDDSA and one ECDSA. They only need their single EDDSA key pair. And more importantly, you don't have to do this whole thing where they make their ECDSA signatures available because they don't need them in the first place. They only have a single key pair. That key pair is used to vote on Celestia blocks proper. If they stop voting on Celestia blocks, they'll get kicked out of the validator set, or they'll get slashed by Celestia social consensus, regardless. So this kind of solves all the issue and makes everything substantially easier. Okay. Now, let's say you're a developer and you want to use Blobstream. Now, I've talked a lot about kind of how it's implemented and stuff, but how would you actually use it if you're a developer? Be it a rollup developer, maybe you're some infrastructure developer, maybe you're an application developer and you just want to skip over all the infrastructure stuff and just go straight to having an application that uses some off-chain data availability solution. It's actually quite simple. Literally, the entire interface for using Blobstream and Blobstream X, because they have identical external interfaces, is this one function. This one function allows you to verify is some data in a Celestia block, and has the Celestia block been previously relayed by the Blobstream contract. And the implementation of this function on both versions of Blobstream essentially checks all the necessary preconditions and then returns you true if in fact that data is available. So it's very simple. There's only a single function that needs to be used to verify this. Okay, so what do we get out of all this in practical terms? Right? I've talked to you about Blobstream existing, sure, what do you get out of it? So on the left here, we see the average throughput of the Ethereum chain and the average availability of call data on the Ethereum chain, which is in the order of like 10 to 15 kilobytes per second, which is also on the order of dial-up internet, right? Which I think was like 56 kilobits. It's on that order, which is not great. Celestia, which currently on mainnet supports 8 megabyte blocks every 12 seconds, has a throughput that's closer to 700 kilobytes per second. And the difference in orders of magnitude, as you can see here. And there's also the difference in order of magnitude between dial-up internet and broadband internet. So this is really crypto's broadband moment, where you finally have access to an abundance of trusted data availability, and you can build applications that straight up would not have been possible to build without this abundance. Right? Like internet streaming, YouTube and stuff, probably wouldn't work very well if everyone only had dial-up internet. And now we finally are getting into the broadband stage, and and that's not where things end, right? This is only the beginning. It's only the beginning of the path towards the end when we're going to gigabyte blocks. And this is how, years in the future when we have throughputs on the order of 100 megabytes per second, not just on Celestia, but I'm sure on other data availability solutions as well, all scaling Ethereum, the throughput that was available to us in years past, that available, well, not today, but let's say 4 months ago, prior to the launch of Celestia, it's going to look like those tiny little blips on the left, and we'll be wondering, how did we ever do something with, basically dial-up internet? Okay, what does throughput give? Among other things, it'll give a reduction in fees. So this one here is taken from L2 fees today, where you can see that even on layer 2s, because of the very high cost of call data and data availability, things like swapping a token can easily take $1. And Ethereum hasn't even hit mainstream adoption yet, right? I mean, maybe some will argue that it's mainstream already, but I think a lot of people say we are still early, and that's my opinion as well. And we're looking at fees that are already $1. Imagine how expensive they will be in the future. But if you use scalable data availability solutions, then 99+% of this fee essentially goes away. And here's a concrete example from Manta Network, which integrated Celestia underneath back in December. So this was literally just like 2 months ago. And in those 2 months, they've saved almost $2 million in fees that they would have had to pay for data availability had they not used Celestia. Okay, so kind of closing remarks here. We're finally entering an age where you can access abundance, and with that abundance, you can build whatever with Celestia underneath. And to that end, we're also going to be hosting a modular hackathon later this month called the Infinite Space Bazaar. So keep your eyes peeled for that if you want to participate. It's an online hackathon. And if you want to find out more, here's our website and our GitHub. We build basically everything in the open. No closed repos. Everything's in the open. Everything's completely free and open source. And here's also Twitter if you want to follow us for socials. And with a few minutes left, I'm opening the floor for questions. Okay, I see one hand for questions over there. Do we have a mic for questions? Okay, I don't see a mic, but if you yell it, I'll repeat the question. Okay, so the question is around, has there been any thinking or research into using KZG commitments or other polynomial commitment schemes as a replacement to fraud proofs? So currently, Celestia is built around, I don't want to say built around fraud proofs, but rather it currently supports bad encoding fraud proofs, which means that if its block is incorrectly encoded and constructed, there is a fraud proof for that can be distributed to the network to show that it's incorrect. But like any fraud proof scheme, you can always have some sort of validity proof, or even better, you can have some polynomial commitment that is like less expensive than a ZK proof, but that serves the same purpose for the specific task. We haven't done much research ourselves on the topic, but I know that the Ethereum community and also the Avail team have been researching that, and my understanding is that it is totally possible to do. I think Avail implemented KZG commitments and also data availability sampling on top of that. So that is something that we would expect the Celestia protocol to support in the future. And we would also expect to support it in a way that doesn't necessarily break backwards compatibility with the current commitment scheme. So you get the benefits, you're going to be able to get the benefits of not needing fraud proofs, but you shouldn't have to worry about any backwards compatibility breakage. Okay, thumbs up. Cool, with that, I'm out of time, so, quick question. Will you support Bitcoin L2s? Well, I can't say will or won't, but I will say that there have been discussions and I think some concrete efforts towards this Blobstream technique being usable on Bitcoin through techniques like BitVM. So maybe in the future, yes.
Hi, everybody. So now we have Will Warren, the co-founder of 0x and Matcha, as well as Charles Guillemet, the Chief Technology Officer of Ledger, to chat about onboarding users to the Ethereum ecosystem via account abstraction and EVM L2s.
Thank you. Thank you. All right. Let's get started. Thank you so much for joining us, Charles. Really excited to have you here. So for those that don't know, Ledger builds the most popular hardware device for self-custodying crypto assets. And actually, I one of the two things that helped me onboard to crypto back in 2015 or 2016 was my Ledger Nano. And so I've been a long-time user and big-time fan of Ledger for a long time. And I think this story is true for a lot of people. A lot of people were able to onboard to crypto for the first time using a Ledger hardware wallet and a fiat on-ramp. And one of the important things for us as we continue to grow adoption of crypto is that we're able to onboard more people. And so in the early days with Bitcoin and Ethereum, we've been able to support hundreds of thousands, maybe 1 million or so people. But in order for us to expand beyond that into global, a global scale, we need to be able to support way more users, way more scalability. And this has necessitated layer 2 networks, and we're starting to see innovations like account abstraction become more common. And so, yeah, I would love to hear from you, Charles, how you guys have been thinking about onboarding more users in a multi-chain world.
Yes, sure. So in the last cycle, what we saw, we really hit the limits of the blockchain scalability. If you remember, there was a small application called OpenSea. It's a very simple application, and this application simply broke Ethereum because of the non-scalability of Ethereum chain. So this was a big issue, and we have the same issue on Bitcoin, but on Bitcoin you only want to do just simple transaction. On Ethereum you really want to execute code, so we need to solve the scalability. And the good news is during this past 3 years we have seen a lot of progress in terms of scalability with L2s in particular, and now we are really in a good situation where we have these scalability layers that will allow to implement plenty of new dApps and new use cases. And one of the interesting use cases that is enabled by this scalability is account abstraction, as you said. When you consider Bitcoin and Ethereum, they are built with what we call EOA for externally owned account. This idea is very simple but very elegant. You just generate a pair of keys, a public key and a private key, and your public key is essentially your address, and that's it. You have an account. It's brilliant, but if you want to implement something more complex in terms of governance, in terms of what you want to do with your account, this is very limited. All the rest can be done off-chain, but you would like to implement this complexity on-chain. And that's why account abstraction and L2s can really solve this problem. With account abstraction, you can implement a wallet with different spending conditions. You can have different type of signers, and you can implement recovery mechanism. Plenty of such features that are really necessary for users. This is really where we are. Also, if you think about onboarding new users, we really need to think about users who are not as geeks as us, let's say. They don't want to know about cryptography, to know about what is a public key, what is a private key. And with account abstraction, we can create interesting experiences where your account can be unlocked by your passkeys, for instance, or by your email. And there are a few interesting use cases where you simply go to your regular website and you connect to your wallet only with your email address or with your passkeys, and you don't even know there is a wallet at the end. This is the kind of experience that can be done, and that is really, really interesting.
Yeah. It seems like this is also something that's becoming a lot more feasible more recently, whereas I think people have been talking about account abstraction for a number of years. I think Vitalik was talking about moving. I think he was talking about having kind of multi-sigs was one of the ideas floating around in the early days of Ethereum, kind of foregoing EOAs altogether and just having multi-sigs. But it really took a number of years before these types of ideas became kind of feasible to put in front of users and for users to understand how to actually interact with them.
Yeah, and one of the things that unlock this possibility is really the fact that we have scalable layers now with L2s. Because if you want to do that on Ethereum, technically this is possible, but you will pay your every single transaction very, very expensively. So this is a problem. So what really unlocks for me this type of experience is the fact that we have the infrastructure, we have cheap blockchain space that really unlock this experience.
Yeah, that's exactly right. Yeah, and I think like even an example of that is like Gnosis Safe. So a lot of people in the Ethereum space rely on like a Gnosis Safe to create a kind of multi-sig wallet that provides kind of controls over, you know, how different assets can be accessed or utilized. But what we've seen is, well, it is used, but it's very expensive, and it's not really feasible for like an individual to adopt something like a Gnosis Safe. And so making something like account abstraction possible, yeah, is kind of necessary to provide those benefits to like an individual versus like maybe a team or a company that wants to custody in a more kind of complex way.
Yeah, Gnosis Safe was one of the precursors of account abstraction. This account abstraction word became really buzzy after the ERC 4337 launched exactly 1 year ago here in Denver. But this idea is not new. As you said, Vitalik was talking about that a long time ago. Gnosis Safe can be seen as account abstraction. Now we are in a situation where we have this framework, which is 4337, and we can do plenty of things. And one of the interesting ideas that can be implemented with account abstraction is the following. You will create an abstracted account with a spending condition, and let's say you will be able to say, I can spend up to 100 USD a day, and for this 100 USD, I can confirm a transaction only with my smartphone using passkeys. And if I want to make a bigger transaction, or if I want to interact with this specific NFT that is very valuable for me, then I need to use my ledger for that. This is something that you can express with account abstraction, and that is really, really, really powerful. Because if you want to do that today, you will have several wallets that are not connected with each other, and you don't have a unified experience. So this is a very powerful idea, and I'm looking forward to seeing what will be implemented. And now I feel we are a little bit in a situation where plenty of teams are working on this idea and are creating a different flavor of account abstraction, and it will create like fragmented experiences where you have plenty of different implementation with different features and with different ways to interact with them. So we are really in this situation, and I'd like to be like in 2 years from now where we will know which was the best standard, because it will converge back to the most relevant experiences, I think.
Yeah, that's a really good point. So not only like the user experience, but another big consideration with account abstraction and providing users like more flexibility around how different keys can access funds. Another big consideration is security. And how do we present users with an experience that is seamless, that kind of abstracts away some of the technology in the back end, but how do you do that in a way that kind of preserves security for end users? And I think that's an area where your team has spent a lot of time thinking about it, and kind of curious on your perspective on that.
Yeah, and I think I had plenty of discussion at HCC in Paris last year. That was the beginning of this craze around account abstraction, and I had a lot of questions around: is it a threat for Ledger, because now you don't need there is no seed anymore and so on. And this is really a misunderstanding, because when you have an abstracted account, you still need to secure the access to the keys. So maybe you don't want to use like a regular seed as a signers. You can do that. You can do that with passkeys and so on. But it doesn't change the fact that you need to secure the credentials that allow you to interact with the smart contract. Otherwise, you will lose your money the same way you lose your money when you lose your seed. And I think seeds remain a good way, a good standard, because you have the standard, you can recover on other type of wallets and so on, which is not the case with passkeys, for instance. If you want to recover passkeys on another device, there is no standard. Apple has its own standard. Android, this is another, and also you have to rely on this provider, so this is probably not something which is suitable for everyone. So yeah, this is really something that needs to be taken into consideration, and at the end, your abstracted wallet will be as secure as the governance policies that you will implement on it, and the way you are securing the credential, the secret, which could be a seed or a passkeys on your end. So this is really something, there is no magic. It's not because you have an abstracted wallet that it will be magically secure. You still have to consider what are your spending conditions, what are your policies, and where your secrets are, and how do you interact with them. And another interesting thing to have in mind, again with this passkeys experience, when you sign a challenge with passkeys, you don't have the intent. So because FIDO2 do not embed attributes in the protocol, so you just sign randomly a challenge, which is fine because it's very convenient and so on. But if you are interacting with a smart contract and you have no idea what you are signing, so maybe you are signing the transaction you wanted to sign, but maybe you are simply giving away your wallet. And here it's simply not possible to implement clear signing because FIDO2 do not implement this intent property.
Yeah, that's a good point. I don't know if anyone else here has experienced this, but I definitely have personally, where I'm interacting with some sort of like Web3 application, and I see kind of like a big blob of text pop up, and it's like a hash of a data structure explaining what's going to happen on chain, but you really don't have any idea what exactly signing this blob might actually set off, like what chain of events it can actually set off. And so I know providing kind of visibility into what is it that you are signing and what are kind of the impacts of or state changes that can occur as a result of signing a specific data structure. Yeah, I'm curious like how you guys have been thinking about that. I know more recently with like ClearSign. Yeah, curious to get your thoughts on that.
Yeah. Today we are in a situation where we are putting our secret, our seeds into hardware wallet, and which is a very good idea, and then quite often we are interacting with different smart contracts, and we are simply signing hashes, and we pretend it's okay. It's not. It's definitely not. When you sign a hash, maybe you are giving away all your assets. So this is not an acceptable situation. This is really why we are working on solving this problem, and we have an internal initiative which is called ClearSign all the things, and the objective is really to provide to the users with all the information for him to understand what kind of transaction he is about to consent, and what could be the impact of this transaction. And there are really two aspects. There is the first thing, like really understanding what's inside the input data that you're about to sign, and secondly, there is what will be executed on the chain, which is even more a difficult problem. So for the first problem, we are collaborating with dApps and Wallet in order to provide a metadata file to the device, so that the device is able to parse the transaction and understand what's inside the input data. So this metadata file will simply say the name of the method is this, and the parameters are located in this offset, and so on. And on the device, you will be able to understand that you are not like signing a hash, but you are swapping 32 USDT against 0.1 Ethereum, and this is what will be written on the device, so that you can clearly understand what kind of interaction you are doing. And the second thing is a service that is provided by a few players, such as Blockhead, Exagate, and Blowfish, which is really interesting. Is the fact that you can simulate the transaction and try to to understand what will be the impact of the execution of this transaction. And there's two things are really important to take the right decision on what you are going to. Will you sign this transaction or not? You will have really more insight, and it's not about just signing a hash that you don't understand what are the consequences. So this is really one of the big focus for Ledger this year. And it's not only about Ledger, it's really about the whole ecosystem, and we want to embed everyone with us in this venture. We are working with dApps, we are working with wallets, with Wallet Connect, with MetaMask, with Wabi, also with hardware wallet, and we really want to raise the bar for security for everyone. It's not acceptable to sign hash. Signing a hash is exactly the same as signing a blank check and hoping that it's going to be okay.
Yeah. All right. So I have to take the opportunity to brag about my awesome teammates, because we've been focused on very similar problems, because they're just as important when users are swapping on like a decentralized exchange. So yeah, a number of years back, a few of my teammates, Remco, Leonid, and Jacob, they actually developed EIP 712, which is kind of the Ethereum standard for structuring data in a way where users can kind of see what they're signing, and you can kind of hash it and sign it in a way that's more transparent, and yeah, very much feel like it's an important piece. Also, got to give another shout out to Blowfish founding team, also 0x alumni, and yeah, super proud to see what they've been doing as well on the security side.
Yeah, and by the way, we really took inspiration from EIP 712 because this is just a structured way to provide the users with the information to understand what he is about to do. So we are at the beginning of this initiative. Now we are taking some feedback from the ecosystem, and if you have some, don't hesitate to reach out to me. And after that, we will try to implement this. And the idea is to do this on Ethereum and EVM in general first, but the idea is really to secure the whole ecosystem. Bitcoin is easier because the type of interaction are simpler, but for other chains, there will be the exact same problem.
Yeah. So signing, kind of user security, handling, cryptographic keys and managing accounts, like that's one important aspect of allowing like multi-chain to be more accessible and kind of onboarding new users. There's a couple of challenges in this transition to multi-chain and layer 2 networks. And yeah, curious how you have encountered these, the Ledger team has encountered these in your own consumer products.
Yeah, so all those things where we are solving the scalability challenges of a blockchain is really good for us, for the ecosystem. Account abstraction is also a big progress in the user experience and in what we can do with our wallets. Nonetheless, we are at the beginning of this with plenty of ideas, plenty of standards, and it will create a lot of fragmentation. Fragmentation in the liquidity. When you have hundreds of different L2s, that means that the liquidity will be spread over those L2s, which is not good for DeFi. It's not good. It makes the DeFi less efficient to have a fragmentation of capital. And also there will be fragmentation in the user experiences because you have different L2s, different account abstraction, and all of this will be different. And let's think about these newcomers. They will be onboarded with account abstraction, and then we will explain them, oh, now you have to bridge your asset to Ethereum in order to go to your L2, and if you want to go from one L2 to another, you will have to use other bridge again, and it will be another wallet with another abstracted account. So it can create less good experience at the end, which was exactly what we wanted to avoid. So we will go through this period where there is no standard, there are many standards, and at some point one standard will win. I hope so. But from now to this moment, I think there will be some trouble and some challenges around that.
Yeah. Good news is, you do have you are starting to see some solutions to these fragmentation issues. A couple of the things that we're building at 0x and Matcha, like really kind of one of our core priorities is to eliminate the complexity of accessing tokens or liquidity regardless of where they may be located, and ensuring that you're always going to get the best price. So with our 0x trading APIs, we aggregate liquidity across 8 different EVM blockchains, over 130 liquidity sources, and our goal is to really make it super simple to provide a delightful and cohesive experience for consumers. And that's also what we're looking to achieve within Matcha, which is our consumer product powered by 0x trading APIs. And yeah, it looks like we are at time.
Yeah, maybe one last question for you. Like, what are you the most excited about in terms of new use case for the future? Because we have this new layer of scalability, new possibility with account abstraction. But then the question is what we will do with all this cheap blockchain space. What are you excited about?
Yeah, well, so I think this ultimately comes back to the question of why is any of this technology important at all? Like, why are all these smart people dedicating their lives to working on blockchain technology? There's lots of cool stuff you can go and work on in the world. Why work on this? And I think the answer to that is that ultimately this technology has the potential to be extremely disruptive and to democratize access to financial services on a global scale. And so today, a lot of your opportunity in life kind of boils down to where you happen to be born or where you're geographically located, and that's not something that any of us control. And so by being able to move things like stable coins and tokenizing assets on blockchain rails that are globally accessible, ultimately that should allow us to do something that's worthwhile with this technology. And it's still very early on, and we haven't been able to reach kind of global scale and have that type of impact. But that's our mission at 0x, is to eliminate the complexity of accessing tokens and markets, and hopefully to do that at a global scale. So, yeah.
Cool, pretty exciting. I see we need to wrap up. I see a couple of questions, so let's take them offline just after. So thank you very much for your attention.
Cool. So up next we have Amanda Young from Collab and Currency moderating a panel with Justin Malello, the CEO and co-founder of Mona, as well as Andy Bromberg, the CEO of Beam, and David Biner, the CEO and co-founder of Hume. And the topic of discussion is App-Infra cycles and the next wave of consumer crypto.
Hi, everyone. I'm Amanda. I am on the investment team at Collab Currency. We're an early stage crypto fund. We focus on consumer applications and enabling infrastructure at the early stages. So excited to have some of our portfolio companies on the stage here today who are at the top of the consumer crypto space. So to kick things off, would love to just hear what you guys are building. So maybe starting off with Justin and Mona.
Sure. Hi, everyone. My name is Justin. I'm the founder and CEO of Mona. Monaverse is the metaverse world-building platform built for creators by creators. We make it easy and free for anyone to launch their own immersive web-based experience in-game, and it's all built on blockchain rails.
Hi, I'm David Biner, co-founder and CEO of Hume. At Hume, we want to create the Pixar for virtual artists, and we have a platform that allows people to guide the future of those virtual artists all on-chain.
And I'm Andy Bromberg, the CEO of Beam, and Beam is super simple global Venmo, the easiest way to pay anyone, anywhere in the world, nearly instantly, and is built on the Eco protocol, which is a cross-chain payments protocol.
Okay, awesome. So to kick things off, would love to hear a bit more about why Web3. I know each of you are rethinking consumer experiences. Obviously, Hume for music, Mona for 3D immersive, and Beam and Eco for payments. So can you talk a bit about why Web3, what it's unlocking for you?
Yeah, absolutely. So we are living in an increasingly immersive digital future. If we're looking at the future of the internet, the future of computing, it's all spatial. In the future, we're going to be spending more and more time inside of immersive worlds with our own avatars and wearables, spending more of our time connecting across this new medium. And we're going to be spending more and more money acquiring digital assets to use across these virtual worlds. And so why Web3 for Mona? Well, simply because you need blockchain in order to be able to have this open, verifiable record of who created what, who bought and sold what. It really enables true ownership over your digital assets. And as we spend more and more time inside of immersive worlds, it's just super important that we actually have ownership over those 3D items, those 3D environments, everything that we're collecting and trading. And if you look at, if you think about metaverse, if you think about gaming today, every platform that exists in Web 2, they're really all walled gardens, where if you're buying a skin in Valorant, you can't take that skin elsewhere outside of the game. Same with Fortnite or Roblox. You don't have true ownership over those assets that you're buying. Ownership is really at the core of everything that we do, as is creator empowerment. And the same goes with creators, not just people who are purchasing items, but for those who are building all these 3D assets. Web3 enables these new crypto-economic incentives for creators to be able to establish themselves as independent artists. And that's really important for us and why Web3 for Mona.
So Web3 for Hume, blockchains have the most internet-native people on planet Earth. And that will continue to be a trend as more and more people come on chain. For us, when we were thinking about a Pixar for virtual artists, a company that creates stories and worlds for these artists, that virtual artist that is going to break through in the way that Pixar had their Toy Story is going to come from an on-chain community. It's not going to come from a community that just came up on Instagram. And being able to use on-chain activity as a way for people to interact with these artists is how we see the future of this going. People want to be able to participate, they want to be able to track that participation, and they want to be rewarded for that participation.
And for Beam, Beam's all about payments, and for me, payments is the original and killer use case for crypto at some level. If you look back at the Bitcoin white paper, the title of that white paper was Bitcoin, a peer-to-peer electronic cash system. It was literally technology for better payments. And you can actually feel the real effects of that. That's not just a theoretical thing. Beam is a non-custodial wallet, like MetaMask or Ledger or any other non-custodial wallet out there. And one of the benefits of that is that it's globally available from day zero. Because users actually have control of their own funds, the wallet can be offered to everyone at the same time. But if you look at traditional Web 2 or custodial products, those products have to go, because they hold user funds, country by country and get licensed and build a local team and do all the work required to spin up that individual place's operations. That's why Venmo is only live in the United States of America. That's why TransferWise, a company that's literally built for cross-border payments, is only live in 65 or 70 countries. But a wallet like Beam or MetaMask that's non-custodial actually allows you to pay anyone anywhere in the world nearly instantly. And that's a huge advantage over traditional payment products. And I think Satoshi's original vision was better money, cash-like digital payments that avoided intermediaries and avoided the complexity of dealing with all of the custodial things that exist in Web 2 products. And now it's finally time that we can actually go and build those.
Awesome. And building a bit on what Justin and David were saying around creators, can you talk about what are the business models that blockchain technology is enabling for creators and these new crypto native incentives?
So for Mona specifically, with the Monaverse platform, it's free for a creator to build and upload their own immersive world or 3D avatar or 3D game object. The creators are able to actually tokenize those assets as NFTs, as one-of-one NFTs, and they're able to then sell them through the Mona platform or on any NFT marketplace. It's really, really key that these are NFTs because one, you're able to verify, which creator owned it, so you have true provenance over the actual work. But two, it also enables perpetual royalties for that work every time it trades hands, which is so vastly different from how it works in Web 2 for these same creators. The world is filled with millions of just incredibly talented 3D artists working in the fields of visual effects and in game design, and even hobbyist 3D creators or virtual reality artists. Before this point in time, there's really no way for those artists to be able to, be able to prove that they had created a specific asset, but also they were unable to see, who bought and sold that asset, and they were unable to be able to collect royalties every time that asset is traded. So this is so incredibly powerful for creators, not just in the metaverse and in Mona, but for any type of creator who's minting NFTs today. And it's a huge, huge opportunity for these creators, but particularly for 3D artists. They're able to actually have legitimate careers as independent artists because of what blockchain enables. And so, with NFTs being at the core of our tech stack for creators who are building these worlds, that's one of the main ways that they're able to actually monetize and capitalize and leverage blockchain in order to be able to make a living, basically, as full-time metaverse builders.
I think for us, we're waiting to see that major catalyst moment where, especially with something like music or something like fashion, things that are more culture-driven versus gaming, where you have that reason why you could go up to anybody and tell them okay, you should be participating in Web3. I think we're about to see that paradigm shift happening. For the first time, we have legit social apps like Farcaster appearing, and the big opportunity there for any creator is the old marketing funnel, Web 2 marketing funnel, was build a social audience. Now you have to convert that social audience to go buy something or participate in something off the app. With Farcaster and these other social Web 3 native social apps that are coming, you're going to have direct purchasing, direct commerce experiences right through those apps. And that fall off, which is often, on a good day, you get a 2% conversion rate, is going to decrease. And if you're a creator and you're building on Farcaster right now and you're going to be able to sell to your audience directly on that app, this is the massive paradigm shift that is going to bring tons and tons of people into Web3 because it'll be undeniable.
Cool. And building on what you're saying around bringing more people into Web3, are you, with your different apps, primarily targeting crypto native audiences or mainstream audiences, and kind of what has your go-to-market been? So maybe we can go down the line.
Sure. For Mona, we've primarily been targeting 3D creators. Again, these are professional VFX artists. We have many creators in our community who have been working at studios like Digital Domain on Hollywood movies, and also at AAA game studios. We have artists in the community that have been building games like Cyberpunk. We also have a lot of hobbyist 3D creators. And so many of these creators, we've found are actually crypto native, and they're used to Web3, and they've been collecting and minting NFTs elsewhere. And Mona is really the first place for them to actually tokenize a 3D asset, but also be able to display it in the highest quality all through the web browser. What we're also seeing is that many of these creators are not crypto native, which is really exciting because we're onboarding thousands more creators to Web3. But really a big shift and a big focus for us this year is engaging more with game developers specifically as well. And I think Web3 has sort of had this issue traditionally of being associated with scams and all the negativity around it. And so what we're really aiming to do is provide more education around all of the benefits that Web3 really provides creators and developers specifically. And so now we're actually going a little bit broader, not just crypto native, but we're hoping to onboard thousands, hundreds of thousands, eventually millions of these developers who want to build interactive experiences that they can launch for the open metaverse and be able to find a new revenue path for themselves.
We've done a little bit of both. On the Web 2 side, we've been thinking, okay, if these virtual artists are going to be mainstream, they need to have a presence on Instagram and TikTok. That's just the tried and true model. Create great content, figure out what works, fine-tune it, build that audience, and maybe you can get some of them into Web 3. In Web 3, we've had very specific, especially in the last month, marketing plans. And again, what we're most excited about, being able to do something like a frame on Farcaster, and beginning to think of something like Boost Protocol as the new version of paid ads. With Boost Protocol, we can pinpoint who we want to mint our product on Farcaster. We can create some type of incentive. I think in the future, you'll be able to do token-gated boosts. And to me, Boost Protocol is the future of paid ads. It's the future of Web3 marketing. Instagram and TikTok are still going to exist, and we need to serve those audiences differently. Much like a lot of the great, if you look at Pudgy Penguins, they've done probably the best job of this, of any project.
Yeah, and I think generally crypto native people are an amazing audience to start with because they are just people that are earlier on the adoption curve. So whether or not your product requires a whole lot of crypto knowledge, people who are in this space are very likely to be earlier adopters. So they're a great place to start. But I think the real test of these products is, can you go beyond that, like both these guys were just saying, and reach beyond the crypto native early adopters who are often your best advocates because they're excited not only about the product itself, but the technology it's built on. So they're amazing advocates. And can you use those to then go beyond that and get to the rest of the world? Beam is this payments product. We're at this conference that is full of just crypto people, but we went around and we got about a dozen places in Denver to accept payments on Beam. So there's a coffee shop and a cupcake store and a knife shop and all these places that you can go right now and pay with USDC. Pay with stablecoins, and these are not crypto native people, but they're excited because they got the pitch from us, because we are crypto native people. We're early adopters, and we're evangelizing and saying, this is better, there's no credit card fees, people want to pay with this, why not offer this as an additional payment method? And these people say, yeah, sure. Some of them say no, obviously, but some of them say sure, and that's how that starts. So I think it's great to start with the crypto native people. We shouldn't be afraid of doing that just because we eventually want to reach the rest of the world. But they're just a great bootstrap audience.
Yeah, that makes sense. And when you're thinking about the infrastructure to onboard both crypto natives and mainstream consumers, what is the stack? Do you have different options for different types of users? Can you talk through kind of what is the infrastructure stack that is empowering your app? And we can start off with Justin.
Yeah, because we started crypto native, our app, and it currently is this way. You very simply create you log in with your wallet, and by connecting your wallet, that gives you access to your user account, all of your assets. You can use that to buy, sell, create. But now, to go more mainstream, a little bit wider beyond just crypto native, what we're looking at is introducing a more frictionless UX. I think that's really the key, is creating a really frictionless way for users to interact with your product, interact with your app. And the reality is, most of the world, they still don't really understand everything that goes into creating a wallet and really how blockchain works. And so now there are many different options that make it really easy for you to really abstract that wallet account paradigm, that ownership away from it, and just create a simple email login or Web 2 auth login. So we're looking at introducing those into our app to make it a little bit easier just to onboard more users, which I think is great, not just for non-crypto native, but crypto native as well. I think at the end of the day, we all just want a really easy and frictionless user experience.
So I don't know if a lot of people think about IYK as infrastructure, but for us, we're really excited about it. I think about it as physical infrastructure that can actually blend what we're doing on chain in the digital world and what's happening physically. So For us, what we did, we sold a hoodie for one of our artists named Angel Baby. That hoodie came with a chip, and everybody who received that hoodie was able to scan that chip, get a piece of exclusive music, and then we've actually been able to continuously release unreleased music to those people before it comes out. And now we have artists reaching out to us who want to do a remix of the song that the hoodie was attached to, drop it as an NFT through our hoodie, and also give people early access to their song through our hoodie. So IYK doesn't get talked about necessarily in the infrastructure world that much, but we're really excited about these kind of physical infrastructure chips that can merge digital on-chain activity with things that people actually do in public when they're going to a music festival, a fashion show, lined up at a club. 9DCC has done a great job of this in the fashion world with network points, and you actually get incentivized for how much you're representing the brand outside of your home. So that infrastructure is really interesting for a company like us that's trying to proliferate in mainstream culture a little more.
Yeah, and for us, when you log into Beam, you use your X account or your email, and it's really simple, the same as every other service. I think there's kind of this view of crypto as this esoteric technology that requires very specific ways to interact with it, and it's almost like this mystical thing of, oh, crypto is hard by definition. But the reality is I don't actually think it's that different from any other new technology. When you think about, LLMs, this brand, huge new technology that has taken the world by storm, that is incredibly complex technology, but nobody questions the fact that when you sign up for ChatGPT, you just log in with your email. And yes, if you want to go under the hood and get into the guts of it, you can go to the OpenAI playground and interface with the API and really get into the nitty-gritty of it, but that's only if you want to. We just hide the complexity of these technologies behind very simple things like log in with your email account and then interact with it with a chat interface in the case of ChatGPT. And my view is that crypto is really the same thing. Use familiar user patterns for people, and then if they want access to more, you can give them that. So in Beam, when you on-ramp funds to Beam, you do it with your debit card. Really simple. But if you are an advanced user and you want to connect a wallet and deposit funds that you have from another wallet, sure, we let you do that too, but that's not the default option. And so I think we, as an industry, at this point, we have the tools to abstract a lot of that complexity away from people. We just need to do it and not act like this is some technology that for some reason is so much harder to use than everything else. It's just another piece of technology, and then let people get into the guts of it if they really want to.
Amen.
Thanks.
So I guess to expand on this, obviously we've had a lot of technological innovations over the past few years that are making these possible, right? Like IYK was only founded a few years ago, let's say. What are the problems that still need to be solved? Like what in consumer onboarding is still a problem and we don't have a solution?
I think one big thing for people is one of the beautiful things about blockchains and crypto technology is their immutability, right? That you can trust this ledger. When something happens, it's not reversible. It is like this permanent record, and nobody else has control over your funds, right? This is a really powerful thing that nobody else can move your funds from a wallet that you control, from a non-custodial wallet you control. But this comes with a huge downside. What happens if you lose the password, effectively? What happens then? And, with my bank, if I lose the password, well, I just call my bank up and, tell them who I am, and maybe I have to submit some documents or something, but they give me access to my account again, even if I've lost the password. And I think we've built good auth flows for crypto. So logging in and creating an account, that's fine. I don't know that we've really seen truly excellent recovery flows. Or, if not recovery flows, at least truly excellent education of users about what's actually at risk and how careful they need to be about these things and how they need to think about it. Because it is, at some level, a new mental model that you just have to educate people about. That doesn't mean you can't build flows that mirror what they're used to in other products, which is what I was saying before, but it does mean you have to put in the work to actually make that happen. So for me, I think recovery of these non-custodial wallets and making that really seamless is a problem that I haven't seen solved really, really well yet.
I think kind of following up on that, insurance is something that really hasn't been solved, and if somebody is solving it, it hasn't been solved in like an integrated way where I sign into MetaMask and I see quotes of how I can get insurance on my wallet and can just like one click pay and now have insurance on it. I think most other really expensive things, or when you have something really expensive, you're able to really easily access insurance for that product. And the fact that there's not a really simple way integrated with our wallet solutions and a really easy provider for that, to get insurance on these assets that we're all holding is a big loss. And I think if we're going to onboard 1 billion people, those types of integrated insurance solutions are going to be critical.
Yeah, I can think of a few things. One, that there are many different chains now emerging, and we all have assets that are across all these different chains. And I think there are actually a few products, a few really talented folks that are working on this issue of how do we bridge all these assets and have them all in one place. But I think about assets living in these different places. I also think about, this is unique to what we're building with metaverse and gaming, but I think about the speed of transactions and also the cost. And again, I know certain chains, it's far, far cheaper than Ethereum, obviously, and faster as well. But it's still not as fast as, for example, if you want to build a truly on-chain game, to build an on-chain FPS is impossible right now. You can do something like a real-time strategy game, but we really have to get to a point where transaction speed is far, far faster in order to actually have a truly on-chain gaming experience for something that requires milliseconds. So I'd say that's another big issue if you're thinking specifically about gaming.
And one thing I've noticed is that there's been a shift towards mobile for consumer apps. I know there's also new distribution platforms. I know, we've talked about Farcaster. I guess where are you both able to access your product right now, and where are you sort of marketing or distributing it right now?
Well, Mona is web first, so you can visit Monaverse on any desktop web browser and jump into an immersive experience. On mobile device, we actually lean into what mobile does best. And we found so far that rather than immerse someone in an immersive experience on a mobile device, we focus more on augmented reality for mobile. So if you go to Monaverse, you can actually interact with assets using AR. Through the marketplace, you can actually drop them into your world and start moving them around and doing different things with them. And so we sort of we want to lean into mobile more where it can provide a better user experience. And then beyond that, we're also building for the Apple Vision Pro, which is sort of mobile, but obviously it's a wearable device, and we can talk about that in a little bit. But yeah, I would recommend, if you're building a product, really leaning into what you can do the best with, that end hardware. And for us, immersive worlds on the desktop look really great. For mobile, it's more about augmented reality.
So we have a platform, you can sign in, and our artists will ask questions like, what should my next single be? What should the album cover look like? And that site and experience is mobile friendly, but one of the things we realize is if you're bringing people there and they're coming off of, let's say, Instagram, and they get there, a lot of those people probably don't have a wallet, and a lot of those people probably want easy email sign up. So one of the big unlocks for us in the last 4 months has been able to provide that easy email sign up and use Crossmint in the back end to create a wallet for them. They have no idea that they have a wallet. They have no idea that their assets are being stored in a wallet. But if they ever go down the rabbit hole and they want to access those assets, it's all set up for there, and it's all using Web3 in the back end. So I think those types of wallet solutions have been huge for people and companies like us who want to target people through their mobile experience.
Yeah, and Beam is a website. It's just beam.eco. You can go to that website and you'll have a Beam wallet instantly. And it's been really interesting at this conference. We've experienced this before too. People come up to our booth, they ask us what we are. We say Beam, global Venmo, really seamless peer-to-peer payments product. And not everyone, but a lot of people's reaction is, oh, I don't want to download another app. I've got enough wallets on my phone already. And when we say, oh, it's actually not, you don't have to download an app, it's just a website, people say, wow, that is the experience I want to have initially. Now, I do think that people, when they get deeper into these products, often want a native app to have that kind of persistence on their phones. So we'll build that and we'll offer that to people. But the experience of just onboarding these products on web, I think is really compelling for people. And so you can find me after, or come to the booth or whatever. We've got these QR codes that have money on them where you scan a QR code and it pops up in your mobile browser and says, someone sent you $5, do you want to claim it? And you hit claim, and all of a sudden you have $5 you can go buy a taco with, or buy a coffee with, or buy a cupcake with, or whatever it may be. And I think that seamlessness is really powerful. If you limit these products to just being on desktop or requiring a download or anything like that, the friction bar is so much higher for people. And you can lower that initially by just making it really good in mobile web. And thankfully, a lot of crypto's foundational infrastructure has been built with web in mind, because for a long time, the app stores were not friendly and still arguably are not friendly to crypto native products. And so a lot of technology has been built to make building on mobile web really, really easy. And so I think that's a great place to start for these products.
Cool. And Justin, I would like to hear more about this Apple Vision Pro app. So yeah, how does that compare to mobile and web browser experiences? Where do you see the AR, VR, crypto intersection going in the coming years?
Yeah, that's a great question. So Apple Vision Pro, for those who haven't heard of it, it is a wearable device that lets you experience virtual reality, augmented reality, or really, they're coining the term spatial computing. And really, it represents an entire paradigm shift for what the future of computing looks like, but also what the future of the internet looks like. To date, we have been most accustomed to interacting with the world's information, with connecting with each other through 2D interfaces via web browser and web pages. But now, if you get your hands on a Vision Pro, you get a glimpse into what the next 10, 20 years are going to look like, where we start to break information, content, and social interactions out of the 2D context and into 3D, into an immersive context, into the world around us. And so for Apple Vision Pro, Mona is actually building an app that lets you interact with all of your digital assets that you hold, that lets you interact with 3D assets, it'll do the best at, where you can actually pull them out of your wallet, out of your user account, and drop them into your worlds where they can persist and you can share them with friends. You'll be able to add interactions and do a lot of really fun and exciting things with it. And we really see this as the future of computing, but also the future of social interaction and content creation as well. And so it'll be a really exciting first glimpse into what that next 10 years are going to look like. And again, it is still really, really early. But this all goes back to, I think, that first question of why Web3. Again, we're living in an increasingly digitally native, immersive world, spending more time inside of these immersive settings. And so for these assets that we own and interact with and play with, to be on blockchain where you can actually prove that you own them is just going to be increasingly important over these next 10 years.
Yeah, I'm super excited to hopefully try that app soon. So Andy, in the payment space, with stablecoins, with crypto payments, I think we're seeing a lot of kind of momentum and growth there. What do you see as the primary use cases now and in the next decade? And where does Beam play in this landscape?
Yeah, I mean, stablecoins are exploding right now. They're being used all around the world. And I don't know that in the United States we have as much visibility into it as we would if we were looking elsewhere in the world, which I think is really powerful. We're seeing a couple of really big use cases for stablecoins. One of them is the kind of very obvious, long-awaited, 10, 15 years in the making, crypto-powered remittances, where people can send money across borders or make payments across borders, whether remitting money to family or friends or making cross-border payments at merchants or otherwise, with stablecoins and much more efficient infrastructure. If you go and look at these giant cross-border payments companies, PayPal is a great example of this, the amount of money that they make off of foreign transaction fees and foreign exchange fees is ludicrous. It is an insane amount of their revenue because they know that they have very little competition. But now that competition is coming in the form of stablecoins, and I think it will make cross-border commerce and remittances much more efficient for people. The other really interesting angle we're seeing for stablecoins is people globally who want access to dollar-denominated financial services. So there are people who are all around the world, and they want to save and spend in dollars, but their local payment infrastructure does not enable that. And this might be because they have a bad currency, it might be because it's tough for them to easily move in and out of the currency that they currently use, there's tight capital controls or otherwise. People want access to dollars globally, and stablecoins are an extremely effective way for them to get access to dollar-denominated financial services. And so that's what we're seeing from people wanting stablecoins, just a really efficient settlement mechanism for payments anywhere in the world, whether within a country or across borders. And Beam's enabling both those. We certainly have people who use Beam for remittance-type use cases, but the use case that we're really seeing growing quickly is people in places who want access to dollars and want a really seamless payment experience with dollars. And we can provide that for them with this non-custodial wallet using stablecoins.
Super helpful to go more in detail into that. I would also like to hear more about David, when you say that you're enabling fans to kind of participate in the creation of the music that's happening on Hume, like how is that happening? How does that compare to traditional music that maybe the fans are less engaged in the creation process?
So the way traditionally there's a record label and there's like usually what actually happens is one guy, the artist will make a bunch of songs and the artist might think something, there's a great example of this with Eminem. Eminem makes the whole Marshall Mathers LP and it's really dark, if any of you remember that album. Very dark album, and the label heads were basically like, we're not gonna release this album as is. And the last song he had sent, they were like, we need a single. He sends them The Way I Am. And they're like, no, this isn't it. So they get in a big fight. Eventually, because he's Eminem and has that kind of clout, they were able to get it through. Obviously, The Way I Am was a massive song. It wasn't too dark. And the label heads were wrong. So when we were thinking about this for virtual artists, we were like, the fans know best. The fans know what they want, and the fans know they're the ones that are going to drive the initial consumption of that song at first, especially like you were saying, blockchain native people, crypto native people are very passionate when they have early access to something. So when we built this platform, if you've collected NFTs from our artists, if you have the Hume Genesis NFT, you're able to go through a token gated experience, listen to in many cases it'll be 2 songs that haven't been released yet, and decide what that single should be. And when we get that signal of like what this single should be from our fans directly, who are literally invested in this artist, they've been collecting music from this artist from the beginning, that is way more powerful than me or Jackson, who I work with, sitting there and being like, yeah, we're gonna release whatever song next. I'd much rather have an experience where our fans are telling us that.
Cool. So I would like to hear what you guys are most excited about in consumer crypto this year. Like what trend or what are you watching that the audience should pay attention to?
Yeah, I can jump in. I mean, I think a couple things for me. One is a meta thing that I'm really excited about, which is like Mona and Hume, companies building on this technology, not describing themselves as crypto companies building crypto products, but just companies building products for users, which I think is a long time coming. Like we've been going, I don't know about you all, but I've been going to these industry conferences for a long time now. And when every company describes themselves as a company building on this technology rather than a company building for some type of user or some actual consumer or someone who wants to use it, it just doesn't make you feel good about the future of it, because the way to make a successful product is to have a user focus, to actually think about who you're building it for and build it for them, rather than think about the technology you're building it on, which might be really cool and might be worth talking about, with your team or whoever. But just getting to a place where these companies are actually talking about themselves as I'm building for this type of person is really exciting, and I feel like I'm seeing that now. And now more and more companies that happen to be building on this technology describe themselves not by that, but by what they're actually building. And the second thing I would say is I just feel like we're finally at the moment where, for a lot of reasons, consumer crypto is actually possible. The proliferation of roll-ups and alternative L1s and L2s that are fast and cheap is a huge boon to that. Account abstraction on Ethereum being live as of ETH Denver last year is a huge boon to the experience that you can start to build for people. And so it feels like a lot of the foundational technology that we've needed to get to consumer crypto being viable for people beyond the earliest adopters is here. And now we just have to go and build those really great experiences for consumers and compete in the marketplace of ideas. And that's a much more exciting place to be than being crippled by the technology.
Yeah, to quickly build on that, I was around in 2017. I'm not a dev. There was only so much I could do. Now, if you have a consumer idea, that infrastructure's been built out, and I can actually have an idea of like, okay, we're going to use hoodies as a way to directly engage with fans. We're going to, someone can go out and create a fashion company that has an entirely new way of engaging with the people who are building that brand than what was possible 5 years ago, because the fees were too high, it was too confusing getting a wallet. Those two things on their own are why it's going to be possible for culture to come on chain. And if culture comes on chain, you have everybody from a 14-year-old going to a concert to someone in their 40s who are buying a really expensive piece of luxury clothing, getting Trojan horsed into coming into this ecosystem?
Yeah, definitely really excited for different chains where you can that actually enable faster transactions, cheaper transactions, that enable more use cases specifically for gaming. Really excited for crypto gaming. And specifically for what we're doing, really excited for more use cases in spatial computing, augmented reality, and for people to see the value in 3D assets coming up this year.
Awesome. I think that's all the time we have. But yeah, it's been really great to have this panel together today.
Thank you so much.
Thank you.
Thanks everyone.